Okay, does this work again? And why is it the wrong window? Okay, it doesn't. Live. Okay, but we're live again, right? Yeah, we are. Okay, good. Perfect. Perfect. I don't know what just happened. My OBS just crashed. But yeah, let's go again.
Jump, because it's colliding with two colliders at the moment. This little fictional sphere now that we've got is colliding with the capsule collider. Here in the scene view, we can see it's colliding with this green collider here, and it's also colliding with this green collider here. So the collision.
What I just wanted to say is that I'm not a big fan of this equals 1, because if there's some way that this value turns into 0 because of I don't know what bug or something, then I would like less or equal to 1 more, but we're just following the tutorial for now.
When we're touching the ground is 2, the little fictional, because remember now that at this ground check position now, imagine that there's a little fictional sphere about that size now that is checking how many overlaps am I doing. And when we're on the ground, it's 2 overlaps. When I'm in the air, it's only overlapping this one.
Okay, but
maybe
now
the
it should work,
best
right?
way to do it would be to separate the player into its own player layer here. So for the sake of completeness, and
but this is weird. You can
make this.
Oops. You can see if I jump and drop down, I just drop down. But let's. Okay, I can't zoom in more. But if I now press jump the whole time, you see that I'm not just dropping at the bottom, but I'm kind of like jumping, dropping and jumping again.
So a little bit longer.
Looks a bit weird.
That method as well, so you can learn that one. Layer filtering is something very useful that you probably want to be using sometime in the future. So let's create a new layer here. We'll click the player here, use the drop down, click add layer.
Player.
And here we'll click the player here, use the drop down, click add layer, and here let's just call it player. There are a few built
user layer 8. Okay.
Thin layers here that you can't change. So let's just pick the first available one, which is number 8. And when you define a layer, this is also something I mistake myself on quite often. It doesn't mean that we actually gave this player that layer now. Because when I go back to the player, we only define the name for it. So we have to go back here, and then in the inspector, we'll do the drop down and then change it out to player number 8. And now it's going to ask us if we want to do the children as well. And yes, we want to change the children. And that basically sets this one to the player as well.
Ground check transfer. Yeah.
So now we've separated this capsule collider. Now we'll be colliding on this layer. But if we go to edit and go to the project settings, we can see here in the physics, we scroll down a little bit, this player layer has appeared here now, and you've got this weird collision matrix. And here you can actually tick in and out which colliders should be colliding.
Oh, player and player.
But I'll leave this one here for now, but know that it exists at least, that you can define which layers should be colliding with which here. But for our case here now, let's go back into our little script, and then we want to change this. We don't want to be checking the length now, how many colliders we hit. We want to be using this layer mask name now. And to make it as simple as possible, you could actually type in loads of weird code here to generate your own mask. But to keep it simple, let's just call it player mask. And this one's not defined, so it doesn't know what to do with this word. But remember, we can press Control period here and then generate field player mask.
No, I can't.
And when we scroll up here, we can look that it's an integer here. But let's change this from a number to a layer mask. Yes. So that's actually a thing called layer mask here. And again, we want the length here to be 0.
Layer mask, probably like this one, right?
A thing called a layer mask.
Yeah.
Here. And again, we want the length here to be 0.
Oh, wow.
Now it shouldn't really be colliding with anything soon. But we also have to define this player mask. And this one is a private now, and we want to expose this one into our inspector. So let's move it to the top here. It doesn't really matter where it is, but I like to keep them grouped together. we'll copy this serialized field here. Now we'll tab back here into, and then see. We've got, this one is exposed now, called player mask. So let's drop that one down. And let's try to click here, player.
Uno momento. Okay. He's on player and then player mask, yeah.
And let's see if this works. Press play, space. We can still jump in the air.
Oh my god, I still was on play. Yeah, but it wasn't that much. That's I have to do again. This is actually annoying. Already annoys me. Wait, what? Okay, clear. So now I press save and we can play hopefully. And my window is messed up. Is my window messed up? Better like this. Better like this, okay. Well, we can jump now, but we can still jump in the air.
And then it probably means that we thought about it the wrong way. We're actually checking if it's colliding with player, and we wanted to check if it's colliding with everything except the player. So let's do everything first on this player mask, and then let's untick player.
Okay.
And then press play. So now we're actually doing it the proper way here as well. We've successfully implemented a layer mask.
I still was on play, come on. Yeah, okay, now it works. But we still have this weird bounce when I spam space and we get to the bottom.
Expecting that it's going to be collided. The reason why I didn't really want to assume that it was going to collide at all times with one collider, at least, is because imagine if this player also carried a weapon or something, or maybe it had colliders for its shoes or some armor. Then it's difficult to know how many colliders should it always be colliding with for it to be assumed to be in the air. And now we could revert our code here back to 0. And it's because we're actually ignoring all the overlap collisions that we did for the player layer. If you don't understand this fully,
Okay.
it's perfectly fine.
What?
Overlap collisions that we did for the player layer. If you don't understand this fully, it's perfectly fine. Don't worry about it. I just happened to show 3 different methods to solve the same type of problem now, or how to address the same problem. And again, there's multiple more as I could have shown, but let's just leave it like this for now. It's long enough as it is probably. But as
I think we don't need more.
I realized that when I'm playing now, it's quite nice to have the control in the air, because now when you steer, it's a little bit strange. If I press play again, I think it's quite common in platformers that you should be able to steer in the air. Okay, you shouldn't be able to double jump all the time or triple or quad jump. But at least when we come here, we want to be able to change it here.
Yeah,
so because what if I would steer a little bit in the air?
We can just
if I jump here and press side, nothing happens. And if I press, it's just a little bit awkward. So let's leave the movement for side to side movement. Let's make that possible still.
That's because this one is at the bottom.
We can just change the order here.
And this needs to be at the top.
Let's Control X this line.
Oops.
And then move it to the
Code
top
order.
here. So it's always going to run the side movement script here, the horizontal input script part. So now
it should work.
Make sure Control S to save it, and then press play again. And now we should have, now we have the steering ability in the air again. It's a little bit more platformy this way.
Yeah, let's go.
Here and change my mind here in the gap. Oh, here's our next bug. So bug number 3 we have to fix.
What?
I'm keeping D pressed now.
Wait.
Depressed. I'm not depressed, but I'm keeping D pressed, moving
okay.
right. So the capsule is actually sticking to the wall now. Even if I let go of the key, it tends to stick a little bit. So we can fix that by, there's something called physics materials as well. And if you can see here in the collider, it's got material, physics material, and it's got nothing here. So let's go back here into the project, into our assets folder, and let's create something new here. A new folder called phys materials. And they're very different from the other materials that we created. Those were just to render objects. This is going to tell the physics engine how much friction and bounciness something has. So here, let's right click, create, let's create a new physics material. And let's call this one no friction. And here we can see dynamic and static friction. Let's just set those to 0. And then friction combine, because it'll take my value of 0. And then if I'm colliding with a tile that has 0.6, it'll take the average of that, which is 0.3. But we want to change this to minimum, because we always wanted to pick the lowest, which is going to be 0 in this case. And then we go back to the player here, scroll down to our rigid body, no, to our capsule collider. And now we can drag this no friction physics material onto this one. And that should hopefully address the stickiness problem that we had. Yeah, so now even if I'm moving towards the wall, the friction is going to pick the lowest, and its own physics material has 0 friction, so it's just going to slide you right off there. Now maybe we want the camera to...
No way, I just missed. Okay, yeah.
Follow the player. So how do we do that? We've just been working with a static camera. Let's add some more floor tiles first. I can collapse these a little bit. And let's just create a little bit of a level here. So I'll select this object here, the floor tile, press Ctrl D to duplicate it. Hold the Control key to snap it nicely into segments here. Move it up maybe.
Move it there.
Scroll it a bit light. Control D, create another one. Control D, maybe lower that one down again. And now we want the camera to follow the player. Let's press play again here and see.
Wait a sec. Okay. Somewhat like... Okay, maybe this is a bit too far away. So like something like this. Then maybe here. Can't really see because the perspective is a bit messed up, but yeah, should be fine. Looks good.
So here, see, it's a little bit boring. It wouldn't be so much fun if you just ran off screen, and you can't even clear that jump. So maybe we should also increase the jump height a little bit. Let's do that straight away. Let's increase the jump height to 10 here.
Was close though. Jump height to 10, okay.
So we can make sure that we clear. Okay, that was probably too much. So even if we just double the number, actually it has more of an impact when it's in the world of physics. So let's put maybe 7. Let's try that again. Making a game is a lot of trial and error. So that's pretty good, I think. Let's see if we can make sure that we can make that jump. Yeah, that's good. Okay, but again, what we wanted to do was make the camera move along, because you'll quickly run out of screen space here. So let's go back here. You could write a script for that, but I'm going to make it even simpler than that. Let's just take this camera now. Remember this whole child-parent relationship thing. Let's just drag the camera and make it a child of our player.
Ooh,
and
okay.
Everything looks the same, but when we press play now, the camera is actually going to follow along here with the player, because
I was still in play. In play mode.
We can see here that the local position of the camera is the same all the time as it was before, because the camera in relation to the player is not changing, but it's following this player object, and that one is moving.
Oh no.
So many times when you're making a platformer, for example, you could get away with just parenting the camera onto the player object. But then, saying that, sometimes you want to do this entirely by script instead. So there's multiple ways to do it, but we'll stick with this one for now. If you wanted to offset the camera a little bit higher up, you could press stop first of all, go to the camera, put Y to 0, press play again, and now it's a bit more centered there. Let's continue with this level. It's just Control D. Let's make a little overpass here as well. So Control D, Control D, Control D, Control D, Control D. So you can make your level this way and then start creating some new prefabs for new floor tiles maybe. Let's see if this is completable. Let's press play again. Let's see, we can get under here. Yeah, that's good. Oh, that one's impossible to make. So you can't have a level where you can't clear the gap. So maybe it would have been good to give a little bit of a ledge there so you can actually come clear and jump it there. Let's collect some coins as well. But in our case, it's not going to look like coins. It's going to look more like white Pac-Man pills. But the mechanic will be pretty much the same as coins. Let's right click here in our hierarchy and create a new 3D object. And this slime, and this time, let's just create a little sphere. And that threw it into this position for whatever reason. Let's reset that one back to 0, 0, 0. And then hold the control key and slide it up to maybe there.
Oh.
And that's one.
Thanks. I forgot how to move, but shouldn't be big of a deal.
One big Pac-Man pill, so we don't really want to have that size. So let's resize it. Maybe 0.2 is good. Yeah, that'd be all right. We could even create a new material for this one. So let's go to the materials folder, right click, create, new material, and let's call this one coin, and then make it yellow. Here we could also do, instead of just making this, if we make this yellow here, see it's, oh yeah, we have to actually drag the material onto the coin itself, even though it doesn't look like a coin. But we've got a little dot here now, a yellow dot, but see that it's still applying shadow to it.
At
you
least
could do this, you could tick emission here.
Emission.
Yellow. So you could play around with that a little bit as well to get the look that you want. So it nearly looks like a coin now, even though it's a ball. But let's just leave it like that for now. Maybe we move it a little bit to the side here so you don't collect the coin straight away. And then we'll also rename it here so it's not called sphere. Let's call it coin. And we should also move it into this.
Oh, this is a bit shiny
level, so we can hide it away because it's really part of a level, this coin. But it's still visible here and everything like that. And remember that we created layers before, and that will come in really handy again. In the layer here, let's add another layer, and let's call this one coin. And then we'll go back to our little coin game object. And remember, we have to...
What was it? Layer 9, okay. Hey Felix, was geht? Sorry, ich habe gerade... ich war gerade etwas fokussiert. Bist du noch am Start?
And then we'll go back to our little coin game object. And remember, we have to change this layer here again to coin. And now this is on a separate layer here, but it still looks pretty much the same. I can Control D this one, move it to here, Control D, let's put one in the air up here, hold the Control key.
Okay, no, it worked.
E to snap it, Control D again, let's put it here. Okay, so what would happen if we press play now?
Was hast du geschrieben? Das ist schon lang her. Oof.
Try. So I come running here and then, oh, I bump into the coins. I don't really collect them, but they're more like part of the level. So to fix that, what we could do is we select the coin here and we want to change the collider here to a trigger instead. Is trigger.
Trigger? Okay.
And now we didn't use the power of prefabs, unfortunately. See? So that's why we should have really done this as prefabs instead. And you should try to do that as early on, because what I'll do now is I'll...
Warum YouTube? Weil ich versuche meinen... Nicht sehr lang, okay. Weil ich versuche, meinen YouTube-Kanal zu growen und deswegen eher auf YouTube als auf Twitch stream.
I'll delete these. And then I'll select this one again, and let's make this one a prefab. So we go to the project folder here, prefabs, and then drag this coin into the prefabs. And now we've created a prefab out of it. Now the prefab already has the correct layer here, the coin layer. So now when we duplicate this one, it's going to be, all of these will have the coin layer onto them. So what we changed here, which was really important, is we set it to isTrigger instead. And that basically tells the physics engine that it should register a collision, but it shouldn't make a physical interaction between those objects. So it still won't collect them, but at least they're not stopping me. And in the code now, we can detect this trigger. Remember that we did on collision enter before? There's another one that's very related to that one, another mono behavior called
Bro. Okay, you saw it in the tutorial, but I think I just streamed like 5 minutes of VS Code where I just did something in Unity and not in VS Code. Unlucky.
On trigger enter. And if I press tab, it'll auto-complete it here. And it'll say collider other. And this is actually the collider that we're colliding with. And remember that this player component is running on our player. So the other collider in this case will be the trigger that we're colliding with. And that's going to be the coin trigger. But still, nothing is really happening yet in the code here. So we need to check the layer of what we've just entered the trigger of now. And to do that, we do if other, which is the other collider now. But we actually need to reference the game object that that collider belongs to. So we can type game object here and press tab.
Still don't get these auto completions.
Of that game object. So everything is like basically a hierarchy of things that you can traverse up and down. So we press tab there. Okay, which layer number was it? Because this is a number. If we hover here, we see that int it says, which is an integer, and that's a whole
was 9.
Like 1, 2, 3, 4, 5. And if we alt tab back here, we can see that the layer coin here is number 9. So we can do if layer is 9 equals, remember the double equal sign?
Oh, true.
Open and close squiggly brackets. So if it is 9 here, what should we do? Let's just destroy the coin. Destroy other, but remember other is a collider, so we need to reference the game object. We want to destroy the game object.
Destroy is a function?
Object.
Okay.
Control S. So now we're saying, okay, I've entered the trigger of a collider, and the collider we can access by this other variable or parameter. And then we have here if the other collider, and then we reference the parent game object that that collider is belonging to, and then we're looking at the layer of that game object. If that equals 9, then we should destroy the other game object. It's very important to have other.game object, because if I just wrote game object here, I'll destroy myself. And now you can see that we're actually collecting these coins now.
Okay, let's test if it works. Okay, you see it? Let's go. It doesn't. Well, because why doesn't it? Oh. Why doesn't it work? Did I save? Maybe now it's okay. Maybe now it's working. Let's see. Okay, I didn't save.
And here you could start adding stuff like adding a score, for example. Maybe it's not, maybe you want to have a coin collecting and stuff like that. You can just put here and have a variable increasing. Every time you destroy a coin, could collect it, maybe get a point, a score. But instead of adding a scorekeeper now, let's try to do something different. So maybe we'll give the player a super jump every time he collects a coin. So let's define a new variable up here. And this time it's going to be an int, an integer, which is a whole number, like 1, 2, 3, 4, 5. And let's call that one super jumps remaining. And by default, this will have a value of 0 because we're not initializing with anything. So it's going to be 0 in the beginning.
Interesting, because in pretty much every programming language, or at least in Swift, I know for sure, if you write it like this, it's just nil or null or whatever. Okay, viel Spaß, Felix.
So here, when we have the on trigger enter, and we've checked here that we're colliding with a coin, then we can do, not only do we destroy the coin object, but we also do super, and remember you can press tab, and then we'll do plus plus. And that's a strange thing as well, but that means increment by 1. You could also have written plus equals 1. That's also a way to do it. And if you wanted to
increase it
by 2, for example,
+1.
then you'd give it 2 super jumps this way. Let's just give it 1 for now. So super jumps remaining ++ means that we're incrementing this value by 1. And then we can actually use this value here. So when we're doing the jump check here, let's see, jump key was pressed. We've got something adding here. Then we can actually define a little temporary variable here. And you can do that in here, straight in this method. You can type float jump power equals, let's default this one to 5. And you don't really have to type this F here if you don't want to. It's only if you type a decimal point, like 5.2, for example, that you need the F. So we could just set it to 5 now, but internally it'll actually write it 5F. Let's just keep it at 5F. And then what we'll do is if super jumps remaining is greater than 0, and here we'll do jump power, and here we'll do jump power.
Wait, what was funny?
Remaining is greater than 0. And here we'll do jump power. And here we'll do jump power times equals 2.
What was funny?
And that will take the jump power and multiply it by 2. And then we also have to do super jumps remaining minus, which is a way to reduce it by 1. So what's happening now? If we press the key, it's always setting the jump power by default to 5. But if we have any super jumps, it'll double the jump power. And then it'll decrease the number of super jumps that we have remaining. And we also have to replace this number down here to jump power, because we had it to a fixed value of 7 before. But now it's actually going to be back to 5, so it's not going to be able to clear those height jumps. But if we have a super jump power, then we can do it. So let's go back to the game and press play. Let's move, jump, clear. And now when I jump, I should
save before going back to the game.
Have a lot more power. And every time I collect one of these coins, I'll have that super power. And here we should be able to clear it. So now instead of adding a score counter, which you could have also done, we've actually given the players some super jump powers. I should also mention that for the overlap sphere, there is actually one called check sphere as well. And that will return a bool that we already know, true or false. But I wanted to show you this overlap sphere as well, because it's quite common that you want to access which colliders you're colliding with. And with this overlap sphere, you have access to those.
Okay.
But theoretically, you could have done a check sphere here as well, which would return a true or a false. To continue the level, you could just keep selecting these tiles, pressing Ctrl D to move them. I usually hold the Control key to get this nice snapping feature. And you can also block select by just click and dragging here, and then press Ctrl D to duplicate the whole block and move them up and down. And I press Ctrl S to save this scene, and I collapse this level, and I can collapse.
Okay, yeah, just let's add some more blocks. Ctrl D and something like that. Maybe like that. We don't have any super jumps left here. So maybe like this. Then maybe these two. Let me do like this and then copy them, move them, maybe something like this. Okay, yeah, sure.
That's this one as well. And in the root here, we've just got quite a nice, tidy hierarchy now. We've got the level and we've got the player. And then we could, if we wanted to duplicate these coins, Control D, make sure we put a super jump here. Control D, we'd need to put one here. And then you want to play test your level to make sure that you can actually complete the levels as well. Okay, we're going to finish off now. This was a very detailed video that produced a really horrible looking game, if you could even call it a game. But that's beside the point a little bit, because what you've gained now, hopefully, is a foundation that you can build upon. I'm hoping that it's given you a little bit of a confidence how you can navigate in the UI, what the different things do, what a game object is, what a transform is, and even how to create your first C# script. And hopefully that won't scare you off too much. There's so many more things I wanted to cover, and I'm going to build a lot more Unity tutorials, but this one is going to be the most basic Unity tutorial I will ever make. I often get the question, how did I get started with Unity and how did I learn how to make games? And this is exactly how I started. I started with something really, really primitive, and then I built on that. I asked myself questions over and over again. I asked myself a lot of can I questions. Can I create a simple capsule that represents a player? Can I add gravity and make him jump? Can I make him move left to right? Can I add more objects for the level? Can I model the objects in Blender instead to make them look nicer? Can I add some impact effects when the player lands? Can I make some sort of a suspension bridge by connecting joints? And can I model a character instead? And can I make the character walk, do a walk animation? And can I improve that animation and actually make a run animation instead?
Oh shit.
Can I model some weapons and put them in his hand? Maybe a sword and a shield? Or can I model a gun and have him shoot? Maybe even in the direction that he's aiming? Can I add some sound effects maybe to make it sound like he's shooting? Can I switch to a two-handed weapon, maybe a shotgun? Can I switch to a laser weapon that maybe ricochets the bullets when it hits something? Can I switch to a minigun to make a lot more bullets fly all over the place? Can I have him aim over ledge it and have it pointing down? Can I make a grenade launcher maybe that fires stuff that will explode and send some shockwaves? Can I add a background, maybe like a gradient sky? And can I add more details to the background, maybe like mountains? And can I have some sort of a parallax effect by including more layers of backgrounds? Can I add a waterfall, maybe a low poly style one? Can I add some clouds? Can I even add some cities in the background or spaceships? Can I add some blurry effect by applying some post-processing? Can I add some smoke or dust where he runs? And can I even add maybe some lighting effects when he shoots, like a muzzle flash? Can I have some impact effects as well, where the bullets hit, maybe? And can I add some objects that he can actually hit? Maybe in the future I can also add some power-ups that he can collect. Can I make a reload effect? Can I make a ragdoll out of him if he dies, maybe? So ask yourself the question, can I? And take it from there. Behind all of these can I questions are hundreds and hundreds, if not thousands of hours of Googling, trial and error, prototyping, looking in the documentation, looking at YouTube videos, doing more trial and error, YouTubing.
Yeah, this sounds like programming.
That's how I learn. I just repeat it over and over again, and I learn little by little over time. In a similar way to this, I actually learned how to use Blender about 5 years ago. I started by trying to modify the default cube, and by now I can actually do about 10 cars in 10 minutes like in this video, or I could do 5 rigged characters in 10 minutes as well. And that's just from practicing over and over and iterating and getting better over time. So if you want to make games in Unity, my advice is start extremely simple, allow it to look terrible, repeat and iterate time over time, and do the same thing over and over again and improve, and have patience. And I also have to say that I think it's really important that you enjoy making games. If you find this to be quite boring, tedious, or if you want to just put it away and do something else, then it's going to be quite a struggle. But if you enjoy it, if you enjoy making small steps, a little bit of progress, and seeing what you can do next, then you're on a great track. I think you're going to do just fine making games. Hit the thumbs up button if you like this video, and don't forget to subscribe if you want to see some more game dev stuff about Unity, Blender, 3D, low poly, you name it. I've also got a Patreon page if you want to drop by and give that little bit of extra support if you can. And check out the description for some merch as well. I've got some t-shirts and hoodies and stuff like that. Until next time, have a great one, and I'll see you then.
Holy shit. This was honestly a fire tutorial. Really good made. He just explained the basics pretty well. And also gave like a roadmap here where you can improve and how to improve basically. And yeah, I enjoyed that a bunch. And I think I have like some basics now. I mean, not that much, but at least some basics and hopefully enough to now make a game, because now I'm trying to, I mean, with a tutorial, yeah, but I'm now trying to make my own first game, but just after I go to the toilet, because I actually need to really bad. So be right back. I'm back. And give me a second, because I already looked up a game that I want to make. And it's this one. Looked pretty cool. It's like a 2D platformer. And it looks doable. From the tutorials, it looks like it's around 4.5 hours for the whole thing. So, looks pretty good. Looks doable.
So, Android development is boring me to death, and it's time to try something new. So in this video series, we will learn how to build a game in Unity from scratch. Let's go. So let's take a look at the game we will build throughout the series. So we have this starting screen here. And then we have this typical 2D platformer game where we can walk around, we can jump, we can collect items. We have different traps, and when we hit any of these traps, we die. And then the level starts over. Like this, which was totally on purpose. And this was on purpose as well. So let's try this again. And when we get to the end of a level, we load the next level. Which looks a bit different. Okay, we have to wait for this platform to come back. In the top left corner we have a counter for the cherries we collected. And of course you can build these levels any way you want. That's absolutely open to you. And in this example, I've only created 2 levels. So after the second one, we get to the end screen, and then we can only quit the game. You don't need any programming experience to follow along in this tutorial. I will try to make it very beginner friendly. So if you have never written a line of code before, don't worry, you can still follow along. I will also upload this project to GitHub, so you can download it from there if you want. And you will find the link to the repository in the video description below. So let's start.
Maybe if there is some error, we can look in the repository.
First of all, of course, we have to install Unity, and you can download it from...
Okay, install Unity, Unity Hub, creating a project. Okay, let's see. Let's maybe play this back at 2 times speed.
Installing, we can create our project. So here in the Projects tab of the Unity Hub, we click on New, and then we have to make some settings. So here we select 2D. I will cover 3D games in a separate tutorial in the future. In this video series, we will build a simple 2D game. Now you can ignore this other stuff here. Again, I will cover how to create games, particularly for mobile devices.
Okay, new project, 2D.
Later in a separate tutorial, but for now we select 2D, and then we have to give our project a name. So for example, Coding in Flow 2D tutorial. We have to select the location where we want to save this project in. I will leave it like that, and then click on OK. And then again, we have to wait a bit until it's finished loading, and then we are inside Unity, the Unity editor. Now this program really looks scary in the beginning. We have a lot of different options, but don't worry, a few weeks and you will feel at home here. Just follow along in this tutorial and everything will be fine. So in the middle here, we have the so-called scene view. A scene is basically a level. So we are looking at one level here. Of course, right now our level is empty because we haven't added anything yet. Only the main camera is there, which is there by default. Now when we selected 2D instead of 3D earlier, it actually just changed a few settings. We could still create a 3D game in here without a problem, but we don't want to because we want to build a 2D game. But when you click up here on this 2D button, it will switch to the 3D view. If this happens to you, it can be very confusing because it makes it harder to create a 2D game. So if your view looks like this, suddenly then just click on this little 2D button here again, and it should switch back to the 2D view. Now you can move around in the scene viewer by holding the middle mouse button down and dragging your mouse, then we can pan in all directions. Alternatively, you can click this little hand icon here in the top left corner, and then you can pan around by holding down the left mouse button. And with the mouse wheel, we can zoom in and out. Now we have more controls up here with different functionality, but we will learn what they do and how we use them throughout this video series. One thing you can already remember is that they all have shortcuts here, which are the first letter keys on your keyboard or on an American keyboard, which are Q, W, E, R, T, Y. So you can either use these shortcuts to switch between these different tools here, or you can just click.
Yeah, that's the same we already heard.
All these windows wherever you want, so it's really customizable. But remember, if you completely messed up your layout like I just did, you can always click up here on Layout and then on Default, and it will reset it to the default state.
Oh, okay.
That was too bad, was it? In the next part, we will start building our first level, so stay tuned for that. And do me a favor, if you follow along in this video series and you have a Twitter account, tag me on Twitter, write me that you are following this video series because this will make me very happy. Write something like, hey, Coding in Flow, I'm following your Unity beginner tutorial, hey. And my GitHub handle is @codinginflow. And then I hope you're having a lot of fun, so see you in the next part.
Okay, let's go. This should be the first one.
You're still here, that's great, I'm very proud of you. In this part, we will start building our first level. And when you build a 2D game in Unity, a very convenient way to do this is to use a so-called...
It's so crazy. Every time I switch from 2x speed to 1x speed, it just sounds like he's talking in slow-mo.
Tile map. A tile map...
The person in general. Not he particularly.
Is like a puzzle, which you can use to build your level piece by piece. So let's go into our Unity editor and see how this works. First of all, of course...
Program, can my project load, please? It's already loading for over 2 minutes.
We need graphics for our game. And we can actually get some really nice free graphics from the Unity Asset Store. The Unity Asset Store is like a shop for assets, for graphics and music and stuff like that that you can use in your games. And they also have free stuff. So here we click on Window and then on Asset Store to open it. Here we select Always Open.
1 sec. Just need my program or my project to load. Then we can go to the Asset Store. Why is this taking like an hour to load? I'm like at the third and I'm over 3 minutes in. I'll just let him talk.
Open in browser from menu, which basically just means that we have to open the Asset Store in our web browser. So we click Search Online. And this will open the Asset Store in your default web browser. And then we close this tab by clicking on it with the middle mouse button.
Okay.
And then it should open this homepage here, the Unity Asset Store. And here we click on Assets.
Oh, our project is loading. Let's go. Okay. The window's always messed up. Come on, man. Okay, like this, and then somewhat like this. Okay, that works. Okay. It was, wait, assets store. Always open in browser. Then remove that. Okay. Then we have it here.
And on pricing.
Oh my god. 15 windows popping up 2D. And on pricing, probably
and
0.
And set this to 0.
Where's there's pricing. 0.
Because I know you guys really hate nothing more than paying money for something. And here we have these different free 2D graphics. And this is the one we will use in this tutorial series, Pixel Adventure 1.
Pixel Adventure 1. Pixel Adventure 1. Can I search? Okay, I can search Pixel Adventure 1.
If you can't find it here, you can also try just typing Pixel Adventure 1 directly here into the search. And here we click on Add to my assets. We accept this. Then it loads for a moment. And here we click on Open in Unity.
Open Unity.
And then on Open in Unity Editor. This is German in my case, but just click on this button.
I knew
and then it will
German.
open this asset pack directly inside Unity. And it's this one here, Pixel Adventure. Here we have to click on Download to actually load it. And when it's finished, we click on Import. We keep everything here selected. Those are the different images that make up this set.
Okay.
We keep everything selected and click on Import. And then we can use this stuff in our game. We close this and then let's take a look into the stuff we downloaded. So we have this folder here, Pixel Adventure. We can ignore the scenes folder. This is just an example level basically. And in assets, we have our different stuff. We have different backgrounds. We have item graphics. And those are actually just normal files that sit in your computer.
That's completely for free. It's nice.
And click on Show in Explorer. And then we can see these files here.
Okay.
So we have this meta file with some Unity related stuff. But besides that, those are basically just normal images. As you can see, those are multiple images in one. This, for example, makes up one animation. But we will learn how this works later. Let's go back into our editor. And for now, we want to build our world. So we go back into the assets folder and open the terrain folder, which also contains 2 images. Now those are just 2 times the same image. Just one is prepared already and the other one is the raw image. Now let's actually open this in the Explorer again to see how it looks more closely. So this is an image with which we can build our world. And it looks really weird, but you can imagine this like a puzzle. So for example, we have this block here. And we will actually chop up this block into 9 different parts. So we have this block here in the middle, for example, and we will chop this up into the top left part, top middle part, top right part, the 3 middle parts, the 3 bottom parts, and so on. And then we can use this to build our world, but you will see this in a moment. First, we have to prepare this file. So back into our editor, and the right file here is already prepared for us. It's already chopped up. But since we want to learn how to do this ourselves, we will ignore this file and use the other one, which is just the raw image. We click on it so we can see the data of it, the different settings in this inspector tab here on the right. First of all, we have to change this pixels per unit value. We basically always have to change this because the default value of 100 is not correct. Now 1 unit
Nice.
is one of these squares here. And one of these squares is basically one puzzle piece. Now we have to tell the editor how many pixels of our image of each tile fit into such a square. Now when we look at the file name of this
16.
image, you can actually see it down here on the bottom right. It says terrain 16 × 16. This is pixel art. It's meant to be not very high resolution. It's meant to look a bit comic style. And the 16 × 16 already tells us how many pixels are meant to be fit into one of these units, into one of these squares. It's 16 pixels. This can be a bit confusing, but you will get used to this over time. And I will actually later show you how this looks if we set it up wrongly. But here in pixels per unit, we change the value to 16. And then click on apply. And then we want to chop this image up into the different parts as I already explained. So first of all, we have to change the sprite mode to multiple to tell the editor that we want to chop it up, not use it as one whole image, but use the different small pieces of it separately. So we set this to multiple and then we click on sprite editor. We have to click on apply if you didn't yet. This is because I just changed the sprite mode and I didn't save it. So we click on apply. And then it opens this window
on his screen.
And you can make this big. Up here we click on slice.
Wait, how did he make
opens this
big?
window and you can make this big.
Fair.
Up here we click on slice and under type we select grid by cell size. And then since we want to chop it up into a 16 × 16 pixel squares, we change the pixel size to 16 × 16. We keep the rest as it is and then we click on slice. And as you can see, now we can see these different squares. And each of these squares here is now one puzzle piece, so to speak. So we can place them in our world separately. We will see this in a moment. If we set a different value here, let's use something really weird, like 52 × 52. Then you can see now this would be one puzzle piece, but it doesn't make sense anymore because we can't build a world with this kind of piece, with this kind of grid. So we set it back to a 16 × 16, and then we have to click on the.
These extensions will destroy the current sprite and repair. To get lost, consider using smart or safe. Okay. He doesn't use that, so I'm not.
Apply here in the top right corner. And then we can close this window. And then we have to create a tile map. The tile map is the thing where we can place our different puzzle pieces on. It's the frame for our puzzle, basically. So somewhere here in this hierarchy window, we right click, go to 2D object, tile map, and select rectangular, which creates this grid and this tile map object here. And we can rename this to terrain, but you can give it any name you want.
Sure, terrain sounds good.
Next, we go to Window, 2D, and open the tile palette. You can either keep it as a float.
Wait, give me a second. Surely there's some setting that you can see these overlays. But I don't know.
Loading window like this, but I like to put it either here next to the inspector or here. And then we click on create new palette to create a new tile palette, and we have to give it a name. Let's call it terrain again, but the name doesn't matter. You can give it any name you want. We keep the rest as it is and click on create, and we have to save it somewhere. Let's save it in our first assets folder, here where Pixel Adventure 1 and Scenes is. We select this folder, and then our tile palette is here in the assets folder. Because all these folders here in the project view are just normal folders on your PC. But we go back into Pixel Adventure, Assets, Terrain, and then we take our terrain image we just prepared, the one with the pixels per unit 16, and we drag it over with the mouse into our tile map here. And again, we have to save some files that are now generated somewhere, and we will actually leave it here in Pixel Adventure Assets Terrain, but we create a new folder in here, because otherwise this will get really messy. Let's just call it tiles. Create this, and then we select this folder. And after a short moment, we will see our tile palette, with which we can now build our world.
Okay.
And now we can use these pieces here and put them on our tile map.
Oh, I can use...
Like a puzzle. So just click on them and then add them like in an image editor. This is the
Wait, what?
top right.
How did he take this one?
And now we can use these pieces here and put them...
Wait, what? Just clicked on them and then... Oh, okay. You have to just click once and then drag it over, not keep left click. Okay.
On our tile map. Like a puzzle. So just click on them and then add them like in an image editor. This is the top right corner. And then we can just build our world like this. We can also select multiple ones at once. And up here you have different controls which also have shortcuts. When you hover over them, you can see the corresponding shortcuts S, M, B, and so on. B is just drawing, which we already did. With this one here, you can select a tile to make changes to it. You can use this one here to move a tile around. It's just drawing. This one is also very useful. With this, you can draw a rectangle. But what you can actually do is, for example, select 2 tiles at once and then draw this like a rectangle, and it will automatically use the correct tile at the correct place if we drag it in the right size. But don't worry, you will get used to this. With the eraser we can erase tiles. You can also erase tiles with the normal brush by holding Shift down while you drag your mouse. And of course you can revert everything with Ctrl Z. But just play around with this, just experiment a bit. And with this tool here, you can select a tile from the grid and then draw the same tile again. And if we would now click on our terrain, tile map here again and change the value of pixels per unit, you don't have to do this. I will revert it in a moment. Let's say we change it to twice the value, 32, click on apply. Then our tiles are not big enough anymore to fill the whole square because we slice them up into 16 by 16 pieces. So how big the pixels per unit value has to be basically depends on how your tile map is supposed to be split up into single parts. As I already explained, this tile map is supposed to be split up into 16 times 16 parts. So this is what we have to use here and when we slice the sprites. And I want to mention one more time that you can switch between the 3D and the 2D view up here. We don't need the 3D view at all, but if you click on this accidentally or you click the 2 key on your keyboard, which also switches this, then remember that you can always go back to the 2D view, which we want to use here in our tutorial. But of course our world here looks a bit boring. We also need a background. And the background files are in a different folder. Also in Pixel Adventure, Assets, Background, and here you can pick any background you want. But we have to prepare these files again, because again, this is just one image, but it's not meant to be used as one image per unit in our tile map. Instead, it's meant to be used as 16 times 16 pixels pieces. So we do the same as we did for our tile map earlier. We change pixels per unit to 16. And set the sprite mode to multiple so we can slice it up, and then we click on apply. Then we go into the sprite editor, click on slice, grid by cell size, 16, 16, slice, and then on apply. Close this. And then we want to
do this every time.
Add these new pieces to our tile map here. So we drag and drop this over, put it anywhere it's convenient for you. Again, we have to save the tiles, so we create a folder again, which we call tiles, just so it's a
assets, background, tiles.
bit better organized inside our background folder.
Okay.
Open it and click on select folder. Because we have all these different small pieces here and we don't want to clog up our background folder with it. Now to draw the background, I like to select the whole thing by holding the left mouse button down while dragging, and then I like to use this rectangle brush, because then we can just do this. We can click and then just draw an image like this. But as you can already see, now we are drawing over our terrain, which makes sense because we can't put two tiles at the same place, right? For this reason, we have to create a different tile map for it in our grid here. So we can put the background in the back and still have our terrain in the foreground. So we right click on grid, go to 2D object, tile map,
rectangular, I guess.
And let's call it background. And now here in our tile palette, we can actually switch between our different tile maps, background and terrain. And always make sure that you have the correct one selected, otherwise you will mess up your layout. But again, you can always revert this with Ctrl-Z. And now when we select background, we still draw over our tile map, because the editor doesn't know which one is meant to be in the foreground. We can change this by applying a sorting layer. So as you can see, the sorting layer of our background right now is default, and the same for terrain. When we click here, we can add a sorting layer. Let's call it background, just like the tile map. Again, the name doesn't have to be the same, but it makes sense. And let's put it behind the default tile map, because by definition, the background is meant to be in the background. And this is the order.
Fair.
And then we create another sorting layer, which we call terrain. You can also call it foreground or whatever you want. And we put it below default. And then we click on our background tile map and set the sorting layer to background. And as you can see, our terrain appears again because the terrain is in the default.
Wait, what? He clicked on what? On background. And sorting layer to background. Okay.
And then we click on our background tile map.
Oh, wait. Just so that this needs to be this. Yeah, okay. This is terrain.
And set the sorting layer to background. And as you can see, our terrain appears again because the terrain is in the default layer at the moment. But we make it more explicit. We click on terrain and set the sorting layer to terrain here.
Yeah, obviously.
And now we can draw these two tile maps independently from each other. We can draw the background in the background, and we can still draw the terrain in the foreground. You can imagine this like a sandwich. The background and the terrain are on top of each other, like two slices of paper. Let me just make this a bit bigger. So I draw the background a bit bigger.
Okay.
As you can see, I just picked the wrong tile map here. I'm drawing on terrain, but I want to draw on background. So let's try this again. I'm going to make this a bit bigger like this. Then I switch back to terrain. I place these three over here, and then I set up the middle part. Nice.
Oh, fair.
Now let's create our player. For this, we right click in our hierarchy again. Create a new 2D object, sprites, square.
Wait, wasn't it like, which one of those was this one, and then you can, no, this one, and wait, it was,
I placed these three over.
Oh, okay, you just made new ones. Okay, I see. Just pick these ones and then put them over here and then... Oops. And then create it like this. What is that? Okay, but it looks fine.
Over here, and then
I don't know what this weird...
I set up the middle part.
Oh, it's because
Nice.
of the camera.
Now let's create our player. For this, we
Let's
right-click
go.
in our hierarchy again. Create a new 2D object, sprites, square. Attention, we don't want to nest this under grid because it's not related to our tile map. This is supposed to be a standalone object. Then we want to rename this either by right-clicking and then clicking on rename, or on Windows you can just press F2 and let's rename this to player.
Press again.
Now when we have this selected and we put the mouse over our scene viewer, we can actually press F on the keyboard to zoom onto this object. It's a bit close, so I have to zoom out again, but this is our player. I know it doesn't look like a player yet, but it will be one later. First of all, I want to move this object somewhere else. So up here we have this move tool, for which the shortcut is W. We select this, and then we can either move it with these arrows here, or we can click on this little rectangle and move it wherever we want. Now the sorting layer of this item is default. And remember, default is in front of the background, but behind terrain. So if we drag it down here, it actually disappears. But this is fine because our player is not meant to be in front of the terrain. Now when we select player here in our hierarchy, in the inspector on the right, we can see that we have this sprite renderer tab here. And what we want to do is we want to go into assets, pixel adventure, assets, main characters, and I'm going to use the virtual guy here. And we want to go to idle, open this and select the first one. But we select player again. And then while the player is opened here, we drag and drop the idle graphic and put it into the sprite tab here. And now we can see it in the preview.
Ooh, but he's small.
But as you can see, it's very small. And maybe you can already guess why. Because the pixels per unit value of this image file is set up wrongly. So let's actually change all of them at once. So we can select all by holding shift down, and then we click on the first one and on the last one. And we change pixels per unit to 16 here as well. And then 16. Our player grows. Nice. And everything here in our hierarchy is an object.
Did you change the spread mode to multiple? Oh, you can't actually.
And everything here in our hierarchy is an object. So our camera is an object, the grid is an object, and the player is an object. And the way this works in Unity is that we give behavior to these objects with so-called components, which you can see here in the inspector on the right. All objects have a transform component because this gives the object a position in our scene view. But the other components depend on what we want to do with it. So we have our player item here, which is a graphic on the screen right now. And to draw this graphic, we have this sprite renderer here, which was automatically added when we selected 2D object, sprite square. This added the sprite renderer. When we created our tile map, we got a game object with some different components. Here we have this tile map component and the tile map renderer, which gives this whole tile map puzzle functionality to this object. We could also just create an empty object here and then add these different components ourselves. This down here is just convenience. It's meant to make the setup a bit faster for us.
That I understand.
And when we select our player here in the hierarchy and click on add component in the inspector, we can add more components to it to give more behavior to this object. And there are many different components already prepared for us by Unity, which we can use. Very important, for example, components to add physics behavior, because of course you don't want to always code all of the physics logic from scratch when you create a new game. This would be extremely tedious. So a lot of this default stuff is already prepared for us, and we can just fine-tune it to make it appropriate for our game. Let's look at an example. Right now when we start our game, our player just floats in the air because it doesn't have any physics yet. To add physics, we select our player, add component, and we want to add a rigid body. And when we create a 2D game, we always have to pick the 2D version here. Otherwise, this will not work. So rigid body 2D. And now when we click play again, our player falls down because now it has physics applied to it, just by adding this component. And as you can see here, we have different settings for this rigid body. For example, we can increase the gravity scale. Now when we play again, it should fall faster. Yeah,
it just disappears.
It actually falls through our terrain because we haven't told the editor that this is meant to collide. We have to do this with separate components. So let's set this back to 1 and add a new component, which is called Box Collider 2D. Again, important the 2D version. This will make it possible for two objects to collide so we don't fall through our map. And here we click on Edit Collider to set the boundaries of our collider, which is this green box. And let's make it a bit smaller than the player itself. It just feels a bit better usually. Because we don't want to collide with a wall right at the corner here. Instead, we want to have a bit wiggle room basically. So I think like this, it's nice. And also later when we collide with an enemy or a trap, then we don't want to die as soon as we hit the very outer part here. So we drag this collider a bit into the middle, and only at this part, at these boundaries, the collision will be detected.
Interesting.
And let's also drag it a little bit into the feet here, so it looks better. But when we play it, it will still fall through. Because this is not enough, we also have to give a collider to our terrain. So we click on terrain, and for a tile map we have a separate tile map collider, which will automatically create the boundaries depending on the form of the tiles. So as you can see, we have these green squares now here. We can actually see it better by hiding the background for a moment, which you can do with this eye icon here in the hierarchy. We can hide it, and now we can see these green squares. And let me actually put the tile map here so the scene view is bigger. Now one more thing, right now each of these pieces in our tile map has a separate collider, which is not great performance wise, and I think it can also make the game a bit buggier. What we want to do is we basically want to merge this into one big collider, because why do we need these squares in the middle? They don't have any purpose.
Kind of, yeah.
And we can do this with a newer component, which is called Composite Collider 2D. We add this, and then here in our tile map collider, we select used by composite, and it merges the collider into one big one, just like we wanted.
Wait, what?
Tile map collider, we select used by composite.
But he also has a rigid body on the terrain? Why? Oh, I also do have a rigid body on the terrain. Okay. Never mind. But I still...
Tile map collider.
Didn't hear what he said.
We select used by composite. And it merges the collider into one big one, just like we wanted.
Perfect.
But now when we click play, our world falls down with our player. Very funny. This is because the composite collider automatically adds a rigid body to the terrain, and a rigid body has physics, right? We already learned this when we added the rigid body to the player. But we can click on terrain and change the body type of the rigid body of the terrain to static, which means that it can still function like a physics object, but it won't have gravity applied to it. Now
it won't fall down.
Our player will fall down, but land on the terrain. Nice. Of course, we can't move yet because we haven't set up any movement code yet, but we will do this in a moment. One more tip, you can see this little question mark here. With this, you can actually open the documentation in your browser. So when you click it, it will open a browser window to the Unity documentation. Now, don't get scared by this. Documentation tends to be really complicated. In most cases,
that's generally with the default documentations for programming. These are typically very like complicated and not really. They're not really explaining things to you. They're just showing how things work, not in a way that you will easily understand. Just in a way that I guess it's the least characters or like the most detail. I don't know, but it's like not an explanatory style.
It's better to watch a tutorial, but sometimes this can help you and give you some quick hints or a refresher.
That's really if you know what you're doing, kind of, and just want to know how things really work, but you generally understand what they do. Then you can read the documentation, or you generally understand what the programming language or how it does, or how the programming language works.
How stuff worked, but rather watch tutorials than trying to learn Unity through the documentation, because it's almost impossible.
For sure, yeah.
It's written by aliens. And we can also disable single components by unchecking the checkbox next to it. For example, when we uncheck the tilemap renderer, it won't draw the tilemap onto the screen, and it can be useful to do it while editing your world to, for example, see the boundaries of the collider better. So we check this back, and let's also show the background again by clicking on the eye icon again. But of course, we can only get so far with these prepared components. Eventually, you will get to a point where you have to create your very own customized behavior. For example, the game doesn't really know how we want to handle movement for our player, what keys we want to use, and so on. So it's time to create our first own component. So we click on Add Component again, and we click on New Script. And let's call it Player Movement. Now you can't add white spaces in here, so instead you usually write the name in Pascal case, where you start each word with a capital letter. So player,
typical for code, yeah,
with a capital M. Create and add. And then we have this new component down here. But as you can see, the name of the component is automatically set to a proper name with white spaces, because the IDE generates this name from our Pascal case script name automatically, just so it looks better. And then we double click on the script name, which will open the script in Visual Studio. Or
that's why I like to watch different kinds of tutorials, because in the tutorial I watched before, he just did it in a different way. But you can do it like that, or you can just create a new script directly here in Unity. Still, it's the same, but just two different ways. So you can watch different people and learn from them, and then do what fits you best.
Whatever IDE you're using. If you're using Visual Studio like I do,
can you please open Visual Studio?
There's one more step.
Wait.
Which will open the script.
You just double click. Is this do I have to change preferences here again? Oh, I actually do have to change the preferences here again. I don't know why it's not saving that, but okay. Not that big of a deal. And now it's opening Visual Studio Code.
In Visual Studio, or whatever IDE you're using. If you're using Visual Studio like I do, there's one more step we want to do, because by default the interoperability is not set up properly, at least not when I installed it. Which means that we don't have auto-completion, for example, which is really useful. So what we want to do is we want to go back into Unity, click on Edit, open the Preferences, go to External Tools, and set the external script editor to Visual Studio. And then here you select the same boxes like I did in this part, and then you click on Regenerate Project Files. And then you close Visual Studio and open it again by double clicking on our player movement script again. And then it should be set up properly, and then we have nice auto completion.
These are the things I mean. The guy before explained a lot, but for example, this particular thing he didn't explain. So I followed the tutorial, and was like, why don't I have auto-completion? And he just covered that topic.
So when I type in something here, we get suggestions for the different methods.
Okay, I still don't get auto-completion. Forget what I said.
And here we can now write the code for our script, which defines what our script does.
Never mind.
And by default, we have these two so-called methods added here. In start, we put stuff we want to happen when the game starts. In update, we put stuff that we want to happen each frame of our game. So this can be 60 times or more per second. The language we are using here is called C#. And if you already have programming experience, the syntax is very similar to Java.
Oh, okay, yeah.
And every script extends from mono behavior. This is where we have this :mono behavior up here. If you are a beginner in Unity, don't worry about this. It's not so important to understand what this does. Now let's actually see how start and update work. So what we do is we put the cursor inside start and write. And don't worry if you don't understand it yet, just follow along. We write debug. And whenever we write code, it's important that you get the capitalization right. So if I start this with a capital D, it's important that you start this with a capital D as well. And the same for lowercase letters. So we write debug.log again with a uppercase L.
Okay, this is exactly the same thing.
Then make 2 quotation marks.
The person
and
for
write hello world.
Hello world. That's
and
typical.
in C# we have to end a line with a semicolon. And then whenever we made changes to our script, we press Ctrl S to save it. Otherwise, we won't see the changes in Unity. And whenever I use a shortcut that starts with Control on Windows, the equivalent on Mac is usually the same shortcut but with Command instead of Control. So after we have saved this, we go back into our Unity project. And this will reload because it noticed that we made changes to the script. And now what we do is we click on Console and then run our game. And here we see Hello World, which is written from our start method when the game starts. The console is useful to add these little debug messages, which makes it easier to find errors in your code later. And you will also see error messages in here and warnings. So if something in your game doesn't work, it's always useful to click on the console and see if something is written here. And now let's also see how...
That's generally in programming. If you don't know what went wrong, or you don't know exactly what's going on, you can just print out the error messages or print out at different locations a message, so you know pretty much exactly what's going on, and then use like Google or maybe ChatGPT to fix the error. It's pretty helpful, yeah.
Our update works. So let's cut this out and paste it here into update.
What was it? Control X. Yeah.
Press Control S to save the project. Go back into Unity, let it reload, and then start our game again, which by the way we can also do by pressing Control P. And what we now see is a lot of these hello words.
An update. How much FPS do we have? Wait, I'm just oh, oops. Here you can see. Yeah. Oh, you didn't see it, but these error messages are getting more and more pretty fast. Okay, let's pause this, because it was like 1,000 error message or 1,000 debug messages in like 1 second. It's this error again, but if everything works, then I don't care.
Because again, this is executed every frame, so this happens many times per second, depending on the frame rate of your computer. Let's stop this. And when you create a new script, it's also written here. Start is called before the first frame update. Update is called once per frame. And those are comments. When we write 2 slashes, we can add any text we want. And it won't actually execute this. This is just for the developer. For us,
you can also
it's a note
use
for us. If we want to remind ourselves,
this.
for example, what a particular piece of code does, we can add a comment to it.
And then you can
And you
write
can delete these ones,
what
but
you
you
want
can
here.
also put them in as a reminder. And then let's remove this.
Okay, I pressed something that this just appeared. So this is just if you want to write multiple lines of comments, you can use these to and then write what you want in the middle.
This debug line here because we don't need it. And now we want to add some movement behavior to our script here. And we will start simple. In this video, we will only add a way for our player to jump. We won't be able to move left or right after this part, but we will be able to jump. And since we want to be able to do this throughout our whole game, we put it into update. Because in here we can do something in every frame of our game. If we would put it into start, it wouldn't work at all. Because then we could jump theoretically at the very first frame, but this is over almost immediately, so update is the correct place to do it.
Yeah.
And now we have to write some C# code. And if you don't have any programming experience yet, just follow along step by step. It's not too difficult. So we want to check if a certain button was pressed. Let's use our space key to jump. And whenever we want to check if a certain condition is true or false, we use an if statement with a lowercase I and a lowercase f. Parentheses. And in here we write the condition we want to check. We want to check if input with capital I dot get key with an uppercase G and an uppercase K.
Key down,
and
right?
if you set up Visual Studio correctly, you will have auto-completion, which makes it less likely to add typos. After get key, we add a
it's actually just using get key, okay.
Quotation marks, and between these quotation marks, we write space and on lowercase. This
Yeah,
way we check
using
if
a
the
different
space
way.
key was pressed. And we do this in every frame of our app, continuously, the whole time. Below if, we add a pair of curly braces. And if you are a Java developer,
Bro, this looks so weird. If it does it like this, I don't know, it just looks really weird to me.
say, what? What kind of brace placement unholy stuff is that?
Yeah.
But apparently this is how we place curly braces in C#. If you don't have any programming experience, just ignore what I just said. Place your braces like this. And if you mess up the formatting, for example, by adding too many white spaces, in Visual Studio, you can press Ctrl K and then Ctrl D, and it will reformat the code properly, which is very useful. Now we want to make our player jump. And for this, we have to apply physics. And as I already mentioned, the rigid body is responsible for the physics stuff. So we need a way to access this rigid body. So back in our editor, we do the following. And again, the capitalization is important. Get component, angle brackets, the name of the component, rigid body 2D, empty pair of parentheses, and this will give us access to the rigid body 2D of this player object by calling this method. What exactly this does is not important. This is handled by Unity. We don't have to understand the internals. We just have to use it. And then
I actually thought that this would be kind of a bit more advanced tutorial, so he doesn't cover the complete basics. That's why I watched a basics tutorial, but he does. I mean, it's some things repeating, but I guess it's fine if it's not too much.
Velocity, to change the velocity of this object, to move it
because
into a
we
direction.
already did all of this.
And then we write equals to set this to a new value. And then we write new vector 3. The vector 3 is basically just a data holder for 3 values, for x, y, and z. So if we want to give this speed in a certain direction, we have
why
to
do
say,
we have
okay,
C
how much
anyway?
speed into the x direction,
Isn't this 2D?
which
Why do
vertical.
Why do we have C?
How much speed into the
Or
y
Z.
direction, up and down. And C only plays a role in 3D mode because it's basically the depth. Doesn't matter here.
Yeah.
It's all on the same 0 depth, except for the camera, which is at -10, because it has to be a bit
Fair.
in front of the world itself. So back
That
into
makes
our
sense.
script, we now want to add these different values in what direction we want to move our player. We want to jump, so we don't want to move it horizontally, so we pass 0 for x. For y, we pass, let's try out 7, which is basically the force with which we move it up. You just have to try it out, see which one is appropriate. And 0 for the y as well, because again, we don't want to move it back and forth.
Not y.
Then we save this. And now when we press the space key, this part here should be executed. So back into our Unity editor, let it reload. Then we start it. But we see this warning here, cannot use velocity on a static body. Why? Because I've accidentally added this player movement script to the wrong object. I didn't add it to the player, I added it to terrain. But of course our terrain has nothing to do with jumping, and it can't jump since it has a static, rigid body. Of course this was totally on purpose. And now let's change this. First of all, we have to exit the play mode. Because if we make changes while play mode is active, the changes will be reset after we exit play mode. So remember, whenever you make changes to any of your objects, pay attention that you are not in play mode right now, because otherwise they will not be applied. Then we click on terrain, and we want to remove the script here. So we right click on player movement, remove component, then we click on player instead, add component, and since we already created this script earlier, we can now just search it here, player movement, and add it. This way these components, these scripts are very reusable. We can put them onto different game objects. Okay, now that I've changed this, our jump should work, so let's run it again. And when we press space, we can jump. As you can see, it feels a bit like a moon level. The gravity is very low and it feels slow and smooth. So what we can do is we can play around with these different values here.
And we can jump in the air again.
Increase the gravity scale, for example, and it won't jump as high anymore. So since we are in play mode right now, when I exit play mode, it will be reset to 1, as I already mentioned. So pay attention to that. Otherwise, it could happen that you make a lot of changes and then they are lost suddenly.
Yeah.
Now a combination of values I think feels really good is a gravity scale of 3.
Okay.
But with a different jump force. So instead of 7, we write 14 here.
14, okay.
To jump with twice the velocity in the y direction. Save this, important, with Ctrl S. Go back into Unity and let's try it out again. Now jumping still feels weird, but this is not because our values are off here. This is because we can actually just hold down space and fly off into the orbit. This is because right now we check in every frame.
Is this because we put the collision a bit higher?
If the space
that our character like bounces a bit, or it looks like it bounces a bit, or why is that? Because it looks actually good.
Key is pressed, right? So if we keep it pressed, then it will keep adding velocity. So what we do is we go back into our script and we just change this to get key down instead. And as the name implies, this will only execute this code when we press the space key down, but not when we hold it. So save it, go back into our project, and then let's run it again and try to hold down the space key.
Now the tutorial
and it will just jump once, and I think the jump feels fine like this. If you want, you can apply different forces to it and just play around.
But you can still jump in the air now?
Of course, we can still jump while we are in the air by just releasing and pressing the space key again, but we will take care of this later. Now, of course, a game where we can only jump up and down is not the most fun, so in the next part we will add some more movements to it. Stay tuned for that, subscribe to the channel if you haven't yet, and share. Now, when you have social anxiety like me and you try to walk in public places, your brain sometimes forgets how your legs work and you stumble around like an idiot. The same is not the case for our player. He will always do exactly what we tell him to do, So let's tell him what to do by writing some movement code.
Oh god.
For this, we open our
What an
player
example.
movement script. And if you forgot how to open this, just click on player and double click here on the player movement script in the player movement component in the inspector. We want to change the velocity of our rigid body in multiple different places. By doing it like this is actually not very efficient because we make this get component call again and again, and every time we do this, Unity has to go ahead and search the component in this object. Doing it one time doesn't matter at all, but doing it over and over again can really get expensive, which means that it lowers the performance of our game. Instead, what we want to do is we want to search this component one time, save it somewhere, and then just reuse it whenever we want to change the velocity or something else. And we already know that we can execute code one time when our game starts in the start method here. So this seems like a good place to search for our rigid body. And to store it, we create a variable. And we put it here at the top of our class below the first opening curly brace.
We
write rigid body 2D, which is the type of this variable. So what type of data we want to store in there? We want to store our rigid body in there. And we give it the variable a name. You can give it any name you want. I'm gonna call it RB, short for rigid body.
RB, yeah, okay.
A variable is like a box where you can put a value in, and then you can use this variable to make calculations with it, to change the value in it, to reuse the same value in different places. You probably already know variables from
we initialized
class in school,
start,
and we can put all kinds of data into these variables. We could also create a variable for our box collider, for example, when we later need it. Besides these types, rigid body, box collider, and so on, it's also important to know the basic types that we will use over and over again throughout our scripts. Whenever we want to store a whole number in a variable, we create an int. And this is lowercase because these basic types start with lowercase, whereas these more complex types like our rigid body
that's different in Swift
name.
Actually.
So whenever we want to store a whole number, and in this case whole number is just the variable name, you can again give this any name you want, then we declare it as an int, which can have value, for example, 16, right? And the variable name should be written in camel case, where the very first letter is lowercase, but each new word starts with an uppercase letter. For decimal numbers with a floating point, we have float. So in here we can store a number like 4.56. And when we want to use a floating point number, we have to add this f here behind it.
But we actually give it private.
Now we don't always have to add this
control,
but in some places it's necessary. Like here, otherwise there is some ambiguity in the compiler. It's useful to just add it every time you use a floating point number. For example, here our vector actually works with floats. So here it works if we just pass the 14 directly, but it's actually better to pass 14f just to be explicit. The other two basic types that we will use often in our scripts are strings, which are basically just text, and we create a string like this with these quotation marks, as we also did in here, because getKeyDown expects a string argument. And we can use this to print some text on the screen or in our debug console, for example, like we did earlier. And the other one is a boolean, which we declare with bool. And this can be either true or false. We can use this to check for certain conditions and execute code in response to it. For example, getKeyDown returns a boolean. If this key is pressed, it returns true, otherwise it returns false, and then we use this in our if statement to execute something in reaction to it. This piece of code will only be executed if the boolean we get back from this method is true. Otherwise this part here will be skipped. Now there are more basic types like doubles, but those are the ones we will use frequently, so let's just...
double is just floats, but a bit more precise.
The other ones for now. But we don't need them here, so I'm gonna reverse this. And one more thing we want to add is, in front of rigid body, we want to write private to make this variable private. This means that only this script can access this variable and make changes to it, not other scripts. And it's good practice to don't expose any variables that are not meant to be used by other scripts, because this makes it easier to introduce bugs in your code. You should only expose the parts.
And also it makes it more complex. If you want to call player movement, for example, and you have like, you know that you just call start and update, and then you have like 15 variables there. With auto completion, you get all of these variables and update and start. And if you have them all private, you just get start and update. So it just makes the code easier and also safer.
That are actually be meant to be changed or accessed by other pieces of code. But it's not so important that you understand this right away. Just follow along, make this one private.
Just follow along.
Make our methods private here.
Okay, never mind.
We also don't want to access them from somewhere else. They are only useful inside the script, at least in this case. But right now our rigid body variable is empty. It doesn't contain anything yet. It's null. And we want to assign it in start. So we execute this one time when the game starts, and then we can reuse this variable. So we assign RB with the equal sign to exactly what we did down here. So we can actually cut this out, put it here, and add a semicolon.
Don't we have velocity also every time?
And then down here we can just use our RB.
If we write it like this.
And this is now more efficient because we don't execute get component over and over again.
Because then we could also just add the velocity to this one. But I don't know, maybe we don't need it every time. We did in the last
next thing we want
example.
to change is how we detect key presses, because right now we have hard-coded jump to the space key, which is fine, but there's actually a better input system in Unity with a better way to handle this. So when we go back into our Unity editor and go to Edit and Project Settings, we have this Input Manager tab here, which we can expand by clicking on Axis. Let's make this a bit bigger. And here we have different buttons for different functionalities, for example, jump. Now the benefit of using one of those instead of hard coding the space key is that it makes it possible to add the same movement, the same behavior to different keys. For example, moving left and right later will be possible by either pressing the left and right keys on our keyboard,
I see,
or A and D, which is very common in games. And of course you can change this in here.
Oh, and you could also have negative buttons, like for example, we make arrow down for negative and arrow up for positive. So we have like Brawlhalla style movement, where you can also get down faster with pressing a down button.
It's more flexible because you can add different buttons to it, you can make changes to it, and so on. It's better than hard coding the specific key. So let's go back into the code and change get key down. Instead of calling get key down, we want to call get button down, which is the equivalent, but it uses Unity's input system here. And this is the name of the jump button, jump with a capital J, and you can change everything in here. You can give it a different name if you want, can add different keys to it, and so on. Back in our C# code, we replace space for jump, and again it's very important that you start with a capital J, otherwise it will not detect it. Let's run our game again and see if this still works. And we can still jump.
Asset type or namespace, name rich. Oh, I mistyped rigid body. Okay. Rigid body. No, it should work. Or does it? Yeah, it does. Okay. And when I hit play, should we still be able to jump? Yeah, we are. But we can still triple, quadruple jump.
Okay. And for moving left and right, we use this horizontal axis here, which is called horizontal. And as I already explained, By default, it supports the left and right arrow keys and A and D, and it has some settings here. So back in our C# code, above our jump code, we can also put it below. It doesn't really matter, but I like to put it above. And this works a bit differently because we don't get button down left, button down right. Instead, we get the value of the axis, which is between -1 and +1, which makes sense if you think about it, because we could, for example, use a joystick where we are not either all the way to the left or all the way to the right, but we have a gradient in between. So what we do is we create a float because it's a decimal number. We give the variable a name. I'm going to call it dirx for direction x in the x-axis. And then we assign input.getAxis, and in parentheses we pass the name of the axis, which again is called horizontal, as we saw in the editor. So now when we press left, this will be set to -1. When we press right, it will be set to +1. And if we have something like a joystick, it can have values in between, like 0.5, for example. Now what we could do now is we could check if dirx is greater than 0, then we know that we move right. And if it's smaller than 0, then we know that we move left. And then just add the corresponding velocity to the x-axis, right? But then we don't have this joystick support where we can move only a little bit. And I think it's nice to keep this in. And it also makes for shorter code, because instead of the if block, we write it the following way. We write rb.velocity, just like when we want to jump, and we assign it to a new vector. As I already said, we will never move in the z direction, so instead of vector 3, we can actually use vector 2. Then we only have this the x and y axis, right? The horizontal
use
and
vector 2 down here as well.
And we can do the same down here. We can change this to vector 2 and remove the last value. This is enough for a 2D game. Vector 3 is more important in 3D games. And then we want to move horizontally with a certain speed. So our jump force was 14F, and say our horizontal force is 7F. But you can play around with this. But we also want to multiply this with dirx, like this. Because now, if dirx is a negative value, then the x velocity in this vector will also be set to a negative value, and we will move left.
Makes sense.
And this is more concise than writing if dirx is greater than 0, move to right, else if dirx is less than 0, move left. Instead, we just multiply it. Then we just have this one line. If you can't wrap your head around it, just leave it aside for a moment, think about it later, and you will eventually understand the purpose of this. And when we do it like this, we also have this joystick support, because let's say the dirx is -0.5 instead of -1. Then we will only move by 3.5 in the x velocity, because we will multiply the 7f by the dirx, which is -0.5, and we move slower. If this is confusing to you, don't worry, it won't get much more confusing than this. The movement code is actually the most complicated stuff in this tutorial, I would say.
For real?
Don't worry about this. And for the y velocity value, we don't want to pass 0. Because think about it, let's say we jump up, we add 14 to the y velocity. So we have this force upwards. But then in the next frame and update, when we click left or right, we suddenly set it back to 0. Then we would start jumping. Instead, we want to keep the old value. So we take our rigid body, write velocity.y. So this is the value of the y velocity this rigid body already had the frame before. This way we keep it. And we actually do the same down here. Instead of 0, we press rb.velocity.x. So let's save the script. Go back into our editor, close these settings, and then try it out. So now you can use A and D or the arrow keys to move left and right, and we can jump. Of course, we don't have animations yet because we haven't set this up yet, but this is already very cool.
True. honestly.
And it's already a lot
Subscribe.
of fun. Whee. Okay, back to business. One thing you will notice is that when you release the right or left key, it slides for a little bit. It's personal preference if you like this or not. I think it's more appropriate in 3D games, which are more realistic in terms of physics. But in a 2D game, we basically want...
Thank you.
It to stop immediately when we release the button. For this, we go back into our script and we change get access to get access raw.
Get access raw. Why get access? Oh, because it slides.
The normal get access method doesn't go back to 0 as soon as we release the horizontal keys. Instead, it does it gradually. With get access raw, we get back to 0 immediately. And when we multiply 0 with 7, we get 0. So we get 0 in the x velocity and we stand still.
Instantly, okay.
Let's try it out again. But you actually have to try it out yourself, otherwise you won't notice a difference because you can't see me pressing the keys. But it feels much different now.
Makes it different.
And I think it's more appropriate for a 2D game.
Yeah, it feels better, honestly.
Okay. One more thing I want to explain here is the difference between a variable that we create inside the method, like we did here in update, and a variable that we put here. First of all, we can't make such a local variable private because no other script can go into this update method and access this variable. So this is basically private by default. But the difference is that we need dirx at the moment only inside update. No.
And you can just make it private now. It doesn't change anything, but can't you make that private? Oh, you actually can't. Okay, interesting. I mean, wouldn't change anything, but...
Whereas rigid body
just
has to be accessed from two different places, from start and from update. So we have to put it up here and make it a variable that is usable throughout this whole class. And it's good practice to ever create your variables in the smallest scope where you need it.
True.
So we could theoretically make dirx a property up here, so a variable that we can use in this whole script.
We don't need it.
But it wouldn't be good practice at the moment because we don't need it anywhere else than inside update. So we create it in here with this float keyword. Now, of course, it would be nice if the camera actually followed along when we move our player, because right now, when we move around, we will eventually get out of the screen. Now, an easy way to handle this is to just take this camera and put it onto the player so it's nested below it. Now the camera will follow our player automatically.
Then probably 0, 0.
The positioning is not great yet, but it already works. And whenever we nest an object below another one, the position of this transform component is then relative to the parent object. So minus 2.05x of the camera is relative to the player. So when we set this to 0 and y as well, it will be set directly on the player. Now, as I already mentioned, for the camera, it's important that the z value is minus 10, because it moves the camera.
We see out of bounds.
If we accidentally set this to 0 here, the following will happen. We start our game, and we suddenly see a blue screen, even though it looks correct in the scene view. Why? Because the camera is now at the same Z position as the rest, and it basically looks right through it, behind what is behind our actual level.
Okay.
So we set this back to minus 10, the camera moves
Could also make it probably
this
like
can happen very easily. So whenever it happens that you see something here in the scene viewer, but it suddenly disappears when you click play, then make sure that the Z value is set correctly. It should be set to 0. So to see what I mean, let's set the Z value of terrain to minus 20. Here it looks completely normal, right?
Okay, let me check something. I'm going to project settings and then input manager and then alternative negative button I use S, and for positive I use W. Wait. Oh shit, I think I messed up. Oh no, it was jump, never mind. It was jump where I wanted to negative button S and positive W. Not actually this one, okay. Okay, let's see how this changes. Or did it actually change because I had it on play mode? I hope it does. Project settings. It's actually reset. Let me show you this, but you don't see the project settings anyway. Still vertical. I leave it as is. Probably better.
But in the 3D view, we can see that it actually moved behind the camera. And now when we start our game, we won't see the terrain.
Oh.
So always make sure to check the Z value if something like this happens. One more little change.
Ah, I see. That's why we have a 3D view as well, to check these kind of things. Okay.
I want to
make
make
sense. No.
When our player reaches the end of the terrain, it can fall over, right? And it flips when this happens. So this looks really cool because the camera flips over together with it. We will take care of this later. It's not meant to be like that.
Okay,
what we want to change right now is making the player not flip like this, because it's not really appropriate for a 2D platformer game. So to change this, we click on player in the hierarchy.
And lock
then we go to rigid
rotation.
body 2D, and here in constraints, we can freeze rotation Z. And now when we fall over, we will not flip in the Z direction anymore. And Z in rotation actually means something different than Z when it comes to the position. Z in the position was the depth, right? But when we change Z here in rotation, it moves it like this. So you can try this out by changing these values up here.
Wait, but what
and
does...
you can drag like I just did by hovering with the mouse over the letter, and then you can see the cursor changing a little bit to this drag icon.
I see.
Then you can hold and click and drag it around like this, and always revert this with Control Z. I know what you're thinking. Florian moving left and right is really cool and everything.
It's so funny how he like doesn't show any emotion. He just dry talks it.
But when can I start building the next League of Legends? And the answer is,
bro, no one should make the next League of Legends. You already have one, and that's enough. That's enough toxicity for this world.
Not yet. We are not there yet, my young Padawan. You need a bit of patience.
My young Padawan.
But in the next video, we will already add animations to our player, so it looks a lot cooler when it's moving around. So don't forget to subscribe to the channel and stay tuned for the next part. Take care.
Wait. This League of Legends? Just wanted to make fun about League of Legends as a 2D game, but is League of Legends a 2D game? Is this 2D? Probably not, right? Because you can... I think you have the option to fly around and look at stuff, and there it's 3D. But if you just have the League of Legends... But if you just have the base game, like this, I mean, yeah, it looks pretty 3D. I guess you could possibly create this as a 2D game, but I guess it's 3D. Yeah, I think it's 3D. Never thought about it.
This? That's gray hair. Why is my hair gray? Because you haven't shared this tutorial with anyone yet. Go ahead and share it. And then let's go, because now we want to take care of animations. So let's set up our animations. And we can
I like
find
him,
the
he's
animation
funny.
files in our Pixel Adventure folder, assets, main character, and we use the virtual guy here, and then we have these different graphics. And These animation images are very similar to our tileset images. They are always one.
Wait, how do the other people look? Okay. Ninja frog. Okay, yeah, the virtual guy is the one that looks the best.
Large image that we need to slice up into its different smaller images that make up the animation. So if we look through idle, for example, we can see here in the bottom right,
just moving up and down.
Is an animation. It's hard to distinguish here, but if we switch fast enough between them, it looks like an animation. Again, for this, we have to slice up this image, but this was already done for us here. So we can use this file. And we have also already set the pixels per unit value for all of them earlier. Yeah. If you need a refresher how to slice up these images, again, you have to set the sprite mode to multiple, open the sprite editor, and then slice this into 16 by 16 smaller images, depending on the type of graphic you use. And then you get something like this, where we now have a separate little image for each part of the animation. But this is already done for us. So I close this. And then we need to create an animation file. So somewhere in here, we right click, create animation. And then we get this file, which we have to give a name. Let's call it player_idle, because it's the animation while our player is not moving. Next, we have to click on this and drag it onto our player object, which creates a second file. This file connects this animation to our player object, so we can apply it to it. And to set up this animation, we go to Window, Animation, and open the animation window. You can see the shortcut for it here. On Windows, it's Ctrl+6, which opens this window here. Now we select player, and here we have player idle selected. It's important that you select player, otherwise this will not be shown.
Do you see my mouse bugging? Yeah, you see.
Then we open our idle animation, and we again with Shift select all of these images at once.
Oh wait, I didn't pay attention.
Here we have player idle selected. It's important that you select player, otherwise this will not be shown here. Then we open our idle animation, and we again with Shift select all of these images at once and drag them in here. Okay. And now in our scene viewer, we can actually see how this looks by pressing either play or hitting the space bar, and it looks like this. Now this is a bit fast. To change the speed of this animation, we need to change the sample rate. This is not shown here by default. Instead, we click here on these three little dots and on show sample rate. This is 60 by default.
Okay.
Now we can change this value to change the speed of this animation. A smaller value means that it will be played more slowly. And I found that 18 looks good, but this is up to your personal preference. I think this is a nice speed. So let's choose this. Let's put this animation window down here so it's not in the way. And now when we click on our player again, we will see that we have a new component here, which is this animator. This controls which animation is played. But to set this up properly, we need to open a different window. So again, we click on Window here, Animation, and we open this Animator window. Which looks like this. And here we have our idle animation that we already set up. And since we only have this one animation, it will automatically be applied as soon as we start the game, because we have this arrow from entry to idle. Now when we actually start the game, we will see that we play this idle animation for a short moment, and then it stops. Why does it stop? Because we didn't set it to a loop. To change this, we need to go to our animation file again. So in the project viewer, we click on our player idle animation, and here on the top right, we select loop time. And now when we start it again, it will keep looping the idle animation, just as we wanted. But of course we only have this one animation, so we keep idling, no matter if we run or jump or stand still. So we have to add more animations. So again, in here, right click, create animation, and we call it player_running. Again, we have to drag and drop this onto the player to add it to the animator. So when we go into the animator tab, we can see that it was added here. We will take care of this in a moment. First of all, we go to the animation.
But I dragged it onto player, no? Oh, it's already connected, I guess. No, it's not. Wait.
Tap this onto the player to add it to the animator. So when we go into the animator tab, we can see that it was added here.
Oh, okay.
We will take care of this in a moment. First of all, we go to the animation tab again. Click.
He added this earlier. Didn't notice that. Okay, here animation, and then add this to there. Okay.
Player. Select player running. Then we
wait, where? Oh, player running.
Move this somewhere else so we can show our sprites here. And then we want to drag the run animations in here. Again, it's a bit too fast. So we changed the samples and I found 32 to look pretty cool. So we keep this. But now, of course, we have to tell Unity when we want to switch between these different animations. When we want to show the idle animation and when do we want to show the run animation. And again, this is all handled in the animator tab. So we go into this window, and again, if it's not open for you, click on Window, Animation, Animator. And then we position this a bit better. Doesn't matter where exactly you position it, it's just for your personal overview. Then we right click on running or idle.
This triggers me a bit. You can't make this exactly straight. Oh, never mind.
Click on make transition and make a transition to the opposite direction. And then the same from idle to running, because we want to be able to switch from the idle animation to running and vice versa.
This is straight, nice.
And when we click on these arrows here, we can define conditions under which we want to switch between these animations. For this, we have to add a parameter here in this parameters tab.
Now it's getting a bit complicated.
Remember in our C# code earlier that we had Boolean variables that could be true or false. And we want to add one of these Boolean variables to decide if we are running or not. So under animator parameters, we click here on this plus and add a bool.
And we call it isRunning.
Running.
Oh.
And then we click on the arrow that goes from idle to running. First of all, we uncheck has exit time and set transition duration to 0. Those are some transition effects between these animations that make more sense for 3D games. But for a 2D game like we are building here, we want very abrupt and sudden switches, and it looks better if we set it up like this.
Didn't know that.
Then here under conditions, we click on plus, select running. If it's not already selected. And if running is true, we want to switch from idle to running.
That's also some wording tag I learned. That you call a Boolean isRunning, because if isRunning, it just sounds a bit better than just running. You just know a bit better that this is a Boolean than just running.
Then we click on the other arrow.
And if statement, for example, like if isRunning.
Again, we uncheck has exit time. Set the transition duration to 0. We do this for all animations we will use in this game.
Here is running false.
We add the same condition, but we want to switch back from running to idle if running is false, right?
Yeah.
And the way we toggle this running Boolean variable is of course in a C# script later, in our movement script.
Yeah.
But before we do this, we can actually see how this will look in the preview here. So let's move this animator window down here, so we can see the scene view. Let's start. And then we see our idle animation, of course. And now in the editor, we can actually toggle this on and off manually.
Oh, okay.
And we can see that when we do this, we see our running animation. which again stops because we haven't set it to looping yet.
It's not looping.
So let's change this. Project, player running, the animation file, loop time. Then we go back to the animator and let's take a look at this again.
Looks cool.
And now we can toggle between running and not running, which we will later do in C# code. Nice. So next, let's open our player movement script so we can set the running boolean there. And we find the script under player, and here, player movement, we double click it and open Visual Studio. And how do we know if we are running or not? It's actually pretty easy. If dirx is 0, this means we are not moving, right? Then we can show the idle animation. If it's not 0, then we are running, and we set the running boolean to true. So below, inside our update method, we can check for the following. If dirx, and again the spelling has to be correct with the same capitalization, is greater than 0f, and again we could also write 0, but I like to be explicit that this is a float value. And here we want to set the boolean.
But how do we get this running?
In our animator to true. To access this boolean, we need a reference to this animator, the same way as we needed a reference to the rigid body to change the velocity earlier, if you remember. So we do something similar. We go up here and create another variable, private animator. Important, it's not animation, it's animator. And we call it short anim. And then we assign it here. Anim equals get component, again animator,
component,
and then we can use it in our class. And to now change this boolean flag, we go here inside the if check and call anim.setBool, parentheses, and this takes 2 arguments. The first one is a string with the name of the variable. It's the exact same name
as running, I guess.
We set in our editor. Running with a lowercase r. So we write running without any typos. Comma and the value we want to set it to. We want to set this to true to indicate that we are indeed running. Semicolon. Then below if we write else if to check for something only if the first condition is not met.
Can we just write else?
Met, this will just be skipped completely. So if dirx is not greater than 0,
why shouldn't we just write else?
We want to check if dirx is
less than 0, yeah, okay.
In this case, we also want to set running to true, because then we are running into the left direction.
Okay, but surely I can just write it like that. Dirx less than 0, and then just write else here. Let me just check if this works. Does this work? Okay, it does. It's the same. It's the same as the another norm. The term, the name. Norm.
And lastly, we write else without an if, because this will then be.
This is just or, so if it's greater than 0 or less than 0. So just save a bit of code.
Applied if neither of these two is true, which means that dirx is exactly 0, which means that we are standing still. So here we don't add parentheses, instead we just add curly braces. In this case, we want to set running to false, so we switch back to idle. Now you probably have already noticed that we could have written this more concise. We could have written if dirx is not equal to 0f, like this,
true,
and then just
or
set
like
it to running once, and that's it. But we actually do some different stuff here later, depending if we move left.
Fair. Okay, never mind. That's true actually. Else if TRX less than 0f. I just need one. Anim.set will this running true. Wrong true. Okay.
Left or right.
Didn't think about that.
This is when we separate it out into a check for greater than 0 and less than 0. Okay, let's save this and try it out because it should already work. So we run our game again. And now we switch between these animations. Now we don't look left yet, we always look right, no matter in what direction we are walking. But the animation's already working. And you can actually see it switch in real time down here. Let's go back into Visual Studio once more, because we want to make some improvements here. First of all, this update method can become very messy very quickly. And what we can do is we can separate this out into other methods, so our code is better readable.
Oh, true.
So we write private void. Void means that this method doesn't return a result when we call it. It just executes some code and that's it. And we give the method a name, which is completely up to us. Update animation state, for example.
Update animation update.
Update and start are not up to us. Those are methods that are predefined by the Unity engine itself. They have to have this exact same spelling. Otherwise, this, for example, will not be executed in every frame.
If you're wondering how to cut something, it's Control X.
But our own methods, like update animation state, can have any name we want. Behind the method name, we add an empty pair of parentheses, which means that this method doesn't take any input. And then we add a pair of curly braces to define what should happen when this method is executed, just like in start and update. And then we want to cut out this whole part here, paste it here, and then instead just call this method here by writing out the name and the pair of parentheses and a semicolon. So now when the code at the end of update gets to this part, it will switch.
I like it because he explains some of the more intermediate things to do or techniques, because this is kind of an intermediate practice of refactoring to not write everything into a single function but split it up so it's more readable. The goal of refactoring is always to make it more readable, and that he's including this in a complete beginner guide. I think it's actually really helpful because from the beginning you have these practices that you learn and do, and even if it's kind of intermediate, I think it's pretty good that he includes this in the tutorial.
To this method, execute this code completely the same way as we did it before when the code was in here. It basically has the exact same functionality. It's just more organized now. And we get this warning here because remember, dirx is a local variable inside update, because we said we don't need it anywhere in this class, so we can make it a local variable, and we should make it a local variable. But this is not the case anymore. Now we need it in other methods. So what we do is we copy this part, and then we remove the float keyword here, and instead declare the private float dirx up here, and then here we just reassign this value. But this way we can also use it down here in our other method. Let's also give this variable a default value of 0.
Puts a space in there.
Otherwise it will have an invalid value before the first update is called. I don't know if this can cause any...
You don't need this, but it doesn't hurt either. Yeah, true. That's what I meant, for example, in Swift, so the programming language for iOS. Wait, is this not in sync? I think it is. In Swift, for example, you need to do this because otherwise it's not valid. But here in C#, apparently you can just leave this.
Problems, but I can imagine that this could happen. So I think it's safer if we initialize this with 0, like this. Next, let's take care that we actually switch directions of our player sprite when we move into the left direction, because moving backwards looks really cool, but this is not really what we want. For this, we will need a reference to the sprite renderer, because the sprite renderer has this functionality here, flip X. As you can see, it flips the sprite around. But we want to do this in code when we move into the left direction. So back into Visual Studio. Here we add another variable. And I put it here, but you can also put it below animator or above, everybody, doesn't matter. I just like this order. Private, sprite renderer, and we just call it short sprite.
Sure.
We assign it in start as usual, get component, sprite renderer, semicolon. And then when we move
actually
left,
I will wait, give me a second. Okay, yeah, that's fine. Actually, I will put it like this because of the alphabet, so it's alphabetically sorted. You don't need, but this is a pretty common practice to especially if you have packages that you're importing. For example, these are not packages, but these are kind of like packages. People often sort them alphabetically. So I think that's pretty useful. And you can also do things like this to make it look better. It looks just a bit better, but you don't have to.
Which means that dirx is less than 0. We want to flip this sprite. And this is why I put this into separate branches. So now we can execute different code here and different code above. So we take sprite and call.flipx. And we set this to true, which has the same effect as we saw earlier in the editor.
True, and then probably here
it will flip the sprite on the x-axis.
Wait, but when do we flip it
left,
back?
But we don't flip it back.
Yeah,
so
but when do we actually, because do we want it in the idle position to be flipped in the side we were moving, or do we not?
Change this. We copy this line, paste it in dirx greater than 0 and set this back to false.
Yeah, but
now you might be wondering, but how do I find out which values I have to use? And the answer is simply you have to Google for it. So when I wanted to know how I can flip the sprite or how I can flip the character, I Googled for something like Unity.
But you probably want to have the idle animation in the direction you were last moving. That's probably fine.
Player sprite or something like that. But the auto completion of Visual Studio.
Because also if you stop for like a second, so you run in a direction and then stop for a second and then run again, you have this flip, which probably looks weird.
It is also very useful. So when we write something like sprite, and you know, okay, we want to flip the sprite, so you can just type in flip, and then you will see the suggestions here, which will help. And for the rest, you always have Google. So as a programmer, you really have to learn to use Google to use it all the time. And what we are doing here is changing the value of the flipx boolean variable of the sprite renderer class, which also means that this variable is not private. Whether you have to change a variable directly or instead call a method like we did for setBool depends on the situation. And again, you can find this out through Google or the documentation. So let's save the script and try it out once more. Now we should be able to flip into both directions. And this already looks much better, doesn't it? Of course, we don't have a jump animation yet. We will actually do this in the next part. But for now, I want to do some more improvements to our current script.
chill for a sec. Yeah, looks pretty good. And if we stop here, yeah, that looks way better than if you would flip it. Because if you like stop, it would flip in this direction instantly every time you like stop. But yeah, I mean, it looks pretty cool already.
Script. Right now we hard-coded the speed and the jump force with these two values here, 7 and 14. And this is not good practice because this is called a magic number. It's a number in code which is not really self-documenting. When we read this code, at first glance we can't really see what this is for. Of course, we can find it out by following the code execution flow, but on first glance it's not very readable, right? This is why we usually want to use variables for that, because variables have a name.
I really like this tutorial. He explains a lot of stuff that you wouldn't normally do as a beginner. That's cool.
And they are readable. So what we do is, here at the top again, we create two more variables. A private float move speed, again you can give it any name you want, and we set this to 7. And a private float jump force, which we set to the same 14 value. And then here instead we can pass the move speed, and down here the jump force, and it's already more readable. But there's actually one more cool thing we can do, and we will need this a lot later. When we go into the editor, for these predefined components, we have all these nice different settings, like the mass on our rigid body and all this other stuff. And wouldn't it be cool if we could set similar values on our own scripts? So right now we only see our script, but we can't type anything in.
Yeah.
But we can make it that way by going in front of the values we want to expose to the editor.
Public.
So let's say we want to be able to change the move speed directly in Unity. And here we add a pair of square brackets
or like this,
before private. And in here we write serialized field with the exact same spelling. And we do the same for jump force. Save this. And then when we go back to Unity and it has reloaded,
we want to set these. I mean, we probably don't.
We can now
set
add these values here, which is really cool because it's more convenient. And we can also, like we did earlier for the rigid body, change these values at runtime to try out different combinations. So I can set a much higher move speed and I can try out which of them fits.
I mean,
remember, those are reset when we exit the play mode.
Serialized
now another way to get
field.
these fields into the editor is by not using serialized field, but instead making these variables public, which is basically the opposite of private. Then they will also be exposed to the editor, but this is not as good because this way other scripts can also access these values. And remember, we said that we shouldn't expose more than necessary. So to hide the stuff from other scripts, but still have it visible in the editor, it's better to use serialized field together with the private modifier. One more thing. If I now change this value here, for example to 70, save it, go back into Unity, you will see that it's not automatically changed here.
Oh wait, it's not? Okay.
In the editor. If you want to set it back to the script's values, you have to right click on your script and click on reset. And then it will be set to the values of the script.
Okay.
But I want to set it back to 7 anyway, so that's fine. And I just noticed that I accidentally called this update animation update. I meant to write update animation state. We can refactor a name in Visual Studio with a shortcut. We press Ctrl R and then Ctrl R again.
Ctrl R.
And now when we change this name, it will be changed anywhere we use it, which is up to you. If it doesn't work for you, or if you're using a different...
that's not... oh, I reloaded the page. That's not what I was...
I meant to write update animation state.
Wait, what? Ctrl R and Ctrl R. It just put me in a different file. Just got a sneak peek for my voice assistant. But I don't mind.
Animation update, but I meant to write update animation state. we can refactor a name in Visual Studio with a shortcut. We press Ctrl R and then Ctrl R again. And now when we change this name, it will be changed anywhere we use it, which is up here. If it doesn't work for you, or if you're using a different editor, you can also just change these two names here separately. This one and this one. It's just important that you also change the name at the calling side.
Oh, it's Control Shift R. Okay.
The last thing I want to do for this part is changing our camera behavior. Because even though our camera is following the player, because we parented it to the player, it's not optimal. When we, for example, rotate our player in play mode, our camera rotates with it. And we don't want this. I mean, even though our player can't be rotated in our game, it's still better to decouple the camera so it can move independently, because it also has some other side effects. So what we do is we track the camera outside of player. Or let's put it up here, so that it's not parented under the player anymore. But of course, now it's not following the player anymore.
Yeah.
To change this, we add our own camera controller component. So we click on camera, add component, and we call it camera controller. New script. We keep the name, create and add. We open it.
You can also just type it there and then.
We don't need start.
It's loading for me. Okay, there we go. There we go.
Here at all.
Oh, you didn't see it, but wasn't that important.
And we can also remove this comment, so we don't have it in every script. And let's make update private. And we want our camera to follow the player. So we need a reference to the player. To be more exact, we need a reference to this transform component, because this contains the information about the position of the player. So back in Visual Studio, we create a variable here. Private transform, because this is how the component is called.
Transform.
And let's call it player. Now this time we can't call getComponent. Why? Because this component is in a different object. The script is in our camera, but the transform component we need is in our player. Now there is a way to find this from code, but it's not very efficient. Instead, what we want to do is we want to set this in the editor. And we already know how we do this. We have to add the serialize field tag here in front of it. Save it. And now when we go back to Unity and select our camera, we now have this field down here where we can drag in the transform of the player. So we keep camera selected. But
wait, camera controller transform could not. Oh, I mistyped transform. I typed transform. Now we should get. Yeah, now we have it.
But we drag and drop the player into this field. And now when we start our game, this variable will be assigned to the player object in our scene, because we connected these two. And the rest is pretty simple. We want to set the position of the camera to the position of the player in each frame. So in update, we write transform. Now since this is a lowercase t, this refers to the transform of the same object this component is in. So camera controller is in our camera. So with the transform variable, we can access this transform value here. We don't have to call getComponent for this, because it's so common to use that they have set it up in a way that we can just access it by writing transform with lowercase. We don't have to write getComponent like we had to do for other components like the rigid body. This is just a convenience. We want to set the position of the camera to a new vector 3. Vector 3 because we have to set a z value. Because remember, the camera is at z minus 10. Otherwise we won't see anything.
Minus 10.
For the x value and the y value, we want to follow the player. So we pass player, which refers to our player transform variable that we assign in the editor, dot position dot x.
position,
comma. So it will use the X position of our player for the X position of our camera. Pretty straightforward.
Y.
For Y we do the same, player.position.y.
Okay.
And for Z, it's important that we don't use the player position.
Understand.
Because otherwise, remember, the player is at Z position 0, and if the camera is at Z position 0, we won't see anything when we play the game. Instead, we want to keep the position that we have already set up in here. We have set this up to -10. And to keep this value, again, we use our own transform.position.z.
Oh, I forgot the semicolon.
So we tell the script, hey, just keep our own
transform.position.z value.
Okay. So we have the same value as we had before. We don't change it. Of course, we could also just hardcode -10 in here directly, but this way it's more flexible.
Oh,
and since we execute this in an update, this will be executed in every frame. So we will constantly follow our player. So when we
then you could zoom out and in, for example. Probably better as transform.position.z.
Save this and go back into Unity. Our camera script should work pretty much the same as before.
It
follows our player, just with the difference that when we now rotate our player,
this is still in the game.
The camera doesn't rotate, which is just better. Now the last thing I want to do for this part is organizing our files better, because it starts to become messy. We have our two scripts here in the assets folder. Let's create a new folder. Right click, create folder. Let's call it scripts, and we will put all our scripts in here. So we select both and
you can just put them there.
We have to drag it one by one actually, for some reason.
Wait.
Come on.
I don't have to.
Like this. We will also create a folder for our animations. So again, create folder, animations. And right now our animations are here in assets, main character, virtual guy, because this is where we put them. And then let's select the animation controller, which is this one here, and our two animations. And let's drag them over here in this overview into the animations folder.
You can drag them there.
Like this. It's just a bit better organized like this.
And I like how you can just drag these files around, and they're apparently still connected. Yeah, they're still connected to these objects in Android Studio, for example. So for Android app development, this is not the case. So if you drag a file around there, you have to connect them again, or because this in Android Studio it's just a path. So you just point somewhere, and if you move the file to another folder, the pointer or where you point, where the program thinks this file is not right anymore. So you have to update this again. That's pretty nice here in Unity.
In the next part we will add the jump animations, because right now we are just walking in the air like this.
Looks funny.
Do you smell that? That's the smell of success, because we are blasting through this tutorial. Now if any of this stuff here is confusing to you, especially if you are a beginner, don't worry, it all comes down to a repetition and practice.
These outros are so funny.
If you really wasn't able to follow along and it's all a complete mess, just watch the series again from the beginning, try to follow everything step by step. And it's important that you play around with the code and the different settings, because then you get a better feel for it. So change some stuff, change some code, look what effects it has. Just be playful and patient.
Yep.
And then we'll see us in the next part. Take care.
Bro, I like these outros. He has fun outros. I like this. That's probably the best part of the tutorial, is these outros. Really funny.
So now our
funny guy. But let me check for a second if we're still live. Probably are. Looks like we're still live here. Yeah, let's go. Wait. That's not the right live stream. But yeah, okay. Still works completely fine. So let's continue.
Our player already has a nice running and idle animation. And in this part we will learn how to add more animations to our player, but without making a complete mess out of our code. Ready? Let's go. So
Ready,
the first
set,
step,
go.
of course, is to create our new animation. So we go into our animations folder in the assets folder. We right click and create a new animation file. We call the first one player_jumping. And then we drag it onto the player object to add it to the animator. And then we open the animation window.
No, not animation window. Okay.
Select our player in the hierarchy and select player jumping.
Player jumping.
And then we navigate to our player graphics in Pixel Adventure, assets, main characters, virtual guy.
Main character.
And jumping and falling are only one image each.
Oh yeah.
So the whole animation is just one image, which we drag into the animation editor here. And this also means that we don't have to change the samples, because with one image we don't have a speed for this animation. It's just a static image, which looks like this. Then we repeat the same process for falling. So back into our animations folder. And of course you are free to put these animation files into any folder you want. So you can also put them directly into the virtual guy folder where the graphics are. It's a bit easier to switch between them. But I like to organize it into separate folders. So here in animations, I create a new animation, which we call player_falling. The same process, we drag it onto the player game object. We select the player in the hierarchy.
Player falling.
We select player falling in the animation window.
And drag it.
And we drag the fall animation in here.
Why can I? Oh,
which of course we earlier said.
Oh, it's. Oh, I didn't connect them. Right. I forgot to connect falling to player. And then we have here player falling. And then I can drag. Yeah, okay. Perfect. Then I can put it here. Yeah. Looks good.
It's to pixels per unit 16, so it has the correct size.
Ooh,
and here we also don't have to change the samples value.
Oh, okay. No,
the next step is to add these two new animations to the animator of the player, so that Unity knows when to switch between these different animations. So let's close this animation window here, and instead open the animation animator. And of course, we have to select the player. Now this looks a bit messy because we have two new animations. Let's drag them somewhere so it looks good, but it doesn't matter where you drag them exactly. It should just give you a good overview. And then we have to create connections basically from all animations to all the other ones, because we can switch from all animations to all the other ones. We can switch from idle to running, but also from idle to jumping, for example. We can also jump while we are running, and after we are falling, we can go to the idle mode, but we can also start running again. So we have to create connections from all these animations to all the other ones. So let's start doing that. We right-click on idle and make a new transition to jumping.
Do we have to do them all by hand?
And also from jumping back to idle. I mean, normally we have falling first. But I think there can be situations where we can go from the jumping animation immediately back to idle. Maybe, for example, when we jump on a higher platform. We can, of course, go from jumping to falling and immediately back to jumping again. And we can go from falling to running and from running to falling if we run over an edge. We can go from running to jumping, from jumping back to running, and from idle to falling.
This looks messy already.
Back to idle. And that's it. Now you might have...
Wait, it looks a bit like... Isn't this the flag of Alabama? Wait, what flag is this I'm thinking of? Flag of Alabama. Yeah, it looks a bit like the flag of Alabama. Wait for reference. 1 sec. Can drag it into... no, I can't drag it onto here. Doesn't matter. Can just Google it again. Flag of Alabama. Looks a bit like this one. Or the other one. Funny.
This any state thing here, this is actually meant for what exactly we just did manually. Any state that should be available from any other state can just be added to this part here. We could use it right now, but in the future we want to have a state that doesn't go back to any of these other states, and that's the def animation. This means we can't add these to any state because we don't want to be able to go back from any state to any of those ones here.
From def.
Now before we forget it, let's quickly go to our animations again. In the animations folder, falling, and set them to looping.
Oh, true.
Otherwise we only see the image for a fraction of a second and then it's gone. And now we want to switch between our different animation states.
You could probably change the samples to 1 and have a better performance. That was the word I was looking for. I guess because it's refreshing a bit less, you have a better performance, but I don't actually know. I'm just guessing.
And of course we do this in our player movement script. So let's double click on our player movement script here, on our player game object, and open Visual Studio. Now of course we could add additional booleans to our animator for jumping and falling, and we could toggle them on and off in the correct places. But as you can imagine, this can become really messy really quickly. So wouldn't it be nicer if we had one variable that manages the animation state? Because these different animation states, idle, running, jumping, and falling, are mutually exclusive, right? We can't have two animation states at the same time. And we can actually create a variable that can contain any of these 4 different states, but nothing else. And in C# we do this with a so-called enum.
Yeah, enumeration.
So let's put it up here. You can also put it above the other variables, doesn't matter, but you have to put it outside of any of these methods here. We create a private enum. And we give it a name. I'm gonna call it movement state, like this.
This is also because it's kind of an object, I would call it. I'm not sure exactly of the name. But here you also have this like capital start in an enumeration, as for example in a class. Don't ask me exactly why, but this is common practice.
It's up to you, just pick a name that fits. And then we create a pair of curly braces. With such an enum, we create our own data type. Just like we have variables with the data type rigid body 2D or with the data type float, we can now create a variable with the data type movement state. And the cool thing about this is that this variable can only hold the different states we put between these curly braces and nothing else. And this way we can create this finite set of values. So when we in here between these curly braces write idle, comma, running, comma, jumping, comma, falling, then our movement state variable can only hold either of those 4 values.
So I would probably still call it is idle, and is running, and is jumping. It just looks better, because it's basically an enumeration of booleans.
So when we call our movement state variable state, which is the variable name, which can be anything you want, we can set this, for example, to movement state.idle. This works, but we can't set this to 6, for example. Then the compiler will complain.
To 6.
Because this is not a valid value for movement state.
You can just set it to is
but
idle
we
now.
can set it to player.jumping, for example. Now, when we later use this in our animator, they will actually be converted to int values, to whole numbers. And when we hover over any of these values here, we can see the corresponding int value. So we start at 0,
Okay.
idle, running is 1, jumping is 2, falling is 3, 4, 5, and so on. And when we go back,
I'm wondering if you could, because in Swift it's like you can use this, and then you can set the values not to numbers but to A, for example. But I actually can't hover over them and see something. But it doesn't matter. We don't need it probably anyway.
into our Unity project. After waiting for a few hours,
Oh my god, I forgot to switch scenes again. But you saw it on his too. The only things I did differently was I called them is idle and stuff like that. And what I explained in Swift you can do like this. And then not have this equal to 1, but for example equal to A. But we probably don't need that anyway. And you can remove that move state.isIdle and just use isIdle. But that's pretty much it. Invalid expression term. Okay. Maybe... Is it 15? Yeah, okay. Okay, maybe you can't remove move statement. And you have to use move statement.isIdle. In Swift you can remove that, but here you apparently can't. Hopefully this works now. Yeah, now it works. Okay. So in
we
C
can
sharp
remove
you
our
can't.
running boolean here because we won't use it anymore. So let's just click on it and press delete on the keyboard. Yes, we want to delete it. And create an int parameter instead. Because
okay.
Unity doesn't know about our movement state enum. But
State
as I already
probably.
said, we can convert it to an int. So let's just call it state. This way we don't have to manage a bunch of different boolean values. Instead we just have this one variable and we can change our animation state depending on it. Now the next step is a bit tedious. We have to go through all our connections here and add the corresponding state value to the conditions. So let's
idle is 0, right?
Let's start with all the arrows that point to idle. Remember, idle has the integer value
0,
0. So we go from running to idle under the condition that state is, and here it's important that you choose equals. Because now that we have whole numbers, we have these different options, greater than, less than, and so on.
Equal
We want to
running
switch to
was
idle only
1
if
probably.
state is exactly equal to 0, which is the enum value for idle. Let's do the same for the other animations that point to idle. So this one here, remember to untick has exit time and set the transition duration to 0.
What is actually tedious?
And add state equals 0 here as well.
Equals 0.
Then we have one that points from falling to idle. The same process.
Okay, that's the last one, I guess.
And that should be all
Exit
animations
time,
that go to idle.
0.
It should always be 3 transitions to each of our 4 different states.
Yeah.
So next let's take care of running. So everything that
Running
points
was 1,
to running
right?
has the condition that state is 1.
Yeah.
Because remember, the int value of our running enum is 1. So this one points to running.
This one.
This one points to running. We set this up properly. State equals 1. And this one here.
Let me check quick. Is jumping is 2 then?
Okay, the next one is falling. And if we forget one, don't worry, you will later notice it. When we play our game, something will be off. But we can always change this. Let's go to jumping next, actually, because this has the int value 2. So we remove this.
0 state 2
equals exactly 2. We have one from running to jumping.
Oh, there has to be a way.
And we have one from
this fast
falling to
falling
jumping.
Is 3 then. Logically.
And lastly, falling itself
has to be done.
Which has the int value 3.
Okay, should be everything. I hope.
And this one here. So take your time, and if you forget what the corresponding int value for one of our enum states is, just check it in Visual Studio. And now I should have set up all of them properly. But as I already said, if we messed something up, we will notice it.
Yeah, okay, looks pretty good.
Or later. But it looks good to me. Nice. Now let's go back into our player movement script and set the state value at the correct places. First of all, we delete this line here because we don't need this variable. We will set the state directly on our animator, the same as we did it before with our running boolean.
Oh, okay.
So we remove this line. And then we go into our update animation state method here. Now we don't want to call anim.setInteger over and over again because it's very tedious to write it out again and again. And it also makes it more likely to add mistakes or typos in the variable name. Instead, we want to call it one time at the end of our method with anim.setInteger. Whereas the first argument we pass the name of the variable in Unity here. So it's state with the exact same spelling.
State.
Comma and the value of the animation state.
We just changed
a local variable at the start of update animation state of type movement state, the enum we created. And we call it state, but we don't assign a value yet. We will assign the correct value depending if we are moving left or right, jumping, falling, and so on. So below it. So in the first branch, dirx greater than 0, we remove the set bool call, and instead we just want to set our state to movement state dot running. We want to do the same here.
No way you can just set it to.
And here we want to set the state back to idle. Which has the same.
Let me just check that because this saves so much code, but you actually can't. There's no way you can't in C#. Ah, never mind.
Fact as before, just that we now use our enum. And below the last else, we put another if check for our jumping animation. Now it's important that you don't write else if here, because we want to check for jumping even if we already checked for running, because jumping has a higher priority. So even if we already said, okay, we are moving left or right and we want to apply the running animation, we still want to check if we need to replace it for the jumping animation, because while we are in the air, we don't want to see a running or idling animation at all. So we put it below the else blocks for the running animation. And this way it will execute this part first, and then it will execute the part here below, which means that our state will be overwritten if we are actually jumping or falling. If this sounds confusing to you, just think your way through what is happening here a few times and then try to draw a picture in your head how the state is changing under the different conditions, and then you will eventually get it. Because this is not complicated, it's just a bit confusing. Now for jumping, we don't have an axis value like our dirx we have for the horizontal movement that we could use to check here. Now theoretically, we could switch to the jumping animation in the get button down block here. But think about this. This will only be executed one time, and then in the next frame this will already return false because we are holding the button, we are not pressing it down anymore. which means that we would apply this animation, but in the next frame, we would execute update again, and we would overwrite the jump animation with the running or idling animation, because those are checked for in each frame, because the DIRX value keeps its value while we are moving. What we can do instead is we can check for the Y velocity to decide if we are jumping or falling or standing on the ground, because this will keep a value between the different frames. As long as we are in the air, this will not be 0. So what we do in this if block here is we check if the velocity of the rigid body, so if RB
okay, we check the velocity,
dot y is greater than 0, then we know that we are jumping because we have a force upwards applied. Makes sense, right? We are not standing on the ground. Now instead of 0, we write 0.1f here, because there's actually a bit of imprecision when it comes to these velocity values. They are not exactly 0.
Are you serious? You can't write is greater than 0.1, but you can just set the state to dot is idle. Bro, come on.
Even if we are not moving. So if we would check for exactly 0, we would still get a jumping or falling animation, because the value is never exactly equal 0. Instead what we do is we use a very small value. Now 0.1f is enough, but you can even go smaller, because actually the imprecision is much smaller. It's like 0.0000 something 1, but this is fine. This works properly and it looks good.
Okay.
So if the Y velocity is greater than 0.1, we know that we have an upwards force applied, which means that we are jumping. So we set the state to movement state dot jumping. If this is not the case, we want to check if we might be falling. So below we write else if rb.velocity.y is less than minus 0.1f.
Oh, you
so
can
we have a
write minus dot 1. Okay.
Then we want to set the state to state.falling.
Not mono-behavior movement.
So now we set state to a value in each of these branches here. And then down here we just want to pass it and close it with a semicolon. Now this shows a warning because this expects an integer and our state is our enum. But as we already said, each of these enum values has an integer value to it. So what we have to do is we have to go before state here, and in parentheses we write int. This casts this.
And then Swift you would write like that, and then int in parentheses state. But let's write it like this.
State value to an int. So it turns the enum into its corresponding integer representation, which we can.
No, you wouldn't actually do this. You would just do this if you had like a status is like a string, and you want the integer from the string, or you want the string from the integer, for example. You would write raw value to get the integer value. Moin Paul.
In Unity. So let's save the script, and since we have already set up all the different animation transitions, this should now work. So let's go back to Unity and run our game. And we can also keep the animator tab opened to see how we are switching between these different animations. We're jumping, falling.
Can it be applied over vector 2 and float? Oh, dot y, okay. Nee, kein Velo. Bin gerade beschäftigt.
And it looks good to me.
Yeah. Oh.
And we switch between it.
No, it looks weird. We're just constantly falling. Why are we constantly falling? Less than minus 0.1. Oh, because I set it to greater than -0.1, okay.
And run our game. And we can also keep the animator tab opened to see how we are switching between these different animations. We're jumping, falling,
now it should work.
And it looks good to me.
Yeah, now it works.
And we switch between the different
game over
states at the correct time. Of course, we can still jump while we are in the air, but we will take care of this in a moment.
No.
Now, instead of DIRX, we could also use the X velocity to check if we are running or standing still. That's up to your personal preference. When we do it like this with DIRX, we only switch to running if we actually press any of the movement keys.
Probably better.
If we would use
like
the X velocity, then we would also switch to running if we apply velocity through any other means. For example, collision with an object. That's up to your personal preference. I think it makes sense to use the velocity when jumping or falling, but I prefer to use the horizontal axis for the running animation.
I think that's better as well.
Now our game actually starts looking like a game. So don't give up now, we are almost halfway through this.
I can't, I just can't. Every time he does this outro, completely monotone, and looks like he's no fun. It's just a good.
In the next part we will take care of some little bugs we have right now, for example that we can jump while we are in the air. So stay tuned for the next part, don't forget to subscribe to the channel, and see you there.
Let's go.
So
we're about halfway done, no?
Super cool animations.
Yeah, we're actually about halfway done, because these videos are shorter than the first ones.
But right now our player can just fly off into the orbit, because we can press the jump button down over and over again, and every time we apply this Y velocity. In this part we want to get rid of this, so that our player can only jump after we have hit the ground. So let's do this. Now one option to handle this would be to...
We had some different options to solve this problem in the basics tutorial, and let's see. I'm interested what kind of solution he has. If it's one of those in the basics tutorial, or if it's another one.
To check for a collision between the player and the terrain, because both the player and the terrain have a collider applied to it. And we could check if they collide and then say, okay, we are grounded, and then we can jump again. But the problem with this approach is that this will also detect a collision if we are on the edges, for example, on the right or left side. Okay, no, this is left and this is right. If we touch the sides or even the bottom of our platform, we can also jump because it's a collision. Instead, we will use a different approach that is slightly more complicated, but it works, and it's also not a lot of code. It's actually just one line that checks for the grounding. So let's go back into our player movement script.
One sec. Okay. Is this still the same? Okay, yeah, looks good.
Visual Studio, and add this here. What we do is we create a separate method for it. Private, and it has to return a boolean, because this method decides if we are grounded, so if we are standing on the ground or not. If we are standing on the ground, it will return true, and if we call it while we are in the air, it will return false. So the return type of this method is not
you actually write it like
it's
this.
bool.
Okay.
And we give it a name. Let's call it isGrounded. But for our approach here, we still need a reference to the box.
Okay, this I think is kind of weird, because if you make a variable, you have private bool, I don't know, is grounded. Let's say you wanted to make this a variable. Then you write it like this, and if it's a function, you write it exactly the same, just with the parentheses. I don't know. Let's say. I guess it's C#. I like this funky a bit more in Swift.
Box collider of our player. And we already know how this works. We create a variable for it. Let's put it here at the top. I put it below the rigid body. Private box collider 2D. And let's call it short call. We assign our new friend call in start with get component.
Call.
And then we can use it in our code. Back, down, in is...
Whoa, chill. Get component, box collider to here.
And then we can use it in our code.
I mean, you could actually do it like this also, but I think that's a bit too much.
Back,
you don't need it.
In is grounded. We do a Zuccal.
This organized. You could also make it like this. I don't know. Looks okay.
Boxcast.
You don't
first
have
of
to,
all, let's write.
That's a bit unnecessary refactoring. I mean, it looks better. You can do it. It doesn't take a lot of time, but you can also just leave it be.
Out the whole code.
Let it be.
And then we go through it and I explain what it actually does. So here we write physics 2D dot boxcast parentheses. And this expects several arguments. The first one is the center of our box collider. So we write call.bounce.center. The second argument is the size of our box collider. So again, call.bounce.size this time. For the angle we pass 0 as a float. For the direction we pass vector.down, and again I will explain this in a moment. For the distance we pass 0.1f, and we will pass the last argument in a moment.
Okay.
Now I'm not 100% sure that
I understand. 6 parameters? 1, 2, 3, 4, 5. Yeah, it's 6 parameters actually.
Boxcast correctly myself, but I'm actually fully confident. What we basically
Bro doesn't understand it himself.
We create a box around our player that has the same shape as the box collider, so as this little green rectangle you can see here. We create another box like this. This is what these two arguments here are for, the center and the size of our box collider. It positions this second box over it basically. Now this 0 is just a rotation, it doesn't matter here because we don't want to rotate anything. And vector 2.down and this 1.f moves this box down just a tiny little bit. So instead of this green box here, you can imagine the other box just being offset a little bit downwards. And why is this useful? Because now we can use this other box to check if something overlaps with it. So if we are standing on the ground, and our new boxcast is slightly below our collider, then the boxcast will overlap with the ground. We can detect this and then we know that we are standing on the ground. But since we don't move our new box to the right or to the left, we won't detect any overlap with the right and left sides of the terrain. So this way we don't have this problem that we can jump when we are touching the walls of the terrain. But now we still have to check what our boxcast is overlapping with, because we only want to be able to jump when we are on the ground, right? We don't want to be able to jump when we hit an item, for example, that is floating in the air. So this is pretty simple. We just go to our terrain object and we want to apply a layer to it, because we can check for this layer and then make a decision depending on it.
It's the layer.
At the moment the layer is set to default. When we click on it, we can create our own layer. When we click on add layer. Let's use the user layer 6 here and call it ground. Then we click on our terrain again and we set the layer to ground.
Okay.
We want to pass this ground to our player movement script.
It's a decent solution
in our boxcast. So back into our script, we create a variable for it with a serialized field so we can pass it in the editor. I'm going to put it here, but again, you can put it below or above, doesn't matter. So angle brackets, serialized field, private, and when we want to pass a layer, we declare the type as a layer mask.
Layer mask.
And let's call the variable jumpable ground. We assign this later in the
Pretty
editor,
jumpable.
and then we pass this jumpable ground as the last argument to our boxcast. So now it checks if we are overlapping this jumpable ground. And the boxcast method itself returns a boolean. So if we are overlapping this ground, it returns true, otherwise it returns false. So we can just add return in front of it and return it from our own method. So now whenever we call is ground,
this thing returns a boolean. Okay. This doesn't look like it would return a boolean, but fair enough.
it will execute this boxcast and then return true or false depending if we are touching the ground or not. And again, you can imagine this just like a little box we are creating, which we move down by a tiny little bit, and then we check if this box is overlapping with the ground. And then we want to call this method when we press the jump button. So we scroll up. Here we have if input get button down jump. After jump, between the two closing parentheses, we write
we
two
use
ampersand
end now?
signs, which
Yeah,
is
we
a
use end
logical
now.
end, which means that only if this condition is true, but also the condition that we put to the right side of it is true, only then the if block will be executed. If either of these two conditions is false, it will not be executed. And you can already imagine what we put in here.
It's grounded.
We simply call our isGrounded method, which will return true or false. And earlier I showed you how you can get to the documentation of a component.
Wouldn't you use a... Oh, what's it called? A computed property? Is it a computed property? Where you have like, let's say public bool equals is grounded. So you can, this is actually a variable that changes, not a function itself. I guess you could, this would better fit in here, but I don't know if this is even a thing in C#.
Directly in Unity by clicking on this little question mark here. We have some similar functionality here for methods in Visual Studio. What we can do is we can click, for example, on boxcast with our mouse cursor. And then if everything is set up in your Visual Studio correctly, you can press Ctrl-Alt-M on Windows and then immediately press Ctrl-H afterwards. And it should open the web browser with the documentation for this method. But again, documentation tends to be really complicated, so don't get scared by this, but it's a useful.
I like this simple, this very minimalistic subscribe notification.
Because then you don't have to type it into Google manually. Okay, let's not forget to save our script and then let's see if this works. Run our game. I know we should only be able to jump when we hit the ground. We are not jumping at all right now.
Wait, we need to connect it, don't we? Did you connect that to anything? Okay, let's test it out. Maybe we don't need to connect it.
Because we have forgotten to set
I can't jump.
the layer mask attribute on the player. So we click on player, scroll down to our player movement script, and here jumpable ground, we can now select a layer for which we select ground.
Oh.
Let's try it again. And we can jump, and we cannot jump anymore while we are in the air. That's great.
That's a cool
And
solution.
we cannot
Honestly,
jump
I
while
like the
we are
best
on the sides of
from
our
the ones
platform
we
here.
had.
We can't jump, but we can stick to it, which is a different bug that we will take care of now. This one is much easier because there's a ready-made component that takes care of this.
But I
We
can't
go
jump
to
here.
our terrain. We add a new component to it. And this one is called Platform Effector 2D.
That's
we add
probably
this.
thicker to the- okay.
We untick use one way because this is some other stuff where you can jump through platforms from the bottom. We don't need this
Oh,
here.
okay.
And then we go to our composite collider and tick used by effector, which gets us rid of this warning. Let's try it again. And now it should work properly. Now when we touch the sides of our platform, we slide right off. And we also can't jump while we are not grounded. Okay, great.
Cool solution.
That's it for this part. If you feel that this was very difficult, don't worry. In my opinion, the most difficult part of this tutorial is over. The rest is basically just applying what we already know in different forms. And in the next part, we will learn how to add collectible items to our level, which is really cool. So stay tuned for that. Don't forget to subscribe to the channel. Leave a comment if you enjoyed this tutorial, like the video, and then we see us in the next part. Take care.
Bro's nose hole could also fit like 2 elephants.
A game without items that we can collect is pretty boring, because otherwise how am I supposed to fill the emptiness in my heart? So in this part we will learn how to add collectible items to our game and how to count them on the screen. So let's go. So when we navigate
to feel the emptiness.
Assets, Pixel Adventure, Assets, Items folder, and then into Fruits we have different collectible fruit items that we can put onto the screen. Which ones you choose is up to you. I'm gonna pick these cherries here again. And
look good, yeah.
First, before we forget it, let's set the pixels per unit value of all of these to 16 and apply it. And again, this cherry image is an animation and it's already chopped up for us into its separate images.
Wait, did he... oh, sprite mode is already multiple, never mind.
And it's already... To create a cherry, we need a new game object. So here in our hierarchy, we write...
What do we have here? We have apples, bananas, cherries, whoops, kiwis, melons, oranges, pineapples, and strawberries. Yeah, I guess cherries are fine.
Click, go to a 2D object, sprites, and then on square, which creates such a square similar to our player in the beginning. And by the way, this is just an empty game object with a sprite renderer applied to it. So instead we could also select create empty and then add the sprite renderer component manually. Those here are just shortcuts for us. So let's rename square to cherry.
Cherry blossom.
And then we keep cherry selected and we drag the first image here into the sprite renderer.
Oops.
Now this is basically just for the preview, similar to our player image, because when our game runs, this will immediately be replaced for the animation of this cherry.
What has he selected? Oh, he has this one selected, so he...
Since the sorting layer of this cherry is set to default, it will be in front of the background, but behind the terrain, which makes sense, it won't overlap with the terrain anyway. Next we have to create the animation for this cherry. So let's put it into the animations folder, right click, create animation. Let's call it cherry. Then again we have to drag it onto the cherry object to create the animator, which connects the animation to the game object.
Wait, it didn't create a... Oh, no it did. Okay, I just missed it.
Then we open the...
I should play a bit more aim labs.
Animation window. We select cherry. Then our cherry animation here is selected. We go back to the fruits folder where the animation files are. Select all of these, put them in here. Again, it's too fast. So I change samples to 30,
okay.
Which looks fine in my opinion, but again, that's personal taste. Let's close the animation window, go back to our cherry animation again and set it to looping. And since it's the only animation applied to cherry, it will start when the game starts automatically. And for the cherry, we don't want to switch to any other animations. But we want to be able to collect it, which happens when we touch it, right? And how do we detect when two objects touch? With a collider. So we...
Isn't that a bit fast? Let me just start it real quick. Because I think 30 is a bit fast. Yeah, I think it's a bit fast. I would maybe change it to like... Let's test out 20. I don't know. Let's keep it at 30. I think I just don't like the animation that much. And that's the problem, not the speed. Oh wait, these changes wouldn't have been saved anyway.
We will add a box collider 2D to our cherry game object. So we select cherry in the hierarchy, click on add component, and add a box collider 2D.
Another box collider. Box collider 2D. Remove components. Box collider 2D.
Then we click on edit collider to edit the boundaries. And let's make it a bit smaller than the actual sprite itself, because it feels better in the game.
That's actually interesting. I don't know why it is the case, but apparently you make this smaller because it feels better. Probably something like this. No, probably.
I think this is fine.
Something like this. Okay.
Then we click the edit collider button again to go out of edit mode. And here we will tick is trigger in the box collider 2D component. This way we can collide with the cherry, but we don't notice any interruption in the physics from it. So normally when we collide with it, we can't go through it, right? Now we will destroy the actual cherry object, so it disappears from the screen. But when we jump on it, we will still notice that we stop moving for a split second because we are colliding with it. When we tick is trigger, then we won't collide with it. We will still get notified when the box colliders overlap, so we can do all our stuff, but we won't notice the physical collision with it. We won't stop mid-air because we are hitting the cherry, which just feels better for collectible items.
Yeah,
now, of course, we need a script that handles the logic.
If you jump against it and then you just bounce off, or you can jump on top of it.
When we,
I mean, that's pretty much the Mario collectibles. You have these blocks where you can from under jump against them, and then here's my mouse. Jump from under against them, and then you get the item out of them, and you can also jump on top of them and against them from each side. That's pretty much the Mario blocks, but for a normal collectible, I guess it doesn't make much sense.
Collide with our cherry. We want to remove it from the game so it disappears, and maybe we want to increment a counter so we can keep track of how many cherries we collected. And now the question is, where do we put this newer component? We can put it, for example, on the cherry and then check if we are colliding with the player. We could also put it into the player movement script. Where we put it is really up to us, but I think it makes sense to put it on the player game object and actually, to create a separate...
I would have guessed it's better to put it on the cherry because, okay, well, probably you have just one player and that's why it's better to put it on the player instead of the cherry. But if you put it on the cherry, you would have at least a bit code less in the player object, and the cherry you probably don't have much code anyway. So that's why I would have guessed you put it on the cherry, but you probably have a lot of cherries and then you have repeating code for every cherry. So putting it on the player makes sense.
Script for it to keep it reusable. Because then we could add the script to different game objects than the player if they should be able to collect items. Maybe a second player, for example, for a two-player mode, or a completely different object. First of all, we need a way to distinguish between our cherries and other kinds of game objects. So we can do something with it in our C# code. Now, of course, we could just check for the name, which is cherry. But then if we rename it, or if we create additional cherries with a number appended to it, we get problems and we have to update our code or it won't work at all. Instead, we want to use a tag because we create this tag one time and then we can apply it to as many game objects as we want and use this tag to distinguish between these objects and other types of objects. So tags are a way to organize your objects so you can distinguish between them in code. So select the cherry, then click on tag here and then on add tag. And here we click the plus button and we call it cherry.
Okay.
And then when we click on the cherry game object again, we select the cherry tag.
I mean, I wouldn't call them.
Now to make it even more
tags,
reusable, you could also name this tag collectible item or something like
fruit.
that.
Yeah.
And then use this tag on all your collectible items, not only on cherries. But I want to know later what kind of item we are collecting exactly, because I want to show a counter just for cherries.
Well, could also be like cherries are worth 5 points and maybe a banana is worth 2 points or something. Probably for that you would also need different kind of tags. Or if, for example, what he said, you have different collectibles and just have a count for each collectible.
The screen, so I need to be more explicit with this tag. Then, as we already said, we want to add a newer item collection script to our player. So we click on player, add component. We can write out the name, item collector, and then click on new script. Alternatively, what we can also do is we can go to our scripts folder, right click here, create, and then C# script, which has the benefit that we already have it in the correct folder then.
Oh, we don't do that. We don't have that with this solution already. Yeah, now it's here instead of in scripts. But I mean, works.
And then open it
in both ways
in our IDE. We don't need.
By the way, I can really suggest Visual Studio Code because it's pretty easy to use. Looks good. I don't actually know what the competitors kind of are, but I'm fine with VS Code.
Start and update here. Instead, we just want to do something.
Just remove everything
when we collide with the cherry. So we want to overwrite on trigger enter 2D. It's on trigger enter 2D because we.
Yay! I can completely write this on my own because I don't have auto completion. Let's go. Private void on trigger enter 2D collider 2D collision. Oops. This happens sometimes. That I don't know why, but I see this big 2 and the big D, and I just press shift on the 2 as well. This is the time when I like Mac, because on Mac you can just kind of select what you see on screen. So in the video, I could just select what he typed and copy paste it instead of typing it on my own.
It's on trigger enter 2D.
That's a pretty cool feature. Probably using text, some text AI to guess what the texts are you see on screen.
Because we
or to identify the text on screen.
Set the box collider of our cherry to is trigger. If we hadn't done this, we would have to use on collision enter 2D. Now, how do you know what kind of method you have to use? How did I know that I have to use on trigger?
You Googled it.
Now, one way is to just try auto-completion and type something in like trigger, because you know that you use the trigger in the Unity editor. But normally you just Google this stuff. When I try to figure this out, I Googled something like Unity, how to collect
programming
items,
is just
and
Googling.
you will find solutions for pretty much every
a different word for Googling.
So you really have to get used to using Google a lot, and it will tell you what to use. And in this
or nowadays ChatGPT for simple things. Or generally, you can generally ask ChatGPT, but I find for more specific or complicated things, Stack Overflow or real humans for that matter probably have to give better answers than ChatGPT sometimes has.
This method we get,
and I don't know what's up with Bing and maybe other AIs, because I know that Bing has an AI who can access the current internet, so maybe this could also help in these kinds of situations.
Has this collision argument here, which means that Unity gives it to us so we can use it inside this method when it is called. And it contains information about what we collided with. We can use it to check if collision.gameObject, and then we want to check the tag of this game object. We want to see if it contains our cherry tag. So we call compare tag and pass the tag as a string argument to this method. And again, it has to have the exact same spelling as the tag we added to our cherry. So we pass cherry with a capital Z. So if we are colliding with one of our cherries, we want to execute the code in this block here. One thing we want to do is we want to remove the item from the game so it disappears. For this we can call the destroy method, where we have to pass the game object we want to destroy, which again we get with collision.gameObject, because now we know that this is our cherry. So we close this with a semicolon, save our script, go back into Unity, and now first of all we have to add this item collector script to our player. So we select player, add component, we type in item collector and choose
item collector. Wait, what?
Here, and player. So we select player, add component, we type in item collector.
Oh, he created that in here. That's why he doesn't have item collector in the player object already. I was confused.
Now we should be able to collide with our cherry and remove it from the scene. And we should not notice any collision with it because we have set it to a trigger. We should be able to jump right through it. And this works.
Nice.
And when it happened, the cherry game object was also removed from the hierarchy. Because we destroyed it. If it didn't work, make sure that you have tagged the cherry correctly. And if the cherry
probably, give me a second. I should probably make this a bit bigger. We had background, tile palettes, backgrounds. This. And then let's do something like we don't need that much here. Let's make something like this. And then maybe remove this. Yeah. I guess that's better. Then we don't see the background on top of here every time. Or do we? Voice crack? No, we don't. Okay.
Completely disappears from the screen when you start the game. Make sure that.
Okay, here it's good again, because if you would play and remove the cherry, then you don't have the cherry when going out of game mode. But if you change something by hand, I don't know. Maybe you could save it some way, or you just accept the fact that it works like that and have to be paranoid for all of using Unity.
That the Z position is 0. Otherwise, as I already explained, it's possible that it is behind the camera.
Possible.
But just removing the cherry from the screen is a bit boring. We also want to count our cherries. So let's go back into our item collector script. And here we create an int variable at the top that counts our cherries. Integer because it's a whole number. We don't have 0.1 cherries or something like that.
Makes sense.
So we don't need a float. And we initialize this with 0 because when we start the game, we don't have any cherries yet.
Probably don't need this.
Now we don't throw this variable declaration into onTriggerEnder, because then it would be a newly created every time this method is called, and we would start at 0 again. Instead, we want to keep the counter as long as this level is active.
And then
we make it a property,
plus, right?
Or in other words, a variable inside the class body of the item collector. Then after we've destroyed our cherry here, we want to increment this value. So we write cherries plus plus semicolon.
Yeah.
This is the equivalent of writing cherries equals cherries plus 1.
Or
This
plus
plus
equal
plus
1.
is just a shorthand for it. Now before we display this cherries,
just to show you, or you could write it like that, but shorter like this. If you just increment by 1, then you can write this.
Our screen, let's just print it to the console to see if it works. So below we write debug.log, and as the text we write cherries colon space, and outside of the string we write plus cherries. So this will take this cherries number and add it to our string, and in the process
okay, just in the debug,
turn it into a string.
I hope, and I guess he's going to make an overlay displaying the cherries and the count of cherries. But for now it's just in the debug log.
So we can show.
So the thing we have at the bottom. You don't really see this in game.
Number behind the colon here. We save this. Go back to Unity. Now before we try this out, let's add more cherries to our game, so we actually have a few that we can collect. And what we do is we go to our assets folder here, and then we take this cherry game object and drag it down here, which creates a so-called prefab. Prefabs are very important in Unity. They are basically templates for
making a new folder
objects.
for that.
So all the settings we have made on our cherry object are now also saved in this cherry prefab. Our sprite renderer with the cherry sprite, our animator, the box collider, everything is also set on this prefab. And now we can use this to add more cherries to our game. And the useful thing about prefabs is that we can now make changes to the prefab, and these changes will be applied to all cherries in our game.
Yeah.
For this we either double click on prefab, or we click on this little right arrow here next to our cherry to get to the prefab itself.
Oh damn.
And then we can make changes here.
This looks
and they
wild.
will be applied to all cherries that use this prefab. And you can also see that the text color of the cherry game object turned bluer, which indicates that this object is using a prefab.
Oh. Let's see how he does this, but I would probably create a empty kind of, but really it's a folder, and call it collectibles, and then put the cherries into there, and then maybe put it into grid, but I don't know. I would probably put it into grid.
First of all, let's set these cherries to the same height. So the transform positioner y value of our first cherry is 1 point something. Let's set it to a 1.3. And let's also set the y position of our other cherries to 1.3.
Can you select all of them?
And let's
make
space them out evenly.
1.3.
So let's say the first one gets the x position 4. The second cherry gets x position 8, or let's say 6. Oh no, let's actually keep 8. And the third cherry
12.
gets the x position 12. Now they are spaced out evenly and have the same height.
Yeah.
And to not make our hierarchy here too messy, we can also organize them. For organization, we can just create an empty object. You don't have to actually use it to display it in your game. You can also just use it for organization.
As a folder.
So
I don't know why they don't have folders, but...
or cherries or whatever you want. And then we can drag our cherries onto it to nest them under this empty object. And now we can hide this by clicking this.
Okay, now the question is, does he put collectibles into grid?
Error here. This is just for organization. But what's also useful is that we can now change the position of this whole parent, and it will move all our cherries.
Good to know.
Let's create a folder for our prefabs, and by the way, the terrain map is also a prefab. So we put it in there as well. New folder, and we call it prefabs. And then we drag cherries in there.
Did exactly that. Oh my god, you can't see. I'm so sorry. but you saw what we did at the bottom at it exactly the same. I just created this collectibles folder, you can call it folder, a bit earlier than he did. And no, I actually didn't, I just talked about it, but I organized it in prefab already.
And then let's switch to the console and run our game and see if we actually count our cherries we collected.
Okay.
We can ignore this warning here.
I'm removing my cam for this.
Cherries 1, cherries 2, cherries 3.
Yeah, you see this,
so this works.
Debug console.
Now let's display this counter on the screen instead. So we right click in our hierarchy again, go to UI, which is short for user interface, and we create a text. This automatically creates this canvas object, which is the thing where we can put UI elements on.
I don't have this text.
And it nests a text below it.
The text is Pro Legacy? Oh, it's Legacy text.
Now when we select Cherries text, go with the mouse over the scene view and press F. We go to it, and you can see that this is much bigger than the scene itself. It's a bit confusing in the beginning, but this is actually it's the screen size basically.
Wait, how did he get there?
Now when we select Cherries text, go with the mouse over the scene view and press F. We go to it, and you can see that this is much bigger.
Bro, I added this, oh god, while I was in play mode. Okay, we have it here under Legacy text. And then Cherries text. And then over here and press F. Holy
then the scene itself, it's a bit confusing in the beginning, but this is actually it's the screen size basically. This is why this is so big. But here we can place our UI elements, and they will overlap on our scene viewer when we play the game. So let's just try it out. Let's put it here in the top left and start the game, and you will see that the text is in the top left here. And when we move, it stays in the top left. When we select this text, we can change the text that's written inside it here. Let's set it to cherries:0 because this is what we start out with, but we will then change this text from our C# script. Now let's also change the font because Arial, which is the only font that's available in our game here by default, is a bit ugly. And you can get really nice free fonts at fonts.google.com.
Fonts.google.com.
And there is one that looks like a game, and it's called Press Start 2P.
This site can't be reached. It's a site. Bro. Through fonts. What? It's fonts.google.com. But I can't reach it if I just type fonts.google.com. Okay. Press start 2P. Oh yeah, okay, that's basic.
Which looks like this. Really cool in my opinion.
Gaming.
To download this font, we click on Download Family. Save it on our PC. It's downloaded as a zip file, so we have to unzip it. And this is our font file here. So we go back into our Unity editor. Open the project viewer. Let's create a new folder for it to keep it organized, and we call it fonts. And then
one sec. Folder fonts.
We just drag and drop it directly from our Explorer into the fonts folder.
Oh, okay.
And that is. If you weren't able to follow along, you can also just use the normal Arial font and skip this part completely. And now when we click on Cherries text, we can either drag and drop it.
What is event system? Oh, I don't know.
In here, like we did before for other stuff in the components, but we can also click this button and then select it from the window that opens up. So double click on it, And now it changed to the...
Bro, this color looks so ugly, holy shit.
Newer press start font. Now we can keep the font size and everything else as it is. And then we click here on this icon. And then select this image where we have this dot in the top left corner. Which means that if the size of the screen changes, this text will always be anchored to the top left corner so it doesn't move into weird places if we have a completely different screen resolution. Let's run our game one more time to see if the text is displayed correctly. Looks nice, but of course it doesn't work yet because we haven't told Unity to update this value yet. Which of course happens in our item collector script. So back into Visual Studio. First of all, we need a reference to our new text so we can update it. So we create a new variable for it with the serialize field tag because we need to add it in the editor. We make it private, of course, text. And it's of type text.
Yeah, text.
But the IDE won't find this type yet because we have to import the namespace first. This line here, using Unity Engine, means that we can use classes that are contained in this package in our code.
Okay. Does he use alphabetical?
This is enough for all the basic stuff, but sometimes we have to add additional packages.
Alphabetical sorting.
Because, for example, our UI related stuff is not contained in this Unity Engine here. So below we add using Unity Engine dot UI semicolon. And now it finds the text type.
.ui.
We call it cherries text. And then we just want to update it in our onTriggerEnder method here. Instead of showing the count in the console, we want to update our cherries text. So we write cherries text, which is the game object, dot text, which is the text component in our game object. So we want to access this one here, which is called text. And for this one, we don't have to call getComponent. Instead, we have this shorthand here, which is just there for convenience. We want to assign this to a new string, the same as we have written to the console before. Cherries colon plus cherries, so it appends the number.
Just cherries, okay.
And that's it.
That's it.
So let's save it. Go back into Unity.
Bro, I like how we...
Wait until it has reloaded with our new changes. Go to our item collector script, which sits on the player object.
I like how we make simple steps towards a playable game, a decent, okay game. It's not like crazy, but it's playable.
And now we have this cherries text field here.
But it's not updating. Okay, well.
And of course, we just take our cherries text and drag and drop it in here. And now this cherries text is connected.
Wait, what? Okay, give me a second. I wasn't paying attention at all.
Our item collector script, which sits on the player object. And now we have this cherries text field here. And of course, we just take our cherries text and drag and drop it in here.
Okay.
And now this cherries text is connected to our item collector script.
Now it should work.
And now our text should update when we collect cherries. And it works. Very nice.
Let's go.
And when we created our canvas, we also got this event system game object. This is just necessary to handle stuff like mouse clicks on buttons and so on. It's created automatically. You don't have to care about this, just don't delete it. That's it for this part. In the next part we will talk about something very scary. You really don't want to miss that, so make sure to subscribe and
very scary. Okay. Player dev logic, okay. I see what you mean with very scary.
All have to die eventually. And the same is the case for our player. But at least we can make it look cool. So in this part we will learn how our player can collide with traps, then show a death animation in response to it and restart the level. So let's go. First of all, let's add a trap to our game that the user can run into. And in our Pixel Adventure folder here we have assets, traps, and then different kind of traps that we can add to our game. we are going to use the spikes here, which is basically just one sprite. So let's go back into our scene. You can either scroll into it, or let's just click the camera, hover over the scene view and press F. And now we want to add this sprite to our scene. So instead of right click, create new sprite, we can also just drag and drop this onto the scene view and it will automatically create a sprite, which has the name of the image file. So let's rename this to spikes. And of course we have to change the pixels per unit value, otherwise it will be displayed very small. And 16, there are our spikes. Let's hit W to select the movement tool.
Apply TF single.
Very small.
Yeah,
and there are our spikes. Let's hit W to select the movement tool. And then let's move it somewhere here. And let's be pretty exact, because these spikes won't have gravity applied to them because we don't add a rigid body. Now let's also put the player a bit more to the left, and the camera place doesn't matter because it will be changed from our camera controller script as soon as we start the game. It will be set to the position of the player object. But our spikes need a box collider. So we add a new component, box collider 2D. Let's set up the boundaries properly. Let's put it here like this. Let's make it a bit smaller.
Bro, I want to... Wait, what? Oh, it was edit collider. Yeah, it was edit collider. Why don't we just make the hitbox bigger? And make everyone tilt because the hitbox of these spikes is bigger than the splash art.
This will work. And as soon as the box collider of the player object and the box collider of the spikes collide, the player will die after we have set it up. And this time we don't select as trigger because we don't need to walk through these spikes. Now before we write the logic that kills the player, let's prepare an animation for it, because it's better if we have some sort of feedback when the player dies. So again, Pixel Adventure assets, main characters, and here we have these appearing and disappearing animations. Now they look a bit like teleportation. Maybe they are meant for a teleportation feature, but we will use them for player dev. And for this we go into our animations folder, create a new animation as we have already done 1,000 times.
True.
Call it player_dev. Drag it onto the player object to put it into our animator.
It's good for learning.
Open the animation window. Select player. In the hierarchy, select player dev. Go back to the folder where the animations are.
I missed it again, I guess. Oh yeah, okay. Player, and no player, yeah, no player dev. Player dev. And then we have main characters, virtual guy, no, not virtual guy, just main character.
See how they look. Of course they have the wrong size. So let's select both appearing and disappearing. Set the pixels per unit value to 16. Now it has the correct size. And let's change the samples value to 18, which looks fine in my opinion. Okay, the next stop is of course the animator for the player, where we now have this player dev state. And this time it's easier because we can just make a transition from any state to dev. Because no matter what we have done before, the player can die, no matter if he is idling, running, jumping, and so on. The player can transition to the dev animation from any of our movement states here, but not from dev back to a movement state, because after we died, we will just restart the whole level. Which also means that we don't need to add the dev state to our movement state enum we created earlier, because we don't need to switch back and forth between these different states. When the player is dev, it's basically over. So what we do instead is we create another parameter and we choose trigger this time.
Okay.
And as the name implies, this trigger can fire off and then the animation will be applied. But the trigger is not a value we can change afterwards. It's a one-off event, basically. Exactly what we need.
A boolean that you can
because
change
we
back.
Only need to die basically one time, and then we restart the whole level, which will reset everything else. So we call this trigger def, not like this, like this. Then we click on the transition from any state to player def. Uncheck has exit time, set the transition duration to 0. And under conditions, we add the def trigger, which doesn't have anything else because, again, it's just a one-off event. As soon as we set this trigger, it will be applied and we will switch to the def animation. Again, it makes sense to put this whole def logic into its own script that we apply to the player. We could also put it into movement or wherever we want, but it makes it easier to keep it organized. It makes sense to keep these scripts small and only give them a single major responsibility. So let's go into the project view, into assets and into our scripts folder and create a new C# script that we call player live.
Player live, okay.
And then let's open it in Visual Studio by double clicking it. We don't need update this time, but let's remove this comment up here and make start private. And as I already explained earlier, if our collider is not set as a trigger, we detect collision with the onCollisionEnter, not this one, onCollisionEnter2D method, where again we get past the collision from which we can get information what we collided with. To distinguish between traps and other game objects, you already know what we have to do. We have to add a tag to our spikes.
Yeah.
So we click on spikes, then add tag, and let's call it trap.
Sure.
Then we click on spikes again, set the trap tag on it, and we will reuse the same tag for other kinds of trap.
Yeah, makes sense because you die on every trap, so you don't need different ones.
In the future, whenever we want to die when we touch it. So we go back into our player live script, and in here we can now check if collision.gameObject.compareTag, and by the way, you can also compare tags like this with .tag, two equal signs and then a string, but the IDE will show you a warning because compare tag is simply more efficient. So you should do it like this, and the tag was called
performance. Let's go.
If we are colliding with a trap game object, then we want the player to die. And let's put this logic into a separate method for better organization, which we will call die. So we call it here and create it below. It doesn't return anything, so it's just a private void die. So what do we want to do in here? Now one thing we want to do is we want to switch to the def animation. So let's do this first. Of course we need a reference to the animator. We already know how this works. We create a property, private animator, which we call anim. We assign it in start. Get component, animator,
get component,
and in die, we want to set our trigger, which we do the following way. Animator, set trigger, and then just the name of the trigger in our animator in Unity.
Trigger, okay, I don't have that auto-completion. But hey, this time we had a bunch of auto-completion.
Trigger. And then the animator will switch to the def animation. because we have added this trigger as a condition to this transition here. Of course, we have to apply this new script as a component to our player. So add component, player
Bro, this is getting long.
live. And then when we start it and touch the spikes, we should see the death animation.
Compiler error string does not contain a definition for compare tag. Accepting a first argument of type string. Wait, what? Collision game? Oh, dot tag that compared. Oh, it was just compare tag. Okay. Now it should work. Right? Yeah, okay.
So we have added this trigger as a condition to this transition here. Animation. Because we have added this trigger as a condition to this transition here.
Because now it should work.
Of course, we have to apply this new script as a component to our player.
I think we already did this. Okay, here.
Which we this time don't want to loop because it should only be played one time. Now, as we can already see, there are a few things wrong with this. First of all,
this should probably
we
disappear.
are stuck at the last frame of the animation, but we want this to disappear. And even worse, we can still move around. And we can still
What?
jump. And we can still collect cherries. So let's take care of this.
Lol.
First of all, we want to disable movement for our player. And one option would be to just disable the whole player movement component. But there's also a different way. We can also set the body type of the rigid body of our player to static. Static means that it can't move around at all, and physics are also not applied to it. And we can change it to static directly from our player live script.
Okay.
So let's do that. Let's go back to Visual Studio. We need a reference to the rigid body component of this object. So rigid body 2D. We already know the drill.
Bro. Okay, I have to do this for completion. Wait. Okay, yeah. It's component body 2D.
And inside die, we can change our rigid body to static with rb.bodyType.
So turn it here.
And again, you find this out in Google what you have to use.
Body type.
And then we type rigid body type 2D
Body
with a capital R. Dot static. We save this.
static.
Go back to Unity and try this out. And we can actually see the rigid body changing in real time while we are playing. So take a look at this part here where it says dynamic. And now when we touch our spikes, this will change to static.
Probably have to restart.
And then we can't move around anymore, even if I click buttons. So this already disables the movement for the player. What we now want to do is we want this sprite here to disappear.
Change to static.
And then we want to reload the level. But I don't want to reload it immediately. I want to have like a second or two before it reloads because I think it feels nicer.
Yeah, I can agree.
So let's do this. Let's go back into our script and create a method that reloads the level. Private void, we call it restart level. And how do we do this? Now, first of all, we have to import another namespace up here, the same as we had to do it for the UI parts. This time we have to write using Unity engine dot scene management. And then down here, we can reload the same level the following way. Scene manager dot load scene, and again a scene is basically a level.
Load scene.
And in parentheses we pass scene manager dot get active scene, which is the scene that we are currently playing. And we pair of parentheses because this is a method dot name, because this load scene method expects the name of the scene. And then we close this. Okay, this will reload the current level. Now the question is, where do we call this method? We can't call it here directly in die because then it will be executed immediately. But we want to have a short delay before this happens. Now there are different ways to handle this. We could do this directly here in code and set a delay of a few seconds or something like that.
Async. Wait, what was it? Something async, that's the main. Then you can add a value, how long it should wait. In Swift, obviously, not in C#, I guess. Hey, maybe.
But a really cool way to handle this is to let the dev animation itself call our restart level method at the appropriate time. So let's go back into Unity. Then we open the animation window, select the player, go to the dev animation that we have already set up earlier. And the reason why we always see the last sprite is because this animation doesn't contain an empty sprite, an invisible sprite. What we can do instead is we can click this record button here, and now any changes we make to this object will be applied to this animation. So let's put the cursor of this animation here behind the last sprite of this animation. The first one that's actually empty. And then what we do is we untick the sprite renderer. And the sprite renderer, remember, is the component that draws the sprite on the screen. By checking it off, we make the sprite invisible. And this will now be applied as another step to this animation. Then we click this record button again. And now this animation contains this additional step where the sprite renderer is checked off. And you can actually see how it's removing the check mark here on the left side, and our sprite disappears. When the dev animation is over, we want to call our restart level method from our player live script. And we can do this directly from an animation by adding an animation event, which we do over this button here. But remember that we said that we want to have a little delay before this happens. So I don't put this directly behind the last animation frame. Instead, I put it somewhere here, for example, to 106, which is a bit longer than 1 second. So we put the cursor here, add an animation event, and then here in the inspector, we have to select a method we want to call. And we want to call restart level, and we have access to this method because it's on the same game object as this animation. We want to call restart level. And now we will play this animation, hide the sprite, and then it will run for another second before we call our restart level method, which will basically reset everything.
Should work.
So let's close the animation window and try this out. We click on play. And when we jump on a
then we die
trap
and respawn. Oh, nice. Let's go.
And after a short moment, the level is restarted. And we also can't move around after we've died.
Oh, and the cherries are also resetting.
Now you will notice this warning here at the bottom. Cannot use velocity on static body, because after we have set our player to static, we can't move around anymore. But this is a kind of warning that you can just ignore because it's expected.
Just ignore it.
Now, of course, you can also add finite lives to your game, but I won't cover this in this tutorial. I will probably make a separate tutorial about this in the future. And we also die when we touch our spikes from the left or right side.
Makes sense.
If you only want to die when you jump on the top, then you have to set it up a bit differently. Again, I will cover this in different separate tutorials in the future.
Makes sense if you run against
them. And now if we want to add more of these spikes to our game, we should of course make them a prefab first. So we drag spikes into the prefabs folder. And then we can drag more of them on the screen and move them around. And by the way, when you move an object with this move tool, you can hold Control down and then it will move in increments of 1/4 of a game unit. Or maybe it's even less than that, but it feels better than just moving it around freely, at least for these pixel games.
4.
But you don't have to use this. So I put it here, And again, since this is now a prefab, whenever we make changes to the prefab itself, it will automatically be applied to all the spikes objects in our game. And the second spikes will work exactly the same as the first one. When we touch it, we die.
Wait, this could probably be pretty hard. I don't know.
Let's also organize this.
If the space is enough. Is it though? Because, I mean, the player model looks bigger than it is, but we barely, holy shit, we barely fit. Okay, but this should... Okay, this already kind of hard. Because it's like, I don't know if it's completely pixel perfect, but at least it's pretty damn close to it. Oh, okay, this is hard. And I think you can't skip them. Okay. I'm trying to beat it, but yeah, okay, it's getting a bit challenging. Let's go. Okay, it's doable, but it's actually hard. Kind of.
Because we will add more traps in the future, so we create an empty game object.
Called traps.
Let's call it traps. And put our spikes in it. Great. So now that we have collectible items and traps and our dev logic, our game actually starts to feel like a real game. But
Motivation
we still have to add some more stuff.
.mp4.
We, for example, want to add sound effects to our game. We want to add different levels. We want to add a starting screen and an end screen. And we also want to add some other stuff. So make sure to not miss any of that. Subscribe to the channel if you haven't yet. Please leave a like because it really helps this channel. And then we see us in the next part. Take care.
And let's go. Next part.
So now our player can run, he can jump, he can collect stuff, he can die. But sometimes he might just want to relax for a little bit. So in this part we will create moving platforms in our game world where the player can jump on and then be transported around with it. I think that's a really cool feature.
Yeah.
And we will learn a lot of new stuff in the process. So let's go. So back in the Unity editor, first of all, let's make our game world a bit bigger. For this we open the grid, because here we draw our tile map on, and I'm gonna start with the background. And I switch to the tile palette. Make sure that the active tile map is set to background.
Yeah.
Select our background here. I used the rectangular drawing tool. And when we jumped, it was also not high enough, so I go a bit bigger. And it's better to make it a bit too big than too small. And then what I want to do is I want to have a part here in the middle with spikes on it. That's too big for the player to jump over. Instead, he has to jump on the moving platform and get transported over it. So first of all, we have to select the terrain tile map. Otherwise, we're trying on the background. Then I'm going to select this piece here, the left part. Put it here next to our platform. Then I pick the middle piece and the rectangular drawing tool. So I can draw a long piece like this and the right piece and put it here. Then I'm going to use the pick tool where I can select tiles from my tile map, and then I select a big piece like this and put it here. And of course this also needs the ending part.
I'm in background. Oops. Wait, just let me remove this and then go to the Terra and then add this again. Something like this. And then take this. Put it. Bro, come on. Come on, man. I don't know how to move around. I mean, I know that you can do this, but Okay, let's do it like this, I guess. And then like that, and then here. So, okay. And then probably also use this and put it here.
Like this. And then I want to put spikes onto this middle piece.
Oh, fair.
So let's open traps, select one of those spikes and press Ctrl D, with which you can duplicate them. Then I hit W to select the move tool and put it down here. Like this.
Should be fine. And now
then I go ahead and use Ctrl D to duplicate this a few more times. So Ctrl D. And then I hold Ctrl down to get this incremental movement tool, which makes it easier to place them in the same position in the next tile. So again, Ctrl D, I hold Ctrl down and move it over. And then I do this a few more times.
And then hold Ctrl D. Okay, now it's just one more. There we go. Okay. Did he really just do it for every single one of them?
Like this.
Okay.
And luckily we have them all nested under our traps object here.
I maybe made it a bit wider than he did.
So I can just close it and our hierarchy here doesn't become too messy. And then we want to put our moving platform here. And the sprite for it is under Assets, Pixel Adventure, Assets, Traps. And here we have platforms. 2 different ones. You can pick whatever you like. I'm going to pick this one. And we will skip this one with the off animation state and just use the on animation state. And it consists of an animation. It's a really subtle animation where something is rotating, but it will look cool later.
Okay.
So let's right click in our hierarchy, create a new 2D object, sprites square. Let's call it moving platform. And by the way, you can put white spaces in this name, doesn't matter. You can only not put white spaces into C# scripts, or C# script names rather. So we click on moving platform, switch to the inspector, and then we drag the first image of our animation onto the sprite tab here. So we can see it.
It's small.
But of course it's small, so let's select it and set the pixels per unit value to 16 and hit apply. And there it is. Next, let's select the platform in our hierarchy again and move it up a little bit. And we can either leave it like this without an animation, or we can add the animation, which looks cooler. So let's do this. Let's switch to our animations folder, create a new animation, and call it moving platform.
Oh, how do we do this? Make this 0.6, 5, and 2. Just 0? I guess just 0. Oh yeah, he made an animation for it. Not a font animation. Platform.
Then we drag and drop this animation onto the moving platform game object to get our animator. Then we open the animation window. We select moving platform. We switch back to the folder with the animation graphics in, which was here under traps and
it was under
platforms.
Traps. No.
Then we drag them all in.
That's not the right one. Traps. Traps, platforms. Okay. And then all of those.
I'm gonna set the samples value to 8, which looks fine. So when I play it, you can see that the middle part rotates, and that's the whole animation. It's very subtle, but it gives more life to the game.
Yeah, why not?
And now we want to move this platform back and forth between this middle part here. And one way to do this would be to add a rigid body to this platform and then apply velocity and maybe change it every 2 seconds. But it's very imprecise to use a time for that, and it's also dependent on the speed. So when we change the speed, we have to change the duration. Wouldn't it be cooler if we could add waypoints to it so that we can say, okay,
if we could turn back time. Okay, sorry.
We want to move exactly between this point here and this point, and maybe additional points in the future. And in Unity, you can do pretty much anything you want. So let's try to build this. Let's close this animation window. And for our waypoints, we can just use normal game objects. So we create empty here, and we call it waypoint 1. When we select it, we can see where it is. If you can't find it, you can also hover with your mouse over the scene viewer and press F. And then it should zoom somewhere to it. Now, since it doesn't have a sprite renderer, it's not visible at all, unless we have it selected and see these tools here. And this makes sense because we don't want to have this waypoint visible when we start our game. But it would still be useful if we could see it while we are editing our scene. So what we can do is we can select it in the hierarchy and then click up here and give it one of these icons. Doesn't matter which one you pick. And then you can see it just here in the scene viewer, but we will not see this in the game.
This looks good.
So let's set the waypoint to the same height as our platform. So
wait, is Flux is actually active. Let me just disable this until sunrise. Yeah, this looks probably better.
So the platform has
someone definitely wondered why it looks so orange.
It's a Y of 0.18. Let's copy this and set it to the waypoint as well. And as you can see, the Z value is -6. Sometimes this happens when you add a new object. And it's still in front of the camera, so this would still work, but it's actually better if we set this to 0 with the rest of the world. And then let's move it over to the edge here. Then we duplicate this waypoint with Ctrl D, but I'm gonna rename it because this genius naming convention here is not so great. Let's call it waypoint 2. And then we just drag it over, but we keep the same height. Otherwise, our platform will move up and down slightly, which maybe looks weird. Okay, so we put one waypoint at the start and one at the end here of our
40
area in the middle. Then let's organize this better. So we create another empty game object. Let's call it moving platform 1. And just for organization, we put these 3 objects here below it, so we can open and close.
Makes sense.
Next, let's write the script that's responsible for moving this platform between these 2 waypoints. So we go into our assets folder here, into scripts, right click, create a new C# script and give it a name. Now we could call this platform movement, for example, but it makes sense to give it a more generic name to keep it reusable later. And we will actually reuse this script later on a different game
movement.
So instead of platform movement, let's call it waypoint follower.
Okay.
In Pascal case without white spaces. With this name, the script is more reusable because we can put it on other game objects and it still makes sense, right?
True.
Before we write the code for the script, let's drag and drop it onto the moving platform.
Oh,
not the empty game object, but the one that actually contains the animation. So this component is applied to this object. Then we double click on it here and write some code.
Let's write some code.
And this time we don't move our object by adding velocity to it. Instead, we basically want to set the positioner directly frame for frame. And we already know where we can do something each frame in update. So this time we don't need start, so we can delete it. And I'm also going to delete this comment here. And then I make update private. So the script we will be writing
X,
here will not be very big, but the code is new and might be a bit complicated the first time and a bit difficult to understand, but don't worry about it, just follow everything step by step. It's not a problem if you don't understand it the first time. So first of all, we need a way to hold our different waypoints. But instead of adding 2 waypoints, we also want to have the option to add 3 or 4 or 20 waypoints in the future if we want to have more complicated movements. So instead of creating a variable waypoint 1 and a variable waypoint 2, we create an array. An array is a variable where we can put more than one value in. And it looks the following way. First of all, of course, it has to be a serialized field, so we can set it in the editor. And then we create a private. The type is GameObject, which is basically the generic super type of an empty GameObject. So our waypoints, if you remember, don't have any components in them. They are just empty GameObjects. So this is why we declare the variable type just as GameObject like this. And now to be able to put more than one GameObject into this variable, we add a pair of angle brackets here, which creates an array.
Square brackets,
we give the variable a name, let's call it waypoints, and close this with a semicolon. Let's already save this with Ctrl S,
an array
back into Unity,
waypoints,
and see how this now looks in the editor. So we select our moving platform, and now here we have this drop-down menu for our waypoints, and we can add a list of waypoints to it by clicking plus. Let's click it 2 times because we have 2 waypoints, and then we keep moving platform selected and drag the first waypoint into element 0 and the second waypoint into element 1. And now they will be put in the array when the game starts, and we can use them in our script here through this waypoint.
I actually didn't expect that you use this inspector so much. I thought it would be more like dry programming, like the thing we do in Visual Studio Code.
It's variable.
But that's fun.
Next, we need a variable that keeps track of the current waypoint.
I like dry programming probably more, but not that that really matters.
Point index. So we know what waypoints we are currently moving towards. This one doesn't have to be a serialized field because we don't need to set it in the editor. It's managed within the script. So we just create a private int for a number and call it current waypoint index and initialize it with 0, which is the first index for the first waypoint. And the last variable we create here, and I put an empty line between it because they are not logically related. That's just for organization. Is the speed with which we want to move our platform. And to be able to change it in the editor later, we make it a serialized field. And we create a private float speed and initialize it with 2 as a float.
2ff.
And now we write some logic inside update to set the position of our moving platform each frame. So inside update we write if parentheses vector2.distance. This way we can check the distance between the platform and the currently active waypoint. So we know that we get close to it or we touch it. We want to switch to the next waypoint so we can move towards it. And this is exactly what this vector2.distance method does. It calculates the distance between 2 vectors. So the first vector is the position of the currently active waypoint, right? And the second vector is the position of the moving platform. So we write waypoints, which is our waypoints array. And then we want to access the first waypoint by its index, which we do by writing a pair of angle brackets again, and the index of the currently active waypoint, which is our variable here. So current waypoint index. Then we want to get the position. So we move the cursor out of the angle brackets, write transform, we already know this, dot position, comma, and the second vector, which is just transform.position, which we also already used earlier. That's the position of the object the script here lives in, which is the platform in
Definitely have to check sometime why I don't get autocorrection and I don't get these things underlined that are not correct already.
And then we go outside of the first closing
you can't see
parentheses here.
Okay, here. But
Right, the less than sign. If the distance is 0, we want to switch to the next waypoint. But again, there is a little bit of imprecision here, so we can't write exactly equals 0, otherwise it will be buggy. Instead we use a small value. Let's use 1.f here. So this basically means if the current waypoint and the platform have a distance of this very small fraction here, then we know that we are basically touching it, and then we want to switch to the next waypoint, which we do inside the curly brace block of this if statement here, because this part just returns true or false in each frame. So here, of course, we want to increment the current waypoint index like this. And then when we are at the last index, we need to switch back to the first one, right? So we cycle between these waypoints. So below we write if current waypoint index is greater than or equal to waypoints dot length, which is the size of our waypoints array. This way we know that we are at the last waypoint. In this case, we want to reset the current waypoint index to 0. It's actually pretty straightforward when you think about it. And now we only have to write one more line and the script is already done. And it's important that you put the line at the correct place, because it can be confusing here with all these closing curly braces. We want to put it below the outer if statement. And here we want to move our platform a little bit towards the next waypoint, because this is the next frame. And then, as I already explained, we don't want to use velocity here. Instead, we will move our platform directly frame for frame. So we want to set the transform position of this platform object directly. And to calculate this new position, we have a nice helper method, which is vector2.moveTowards. And the first argument here is the current position, which again we get with transform.position. And the second argument is the position we want to move towards, which is the same as up here. Waypoints, current waypoint index, .transform.position. So we can actually just copy this, put it behind the comma, add another comma, because this takes a third argument. And this third argument defines how far we want to move in this frame, because remember, this is only one frame, and we don't want to move our platform to the waypoint only in one frame, because this would be instant. Instead we write, and don't get scared by this, time with capital T dot delta time times our speed, and we close this line with a semicolon.
Time change.
Now the speed value here defines how many game units we want to move our platform when we call this method. We have set this to the value 2, so we will move 2 game units when we call this method. And 1 game unit is 1 rectangle here in our player world, which is also 1 piece in the tile map. But of course we don't want to move 2 game units in 1 frame, because this would be extremely fast. Instead we want to move 2 game units per second. Now the problem is that update is called every frame, but we don't know the frame rate of the current system. If we have a frame rate of 30 frames per second, we have to move a different amount per frame than on a device where the frame rate is 60. And this is where this time.delta time comes into play. When we hover over it, we can see the documentation comment, which says the interval in seconds from the last frame to the current one. So this is a tiny value, a fraction of a second that has passed since the last frame. And if the frame rate is higher, this value will be smaller. If the frame rate is lower, this value will be bigger. And this is what we use whenever we want to make something in our calculations here frame rate independent. By multiplying our speed value with this delta time, we now move 2 game units per second, no matter what the frame rate of the device is.
Actually interesting if this, or if the fixed update method is commonly used or best practice kind of. But I'm just doing what he does. No, that's some kind of question I can ask myself in the future if I really want to program a game.
Now it's hard to wrap your head around this the first time, but if you think about it for a bit, I'm sure you will get it. But this time.delta time value is very common in Unity games, so you should get used to it, because you need it to make your games frame rate independent. So now this should already work. Let's save it.
Makes sense.
And go back into Unity. Let it reload. And we have already set the waypoints. So now we should be able to just start it. And our platform should be moving.
Does this work already? Wait.
And it seems to work. Oops.
I have to clear my way too hard obstacle course for the start. Before I can see if it works or not. I should probably just remove the spike in the middle. Come on. Come on. Bro, there's no way. There's no way. This actually has to be like pixel perfect. It's maybe a bit too hard for the beginning. Okay, I give it like 2 more tries and okay, let's go. Now the platform should come to me. Hello, platform? Oh yeah, there it is. Bro! I got baited. Wait. I think I just messed up
when we click on the scene
where it
view,
is.
we can...
Wait. Bro, is this because it's untagged or default layer? Oh, it's because it's default layer.
keep it playing but zoom out and everything, which can be very convenient. And we can see that it moves back and forth. But of course we can't yet jump into it because it doesn't have a collider yet. So let's take care of this next. So we click on our moving platform. Again, we always work with the one that has the animator. The other one is just a folder basically.
But for testing purposes, let's remove this spike.
And we want to add.
Oh, let's just can't I? Okay, I can. Let's just put it there. This should be way easier.
A box collider 2D, of course.
Or put this like there and this there, so it's a bit more centered under, yeah, a bit more centered under the cherry.
Then let's change the boundary.
Oh, okay. I should maybe pay attention to what he's doing. Let's glider 2D. And
oh, let's put it like this.
A bit less than it actually is again. Okay, like this, I guess, and then maybe something like this. And I can't see because the waypoint is there. Okay, I can just. Okay, I can't. Yeah, then this waypoint is going to be none. There we go. So I can see this properly. Yeah, looks pretty good. Maybe a bit something like this.
And see if this.
Okay, he actually doesn't decrease this. Yeah, probably better. Because then you think you made it and you don't make it. Probably better at it.
It already works. So now we should be able to jump onto this platform. And this works, but if we don't actually move with the arrow keys, we just keep our position. So we need a way to tell the game that we want to move with the platform, otherwise we will just slide off. And if you remember in the very beginning, before we wrote our camera controller script. We nested the camera under the player game object to automatically move it with it. And we can actually use the same behavior to move our player with the moving platform. This is the easiest way to go about this. So let's create a new script for this. In our scripts folder, new C# script. And I'm gonna call it sticky platform. I drag and drop the script onto the moving platform. I can't jump actually. Oops. Didn't pay attention again. Let's create a new script for this. In our scripts folder, new C# script. And I'm gonna call it sticky platform.
Sure, why not?
I drag and drop the script onto the moving platform. And then we double click it to edit it. And what we basically want to do is, we want to check if the player touches the box collider of the moving platform and then parent the
process. Why isn't this on the moving platform already? Sticky platform, now it is, okay. Let's go.
Player under this moving platform object. So let's do this. We don't need start and update. Instead, we just want to get notified when we touch the collider of the moving platform, which we can find out with onCollisionEnder2D. If you don't have auto completion in your editor, just type it out manually, like here.
Yeah, let's do it another time. On CollisionEnder2D, now it's Collision2D, collision. Yeah, that's the AI that knows what I already typed and gets me auto completion for that.
Collision, which is this argument again, dot game object, dot name. This time we don't need to add a tag to our player because we only have one player and it will always have the name player. So instead of adding a tag like we did for the cherries, we can just compare the name directly, which we do like this, dot name and two equal signs, which we use to compare two values in C#. And we want to compare to the string player, which of course, as usual, has to have the exact same capitalization as the name of the player here in the hierarchy, the name of the game object. So this part will be executed if this...
Wait, this means that if you create an empty object that's called player, lowercase, yeah, okay, you can do that. And the doesn't think it's the same. It's pretty good.
Sticky platform collides with another collider, and if this other collider has the name player. Then we want to put the player inside the moving platform as a child, which we do like this, collision.gameObject, which again is the game object we collided with, .transform .setParent, which is a method where we have to pass what we want to set as the parent of this game object. And here we just pass transform, which is the transform component of the sticky platform, because we have written this with a lowercase t. We've already used this before. And this will set the player as a child of this moving platform. But then we also need to do the opposite when we leave the moving platform. So we also override onCollisionExit2D and do the same check again. So we copy this whole if block here. But instead of setting the platform as the parent, we want to remove.
Okay, here. Current void onCollisionExit2D. Collision2D, collision. Whoops. And then just copy paste that, okay.
Remove the parent, which you can do by passing null, which basically means no value.
It's also different for different programming languages. For some it's none. And in Swift, for example, it's nil. I think nothing is also a case. I don't actually know if there's anything else, but I know these four for sure. there's none, nil, and nothing, and null. I don't know, maybe there's some there's probably 1 or 2 others as well.
This and go back into Unity to try it out. Before we start this, we have to select the moving platform again and set the layer to ground. Why? Because otherwise we can't jump while we are standing on it. Because remember, our is grounded check checks for this layer mask here. So we set this to ground and then run it.
Okay, let's see.
And now I don't have to press the arrow keys.
I
can still move and walk on this platform,
to the platform,
but we also move automatically with it. And here in the hierarchy, you can see that the player is now nested below this moving platform. When we leave it, we revert this, and the player is its own game object again. But there is still one problem with this approach. Because we check if we hit this box collider, we also get dragged forward together with it, because we are touching the box collider on the sides.
Lol.
This means we parent the player to the moving platform, and then we get moved together with it. Now to get rid of this, we actually have to add a second box collider just here on the top, so we can distinguish between touching the sides and really touching the top, which is what we care about. So let's take care of this. We select our moving platform, and we can actually add a second box collider to it.
Okay.
And now we have to change the boundaries of our new box collider. But before we do this, let's change the order of the components here in the inspector. This is just for organization. You can actually move them around, but for some reason this only works if they are collapsed. So we collapse them with this arrow. And
Makes
then
sense.
I drag and drop the lower box collider here, which is just a better organization in my opinion, because we have our 2 box colliders below each other. And now we have 2 different box colliders that we can edit independently from each other. If you don't know which one is which, you can untick them here and it will make the color slightly less visible. So this is the first box collider we have already set up, but let's make it a bit smaller on the height.
Wait, why don't I have this? Why don't I have this here? Wait, what? I don't have this button on the second one. If I add another one, this also doesn't have it. But he has it. Wait, what? Okay, I don't know, but if I reset this, nothing happens. Okay. Okay, we'll check that.
And let's put a new one on top of it, because we only want to be able to stick to the top.
Okay, this. Oh, okay, I can just take the top one and drag this one a bit lower. Like this. And then drag this one here. Maybe. Okay. Yeah, maybe add a bit space in between them so I can change them later.
Top of the platform. Let's put it like this and make the edges a bit smaller. Otherwise we can still collide with it when we touch the sides of our platform, which we don't want. So this looks good in my opinion. Next we have to make the second box collider, the new one here on top, a trigger. Otherwise we can't distinguish between these different box colliders in our code, because in both cases, no matter which one we touch, only the onCollisionEnder method will be called. But by making one of them a trigger, we can distinguish between them the following way. So let's go back into our our sticky platform script. And now the top box collider, the one that we actually care about, is a trigger. And we have already used a trigger earlier when we set up our cherry items. And remember,
did he change something there? Oh yeah, okay. I missed that. He just ticked the is trigger on the second box collider. Okay.
The following way. So trigger earlier when we set up our cherry items. And remember, instead of onCollisionEnder, when we touch a trigger, we get called onTriggerEnderToDear. And this is how we can distinguish between the box collider that is not a trigger. When we touch this one, those methods here will be called, and the one that is a trigger will call onTriggerEnderToDear.
Oh, it's not collider. Oh, it's
and
collider.
onTriggerExitToDear. So we simply cut out these parts
Private
and put them into the new methods.
Void on
and delete these ones because we don't want anything to happen.
Trigger exit to the collider to the collision. I don't actually know why it's called collision there. You probably could call it something else. You probably could call it collider, but I'm not sure. That's why. Oh, whoops. I'm just changing this by hand. Transform. Then remove these two. There we go.
When we touch the outer part.
Why did I type that? Why I could have just changed this trigger to what was it before? I don't know. Wait. I could have just changed the collision to trigger and never mind.
It's the lower box collider. So, after you have made these changes, let's save the script, go back into Unity and try it out, because now we should only stick to the platform when we actually touch this part here on top. So let's hit play and try it out. And now when we touch the sides of the platform, we shouldn't stick to it anymore and we shouldn't get dragged behind it. So this seems to work. If your player still gets dragged with the sides of the platform, try to fine-tune your box colliders. Make sure you're not touching the trigger box collider, which should only work when we jump on top of the platform. Now one slight thing we can change is, you can see that we are in front of our platform here. We can see it when we touch this round part, the feet are in front of it. And of course we can fix this by changing the sorting layer, as we already did for our tile maps earlier. So we select the moving platform, and here in the sprite renderer we have the sorting layer. Now instead of setting up a completely new layer for the moving platform, we can also change the order and layer value here to change the order within this default layer, and you can do this for all your sorting layers. Which one you choose, either changing this value or creating a completely new sorting layer, is up to your personal preferences and how you want to organize this. But when we set this to 1, it will be in front of the player, because the player also has the default sorting layer, but with the order and layer 0. So let's try it again. Jump onto our platform, and now we are behind it, which looks much nicer.
Funny, you can see the position of the player changing.
Okay, nice.
And the inspector.
And lastly, let's make our moving platform a prefab, so we can reuse it later. Changing. But we don't want to make the whole folder here a prefab, because we want to use different waypoints later for our new moving platform. So we only drag and drop the inner moving platform object here into our prefabs folder. And now we can put more of them into our scene viewer, and when we make changes to one of them, the changes will be applied to all moving platforms.
Makes sense. Prefab, there. Moving platform.
Okay, this was really cool. In the next part, we will combine our new waypoint follower script with a new kind of trap to create the ultimate super weapon.
Okay.
So stay tuned for that.
Bro.
Now what I find really cool about Unity is that we can create these small reusable scripts and then add them to different game components to create different combinations of behavior. So for example, we can use our waypoint follower script that we created for our moving platform, but add it to a trap to get a trap.
Give me 1 second, I'll be right back. Oh wait, I was muted, but I'm back.
Trap that moves in our game world but can still kill the player. So let's do this in this part. So back in Unity, let's add a new trap to our traps folder here. So we right click on traps, create a 2D object, sprites square, and let's call it ZAR. And we can find the images for this under Assets, Pixel Adventure, Assets, Traps, and here we have the ZAR folder with a single sprite, right? And an animation. Now the animation depicts a rotation.
Wait, but let me, I am in game mode. He used square, yeah, okay. 2D.
Click on traps, create a 2D object, sprites square, and let's call it ZAR. And we can find the images for this under Assets, Pixel Adventure, Assets, Traps, and here we have the ZAR folder with a single sprite and an animation. Now the animation depicts a rotation movement, but we actually don't need this. We can also just use the normal ZAR image and rotate the image through a C# script, which in my opinion looks even cooler. So we will only use this image here. And first of all, of course, we have to change the pixels per unit value to 16. And then we want to drag this image
16
into the
ZAR
sprite here. So we drag and drop this into the sprite tab of the ZAR game object.
Small.
And what I want to do is I want to have the ZAR move from left to right here at the bottom. So let's remove these two spikes with the delete button. Then remove this ZAR here behind the ground. And again, the sorting layer is set to default.
Okay, let's just take this one and delete this one. And take the ZAR and put it somewhere here, I guess.
So it's behind the terrain, which looks cool in my opinion. And then we want to move it back and forth between 2 waypoints.
And 0.
So first of all...
Not 0, yeah, it's minus 2.5, okay. Minus 2.5, minus 2.5, no, okay. Wait, he has it minus 2.5. Okay, I just have this terrain different, so for me it's minus 1, minus 1.2, 1.1, 1.1. Looks pretty good.
Let's create a game object as a folder for it. So again, we right click on traps, create empty here. Let's call it ZAR1. Which is a great movie, by the way, and drag and drop this ZAR object under ZAR1, where we will now also put our waypoints.
Wait, but why?
So we right click on ZAR1, create an empty game object. Let's call it waypoint 1. Set preview image here to this little graphic, and then duplicate it with Ctrl D and rename it to waypoint 2. Oops. Then we give these 2 waypoints the same height as our ZAR. So we select the ZAR, copy this Y value, select both waypoints with Shift, paste it in here, and now they have the same height as the ZAR itself.
Yeah.
Then we move waypoint 1.
It could probably be a bit higher, but doesn't matter.
Over here under the first cherry, but of course you can build your world however you want. And here under the second cherry. And luckily the waypoint following logic is already set up. We did this in the last video, so we select
what he's trying to do.
And add our waypoint follower script.
Let me just make that a 4.5. I guess. Maybe not. Maybe 4.4. 4.4. 4.45? Yeah, looks good. And the other one just minus 3.55, like this. And yeah, then maybe like take this one and move it somewhere like here. And then take those 2 and move them maybe here. Yeah. Should be fine.
Where we add 2 elements to our array and drag our waypoints into these slots of the array. And now the
waypoint follower, okay. Makes sense. To use waypoint follower because we did just like exactly for this so that we can reuse the script. Oops. And not need to write it again.
ZAR should move between these.
It's pretty OP in programming to reuse your code for other instances. So you don't have to write like the same code 15 times for one game, or probably like even 100 times or a few hundred times.
These 2 waypoints when we start our game. So let's test it. And this already works. Of course, we don't have rotation yet, and we also don't have a collider on the ZAR yet. We will take care of this next. To rotate our ZAR, we will
create... this is a bit tedious that you have to add collision and this kill method to every object. Can't you just add it to traps and then everything inside of traps has this? This would be a little easier.
Create a tiny script, and again we can reuse this script later on other game objects.
Oh no, if I change it to 0 here, everything is messed up. Well, too late now to change it.
If we want them to rotate as well. So when we have the ZAR selected, we click Add Component to create a new script. We call it Rotate, click on New Script, create and add. But as usual, when we create a script like this, it's in the root assets folder, so we drag and drop this into scripts. And then we open the script in Visual Studio. So I double click it, rotate, and then we set this up. We don't need start here, only update. As usual, I delete this comment and make update private. Again, it's good to be able to change the speed of the rotation in the editor, so we create a serialized field for that, which is a private float that we call speed. And this value will define how many times we rotate the image by 360 degrees per second. So 2 times 360 is 720. So 2 full rotations of the image per second. Just play around with this until you have the speed that you like. And we rotate the image in update the following way. We write transform.rotate, which is a method, and then we have to pass 3 arguments, how much we want to rotate the image in the X, Y, and Z direction. So to see how this looks, let's take a look into Unity again. We select the ZAR, and here we go to rotation, not position,
we
but
probably
rotation.
Just need
X would mean we rotate it like this, which we don't want. Y means we rotate it like this, which we also don't want. We only want to rotate it on the Z value, which gives it this ZAR-like rotation movement. So back into our script. For X we pass 0, so we don't rotate it around the X-axis. The same for Y. And for Z we want to rotate it by 360 degrees.
Okay.
Times our speed value, times, maybe you can already guess it,
delta time.
Because again, we execute update in every frame, and with time.delta time, we make our values here frame rate independent, and instead we rotate the image.
Is this rotating in the right direction? Let me check real quick. If we have rotation Z, no, it's rotating in the wrong direction actually. Okay. I will... Oh, you don't see Visual Studio Code. Okay, here we go.
Image by 360 times speed.
Wait, you also don't... Wait. What is this? What is the...
A second.
Why is this tutorial not updating? Okay, I hope that this wasn't for long. But now it should work again.
So let's hit Ctrl S to save this. Go back into
Okay,
Unity.
what we did, quick update. We just created this rotating script with the speed float and the rotate function in update with delta time, so it's not dependent on FPS. And probably actually the wrong direction, because if you, that's what I just checked, if you rotate this in positive Z direction, it rotates in the wrong direction. You actually have to rotate this in negative Z direction. But maybe he fixes this. Let's see.
Here, and see if our ZAR rotates. And this looks like a rotation to me. Looks really cool. Now let's add the box collider so you can...
Yeah, but it's the wrong direction. It's rotating. Okay, so I'm just adding a -2f in front of the speed, and this should just fix it. When we play now. Name O does not exist. Oh, because I typed O instead of 0. Okay, so now it should work. Now it should also, but I don't know if it looks weird then. It should rotate in the right direction now. Yeah, I don't know, it looks kind of weird. But that's the right direction, isn't it? It looks extremely weird. But it has to go in this direction. Otherwise it doesn't make sense. Why would it? Okay, let's pause for a second. Why would it rotate in this direction? This doesn't make sense. It would rotate in this direction, wouldn't it? Probably would. It's probably fine. Looks kind of weird, but
when we touch it. So we select the ZAR, add component, box collider 2D. We change
circle collider would make more sense. Okay. Oops. Oh, actually true. Circle collider 2D would actually make more sense. And then I can just make the radius like 1.187. Okay, I'm just making the 1.1, 1.05, 7, 8, 6, 7. Let's make it 1.07.
boundaries a little bit. I'm gonna drag it in a little bit so we don't die as soon as we touch the very outside, but I don't want to go too far either. I'm gonna hide the terrain for a moment.
Yeah, it should be fine.
To see the full ZAR. And let's actually put it like this. It's a bit too small in my opinion. Okay.
It makes it bigger actually.
But we have already set up the whole def logic.
Let's make it 1.1.
So all we have to do to make this a trap is to tag the ZAR as trap. And the same as for our spikes.
Okay.
As soon as we touch a trap, the player will die. And I'm gonna make the terrain visible again. So let's run it and see if this works. And this time we had to do a lot less stuff than we had to do in the past, because we have already set up everything. We have already set up the waypoint follower earlier and the whole trap logic. So now when we touch it, we die, and our game restarts a moment later.
But this looks really way cool better. Okay, I'm changing it to what he has. to 2F.
And now I actually want to add 2 more of these ZARs.
Oh, okay, I think I know why, because then it's rotating in the wrong direction, but if you have something spinning really fast, then it looks like it's rotating or it's spinning in the other direction. I think that's the case, or that's the reason why this looks weird to me and the other one looks better. Yeah, this now looks like it spins really fast and therefore spins in the other direction. Okay. Wait, but it's still spinning in this direction. Never mind. Wait.
Just to make
I saved this, didn't I? Saved this? Wait to stop, maybe save this again and then start it again. Because it should now. Okay. I don't know, I think it looks better. But I think it also rotates still in the same direction. I don't know why it does that. But oh, because it didn't update here. Okay. So now if we play it, it should be, yeah, now it's in a different direction. Okay. Now it's in the other direction. And it looks better. Probably just because of this phenomenon that things that spin really fast look like they spin the other way around.
The game world a bit more interesting. But first of all, we will make the ZAR a prefab.
And I should what I should do is take the moving platform and I might just go there, take the moving platform and should move it a bit in this direction. So I have time to clear like the first obstacles until I get to their hoops. Now it's now the platform is there. Okay, that's way better than if I have to wait here every time.
So assets, and we drag in the ZAR here into the prefabs folder. And the name turns blue as usual. What I want to do is I want to draw this piece here, but vertically, and put a ZAR on it to make it look like the ZAR is moving on the stick. Now, of course, we don't want to hide it.
Okay, but it didn't really do anything except of... Wait. Okay, I'm just deleting these two. And then putting this one right here. Okay, that works.
The background when we draw this, but it's also not terrain because we collide with terrain and we want to be able to walk by it. So what we need is a third tile map. So we right click on our grid here again, where we already have our terrain and background tile maps. Create a new 2D object, tile map, rectangular, and I'm gonna call it over background.
Over background.
Then I select the inspector while over background is still selected. And we could add a new sorting layer for this, but I'm actually gonna use background and then set order layer to 1. But again, how you want to organize this depends on your personal preference. So now I click on tile palette, select over background, and we can draw it into the background over our background image, but we will be able to walk in front of these sticks. And we can actually rotate these tiles here before we draw them. So I have this whole stick selected, and how you rotate them depends on your keyboard. I think on an American keyboard, it's the closing and opening square bracket keys. On my German keyboard, it's the SZ button, which is a kind of German letter, and the button next to it with the, I think it's apostrophe. But again, on an American keyboard, it should be the square brackets keys. If you can't figure it out, just Google it because it's described somewhere. So I rotate this and I put 2 of these.
SZ.
somewhere here, like this. And then I want to put 2 Zars on these sticks. And by the way, you don't have to add these sticks at all if you don't want to. You can also just have the Zars hanging in the air. It's just for the looks.
Okay.
So next I'm gonna...
It's the two keys left from backspace.
Duplicate this whole Zar 1 together with the 2 waypoints. Gonna rename it to Zar 2. And then I move the Zar 2 over here. Place it how I like it. Maybe like this. And then of course I have to move the 2 waypoints. So waypoint 1 should be up here. And waypoint 2
what did he do?
Down here. Move the Zar 2 over here.
Oh, okay. He just copy pasted Zar 1, didn't he?
Here. Together with the 2 waypoints.
Yeah, okay. He copy pasted Zar 1. Okay, here we go. Take Zar 1, copy paste, rename it Zar 2, and then take all of this, drag it, drag it like onto here, and I can't see the top, but I guess it's here.
Gonna rename it to Zar 2. And then I move the Zar 2 over here. Place it how I like it. Maybe like this. And then of course I have to move the 2 waypoints. So waypoint 1 should be up here. And waypoint 2 down here. And the cool thing about our waypoint script is that it doesn't matter if these waypoints are aligned horizontally or vertically. The Zar will just move from one to the other.
$37.25. Okay, sure. Take these 2. Oh, this one just isn't visible. Wait, but what is this waypoint? Wait, this is waypoint 1? And this waypoint 2? But, oh, okay, it's just taking the middle. Okay. Okay, I see. Then I take this one and just, 0.25. Just take this one, paste it, make Y4. And make this Y maybe 1.1. Yeah, looks good. This isn't centered. 2.6 maybe? 2.7? 2.7 looks good. Bro, this is all just because I messed up traps and then put that to 0, 0, 0. That was a bit of an oopsie.
But to have a straight movement, I want to have the same X position for both of them. So I align this properly, copy this value and set it on the second waypoint, like this. Then I'm gonna duplicate the Zar 2 again, rename it to Zar 3, and then I move it over while holding Control down to get this very exact positioning. So this is a very cool game mechanic in my opinion, so let's run it again and try it out.
Like this.
I'm gonna run over there with our cool moving platform.
And it already works? Okay.
This is already easily the best game in the world in my opinion, and we have our 2 cool Zars. And when we touch them, of course we die. Nice. But of course, we can also use our ZARs completely without waypoints. So they just rotate in place. So let's actually do this with the first ZAR. Let's just remove these 2 waypoints and also remove the whole waypoint follower script. So right click, remove component, and we don't need this folder anymore, so we can drag it outside and delete ZAR1. And now when we run this, the ZAR will just rotate in place. And of course it's really difficult to get this cherry here, but it's possible. But let's actually
it's not that difficult.
Move it a bit higher. And since our collectibles are all nested in this object here, we can take this whole collectibles object and move it up. This is better. Of course you can keep these waypoints in, you can build this world in any way you want.
I think I keep the
Do you want to hear a funny
so
story? The level we just built with the ZARs and the spikes, I actually posted a preview of this level as a story on YouTube, and YouTube made this story age restricted. So you can only watch it if you are 18 or older.
What?
Because it's too violent. It's too I agree, it's a very hardcore game.
Yeah, it's
but
very
there's one
hardcore
important piece that's still missing, and that's the sound effects. At the moment our game is completely quiet, and
yeah, true.
What's a game without sound effects?
Sound.
So definitely make sure to watch the next part. Don't forget to subscribe to the channel and take care.
Okay, let's go. I'm hyped. 3 more videos. Just 3 more. Wait, is this really? This actually last 3 videos. Okay, we're almost done. Damn.
Psh, quiet. Can you hear that? No? I can't hear anything either, because we haven't added any sounds to our game yet. So let's go into Unity and change that. Okay, first of all, of course, we need sound files, and we can get free.
Why am I like hugging? Okay, now it's better. Like this, somewhat, yeah, like this. It's fine.
Sound files again from the Unity Asset Store. So we click on Window.
We don't already have sound files.
Then
okay.
On Asset Store, which this time should directly open in your web browser.
Yeah, it does.
Then we click on Assets and Audio.
Audio.
We set the pricing to
0.
Free again. And for sound effects like jumping, we use this one here. And for the background music, we use this one. But of course, you can choose whatever you want.
Okay.
So here I click on Add to my assets.
1 sec. Add to my assets. Accept. Add to my assets. Accept.
Open it in Unity, which should open this window. We click on download as we already did before for the Pixel Adventure graphics. Wait until this is finished. Click on import, and then we import all these different sound effects here. Then we go back into the asset store and do.
Probably don't need to read me, but yeah, why not? Open Unity, downloads.
Do the same for the background music.
Import all of this.
And we download and import them as well.
Yeah, nice.
When we have done this, we should find 2 new folders in our assets folder here. Casual game background music and casual game sounds. And the way sound effects work in Unity is that we need 2 parts. We need an audio source that creates sounds, for example our player when he jumps, and we need an audio listener that receives sounds, so that we actually hear them through our speakers or headphones. And the main camera is an audio listener by default, as we can see from this component here. So we are set up here, we don't need to change anything about this, but we need to add an audio source. So we click on the player and add a new component, audio source. But first, of course, we have to decide what sound effects we want to use. So let's go into the Casual Game Sounds folder, and you can actually either double click them to play them on your PC, or you can use the play button down here to listen to these sounds, and then we have to decide which of them we want to use. So give them a listen and then decide what you want to use for which
Just
effect.
pick one, bro.
I want to have a sound effect for jumping, collecting items, for dying, and later when we finish a level. So I've already decided that I want to use this one for collecting items. So I'm actually going to rename this to make it easier to find it later.
Okay, wait. What was it?
Items.
21. Collect.
I'm going to rename this to make it easier to find it later. I want to use this one for jumping. This one for dying.
43, okay.
I rename this to death. And to finish a level, I'm gonna use this one here.
18.
So I renamed this to finish.
Finish.
Then I click
Finish.
on the
Why not Norwegian?
game object.
Okay.
Go to our audio source.
That's funny.
And one audio source contains one audio clip. So I'm gonna start with jumping. I drag and drop this jump sound to the audio clip here. Down here,
what?
And one audio source contains one audio clip. So I'm gonna start with jumping. I drag and drop this jump sound to the audio clip here. Down here you can make some changes, like changing the volume and the pitch and everything, but I keep it as it is.
Yeah.
And then I untick play on awake. Otherwise this sound will play immediately when the game starts, which we want to have for background music, but not for these player sound effects. But of course we have to play the sound effect somewhere. We want to play this when we actually jump. So a good way to do this is in the player movement script. Of course we could also put it into a separate script, but then it would be difficult to really synchronize it with the player movement. For example, we can only jump when we actually hit the ground. So let's put the player sound call into the player movement script. So here we scroll all the way up.
Use visual code. Invalid exception. Can subproduct file name has not been provided. Did this already change? Preferences. External tool. Visual Studio Code. Why did this change? Come on, mate. Player movement. Okay, there we go.
And we add a new variable. I'm gonna put it here, which is a variable for the audio source. But we can't use the get component call here to find this component, because we will add multiple different audio sources to our player and we can't distinguish between them. Instead, we have to insert it in the editor, which of course we do by declaring it as a serialized field. And then we create a private audio source, which I'm gonna call jump sound effect. And we will later set this directly in the Unity editor. And then we go to the place where we want to play this, which is of course here when we jump. So we put it either above or below, the velocity change shouldn't matter. And here we simply call jump sound effect dot play. And that's already it.
Sure.
So let's save this, go back to Unity, which updates the editor, and now we have this slot in the player movement script for the jump sound effect, which expects an audio source. So we drag and drop this audio source here into this slot. And now this should play as soon as we jump. So let's try it out.
Let's try.
And we can hear the sound effect. Nice. So now let's take care of the other sound effects as well. We select the player.
Okay, look, sounds...
Let's collapse this because it's pretty big.
Whatever.
And add another audio source. Let's take care of the collection sound next. So we can click on it and select collect or drag and drop it in from the folder. Has the same effect, and we untick play on awake.
There's one sec here, and then collect. Player, collect. Wait, player. Audio source, collect.
And we play the sound in our item collector script. So let's open this one. So we create a new serialized field variable of type audio source, which we call collection sound effect. We play it here when we actually collect an item.
Collection sound, chill. Sound effect. Before this try, yeah, makes sense. Collection sound effect. Dot play. Oh, you don't see it, but wasn't
go back to
wasn't
Unity.
that much.
Select our player. And then we want to drag and drop this collect audio source into the collection sound effect slot of the item collector.
Yes,
before we test this, let's also add the def sound effect. So again, we add a new audio source. We're going to use the def sound here, untick play on awake, and open the player live script.
So many audio sources. Player audio source def, right? Yeah, def. Player live. Give me a second. I'm just adding the last audio source as well, because moving forth and back all the time. It's a bit annoying. Player live, sure.
Where we do the same steps again. We create a serialized field, private audio source,
not scene manager,
def sound effect, and we play it down here in die.
Def
sound effect at play, save, and then let's try it out. So back in Unity here, of course we have to
play.
Drag and drop this new def sound effect into the player live component, and then let's try it out. So now we should have sound when we jump, when we collect items, and when we die. Nice.
Nice.
And now we also want to add background music. And since the background music doesn't belong to a particular game object, we can put it into its own object. So we add another.
Holy shit! Okay, I forgot to uncheck play on awake. Bro, my heart just stopped for a second there. Oh my god. Okay. Now it should be better. I completely wasn't prepared for that. Holy. Okay, never mind. I forgot I forgot that I was in play still. Whew. I wasn't prepared for this one. This caught me off guard. Okay, yeah. Looks like everything's still where it should be. And okay. Bro, it's way too loud, but oops, like this.
Another object to our hierarchy, which by the way we can also do over this plus button up here. Create empty, and I'm gonna call it BG music, short for background music. It doesn't matter where it's positioned, we just have to add an audio source to it.
Audio source.
Where we select an audio clip, and then one of these background music tracks, I'm gonna use this one here. This time we keep play on awake selected because we want this to play immediately when we start the game.
Fair.
But I'm going to lower the volume by quite a bit because it shouldn't be too loud. It should just be very subtle in the background. So let's set it like this, and we don't have to...
But I also want to make the other sounds a bit quieter. Let's make this like... Where is it? Let's make this like 0.75, 0.75, 0.75, and 0.75. Let's see how this sounds like. Yeah, it's definitely better. Music is a bit too loud for my taste, so we could do like 0.15 or something, but it should be fine.
Thing in a script, because this will just start playing immediately. Let's try it out. And now we have this nice background music. And our game already feels a lot more.
Yeah, I guess that's fine. The dev sounds like kind of dumb, but it's okay.
But one more thing, important, we also have to check loop here. Otherwise the music will stop when the track is over, which we don't want. And you can also play around with these values here, but you shouldn't change this value. This should be set to 2D. Because if you set this to a 3D, the volume of the music will actually change the further you get away from the object that contains the background music. So it will get quieter. And of course this is not what we want.
And you also hear it like, first it was only in the right ear and then it was like kind of in the middle and then it turned to the left.
We wanted to keep the same loudness throughout the whole game. So we set the spatial blend to 2D, which is the default value. Okay, that's it for the music part. In the next part we want to build a new level, which means that we will reuse our player object there. So let's make it a prefab, so that when we make changes to the player, it will be applied to all instances of it. So we drag and drop the player into the prefabs folder, and that's it. Okay, our game is almost done. In the next two parts we will add additional levels and the start and end screen for our game, so that it feels like a complete game. And if you enjoyed this video series so far, please leave a like. Please go back to the other videos and like them as well if you haven't yet. Share this video series if you haven't yet. And of course subscribe to the channel. And then we'll see us in the next part. Take care.
That's cool. Just two more, right? Yeah, just two more. And then we have our first game.
Grandma. Yes. No, they haven't.
What?
Yeah, but I've already told them. Yes, but they won't listen. Okay. Goodbye.
What?
My grandma just called and she's very angry because you haven't shared this video series with anyone yet. And if you don't do this very soon, she will become very mad at you. So better do what
I'm actually doing right now. If you want to follow this as well, you can... Coding in Flow, this channel is called. And the series is called Build a 2D Platformer Game in Unity. I'm actually sharing it right now.
she's saying.
And I'll probably post on Twitter later when I finished it.
Yes. And in this part we will add additional levels to our game, because a game with one level is very boring and we will never become rich and famous this way. So let's go into Unity and take care of this. Okay, so let's finish the design of our first level. And again, you can build this level any way you want. Just make sure that you always pick the correct tile map in your grid when you draw the tiles, so you don't mess up your design. I'm gonna move the player a bit further to the right. And then what I want to do is I will actually put a large platform here.
Okay.
So we can't jump off the map. If you want to be able to jump off the map, of course you can do this, but then you need some more sophisticated camera code so the camera doesn't move out of the game.
Fair, but I would probably just pick this guy and then tile palette and just take this and move this up a little bit. Oops. Move this. Bro. Move this up a little bit, like this. And then put grass here. And then maybe, why not? Maybe add. Oh, okay, I actually can't. Okay, I would actually need to. Yeah, okay, why not? Just take. Bro, come on. Just take this. Move it right here, and then just take. No, not this. Just take this and move it here, and then we can. Do I need this here though? I probably actually can use this here and then a normal middle block here. Yeah, I guess this works. It's not perfect, but it works. Then I can use these and put like one here and maybe one here and one here. Yeah, looks okay.
Boundaries. The part here where we don't have a background anymore. I will cover this separately in a future tutorial. Here we will make it easy and just add these platforms so we can't leave the map. Then I'm going to select this part and I want to put the same one over here, but I have to make the world a bit bigger. Like this. Of course, put the end part here. And then again, I want to select this whole part, but I use this tool here. Select this and put the same one here. I also want to add one more cherry. So I go into the collectibles folder here. I duplicate one of these cherries and I want to put it here so that we have to jump while we are on the platform, which I think is really cool. Next, I want to put an object here that...
Oh wait, I have to fix this. Give me a sec, because this should be here. Oh no. And then this middle one should be here, and then this should be there, and this one should be here. So, okay. Yeah, no, it looks okay.
That we have to reach to actually finish this level and get to the next one. And when we go to Assets and the Pixel Adventure folder, Assets, then into Items and Checkpoints, and then the checkpoint folder here. We have this little animation with this finish flag, which I want to use as a trigger to complete the level. So we already know the drill. We create a new game object in our hierarchy, and to get a sprite renderer, we...
But what I actually will do is, for this one, make something like this, and then use this here. Does this look okay? Yeah. But it looks fine. Maybe... Oh, okay. This looks actually decent. Something like this. So this like standing out a bit. Looks okay, I guess. Yeah, why not?
Choose a sprite's square. Select this.
Where did he put that? Just
we create a new game object in our hierarchy.
Just on top.
And to get a sprite renderer, we choose a sprite's square. Select this, open the inspector, draw the first image here in the sprite.
What do you call it?
Of course, change the pixels per unit value to have it bigger. And then let's move it to the end of the world. So we have to reach this part to finish the level.
16. Oh, damn. Okay. But oops, we'll take this one, put it here. Okay, yeah, I should probably take this and put it like here maybe. And take this, put it there. Yeah, that's better, I guess. And then take this one, move it somewhat like here maybe. Looks okay.
Like this. Let's rename this object to finish. And now it needs a few more pieces. It needs a box collider so that we actually can detect when we hit this object, when we reach the finish line. We want to add an audio source to it so we can play this finish sound effect. And of course we need our own C# script to handle the rest of the finish logic, like loading the next level or playing our sound effect. So let's do this. Make sure the finish object is selected. Add the box collider to it. And since we don't actually want to collide with it, we want to rock right through it, we set it to trigger. Next we add an audio source, which we set the finish sound effect that we've already prepared.
Okay, then I need to delete the finish audio source from player. I was a bit too fast there. Remove component. And put this here it was, I guess. Yeah, okay. Expand this and put it there.
Prepared. And we uncheck play on awake. And then we put everything together in a finish script.
Maybe
so we go into assets, scripts, right click, create new C# script. I'm simply gonna call it finish.
Chill for a sec. Something like this, I guess. It's fine. Or maybe like this. Should be okay. Yeah, should be okay.
I drag it onto.
Wait, what does he do?
Together in a finish script. So we go into assets, scripts, right click, create new C# script. I'm simply gonna call it finish.
Finish Danish.
I drag it onto the finish object to add it as a component. Then double click the script.
Is it there now? It's there now.
To edit it in Visual Studio. So we don't need update this time, because we don't want to do anything in each frame, but we will need start, which we make private, of course. And here at the top, we first of all create a variable for the audio source, which we call finish sound. But this time we don't need to make it a serialized field. This time we can use get component. Why? Because we only have this one audio source on our finish object, so there's no ambiguity. So we assign finish sound to get component, and we want to get the audio source component of this finish object. To detect collision with our box collider that is set to a trigger, of course we override onTrigger enter 2D. And then we simply want to detect if we are colliding with the player, because then we want to finish the level, right? When the player and the finish object collide. So we check if collision .gameObject.name, as we have already done before, is equal to player with 2 equal signs. Then first of all we want to play the finish sound and then complete the current level and load the next one. And we put this logic into a separate method for better organization. So below, on trigger enter 2D, we create private void, complete level, and of course the name is up to you. Now we will write the code for this method in a moment, but first of all, let's call this method here, complete level, and then prepare our second level, because only then we can load it, of course. So let's go back into Unity. Now before we create a second level, let's make sure that all the reusable items are prefabbed, so that when we make changes to it, the changes will be applied in all our levels. So player, cherries, our different traps. The only thing that's missing here basically is the finish line. I also want to reorganize the hierarchy here a little bit. This is just personal preference. I want to change the order so it makes more sense to me. So we have the event system on top.
Okay.
Then I'm going to put the background music below it. But again, this is completely personal preference. The order here doesn't matter at all. This is just how I like it. Canvas, collectibles, traps, moving platform. I think this is fine. And then to create a second level, we go to assets and to scenes. Because remember, a scene is basically a level in Unity.
Oh, yeah.
Now the scene we have opened here is called sample scene by default. And I want to change the name of the scene to level 1. But before we rename the scene, it's important that we save it first. Because when we rename it, it will be reloaded. And all the changes since the last time you've saved will be lost. So hit Ctrl S, or alternatively click here on File and then on Save, and that's it. Our scene is saved and we can safely rename it. Then we click on it, right click, rename, or on Windows you can hit F2. And then I'm gonna call it level 1. And if everything worked correctly, the scene should still look the same as before. Then I want to duplicate this scene for level 2, because this is the easiest way to create another level without having to add all the different game objects from scratch again. So we click on it and press Ctrl D, and it automatically renames the new file to level 2, which is very convenient. Yeah. And when we double click this file, we open level 2, which of course looks the same as level 1 because we duplicated it, but you can see up here that we have level 2 opened now. And then I want to redesign this level 2 because of course having the same level 2 times would be very boring.
Pretty boring, yeah.
Now let's go to the assets folder, Pixel Adventure, asset.
Oh, he actually, okay, let's go back to level 1, because he actually put a Control D, put a cherry up here, which is, I like that. I don't know if you can actually get this here, but I'm putting it, can definitely get it if it's somewhere like here. Should be able to get this. Then maybe another one. Oops. Another one. Maybe another one right here. Something like this. Looks okay.
And then on background, because I want to use a different background image for the second level. So we open our tile palette under Window, 2D, tile palette. Gonna drag it over here. And in the same palette under Window, 2D,
2D
tile palette.
palette.
Gonna drag it over here. And then the same as we did for the first background, we just have to drag it in. But we have to make sure that we have set it to 16 pixels per unit. Let's actually do this for all these graphics at once, so we don't run into problems later. Pixels per unit 16, apply. Then of course we have to slice up the image into its 16 by 16 pieces. And for the second level I'm going to use the pink one here, but it's up to you. Okay, and as a refresher, we slice this image up 16. By changing the sprite mode from single to multiple.
Okay.
Open the sprite editor.
Wait. Oh, okay, I just opened this. I was confused. Wait. Where's this? 100 for everything, just for brown. I selected everyone, didn't I? Everything. Apply.
Click apply here.
Alright, and multiple layer. Apply. And then I also use pink when not sprite editor.
Slice, grid by cell size, and then 16 times 16. And then we hit slice. Then apply, and then we can close this. Switch to the tile palette. Drag this pink background over here, wherever you like it. And save the single tiles in the tile subfolder we already created earlier.
Yeah.
Which is this one here. Okay, and then of course we always have to make sure that we select the correct tile map, and then we can just use this one here and replace our old background with it. I'm also going to make it a bit bigger because the world will be a bit longer, like this maybe.
Okay,
and now I will build the second level, and I will fast forward this because you already know the process. You just design your level with these different tiles. You make sure to always select the correct tile map. You can place and duplicate items with Ctrl D, remove them with the delete button, and so on. And then just build a level that you want.
Okay, fair. Okay, let's just do this. Just take, oh, okay. I need to, do I remove the rest? Or do I just, oh, it was background, that's why. Okay, why do you just take this? And this for the top here. Right, not this for the top here, just this. And this. And then take this right here. Take not this right here, take just this right here. Move this. Take this. I messed up. Just take this here, okay. And just, can we take this and just, okay, we can't. Never mind, let me just use this here. Use this here. Actually, don't use this here. Just use the middle one. Till there. Then use like this. And then make this. Oh, okay. Forgot these. Put them here maybe, something like this. Make the level a bit wider. You can actually just take this, copy it, and then put it like here maybe. Select this one. That's not what I wanted. Can't I? No, while holding. Bro, I want to remove this. Wasn't it while holding shift? Oh, I think I. Okay, yeah, it was while holding shift. I just pressed control instead of shift. Whoopsies. Put this there. Maybe put this like this. And take this. Put this like here. Just make a small. I can just take this waypoint and move it like there. And this should be fine actually. But I also need the moving platform to be somewhere here. And I need the, where's the first O? I removed this. Okay. This should be fine. Maybe this is a bit more difficult, and we have 3 spikes here. I don't actually know if you can jump over 4 spikes. Let's try it. I want to know if you can. Holy shit. Why is this? No, not play on awake, and please make it 0.8. And I need to change this also for... where is it? Where was it? Assets? Oh, it was scenes, and then level 1. And then finish, and then not play on awake, and make it 0.8. And save this, go to scene 2, and play. I want to know if you can jump over 4 spikes at once. Okay, well, the spike is messing this up. But yeah, you can actually. Okay. Good to know. We should take one of these and move them there and make another one like this. And maybe remove the waypoint follower script. Remove components, yeah. And then move this up like this, and then delete this. Just take the saw and maybe put it right here. Then maybe take another saw and put it right here. Or wait. Or I just copy one of those. Command D. Oh, whoops. We also need a stick, but can do that a bit later. Right there. And it looks pretty good, but maybe a bit higher, something like that. And then we take one of those sticks. Can I get one of the sticks? Where did we put those sticks? Oh, this was just, never mind. They're not objects. They're just here. Wait. Oh no, it's because should be Terra. Yeah, okay. And then hit the rotate button. I don't actually know which way we rotate it. We rotate it so that the shadow is to the player, okay. Oops. So we rotate it like this, yeah. Okay. Put this there. Maybe move this a bit up where it saw this one. Take all of them and move them a bit up. Something like this should probably work. And then put a cherry. Maybe not there. Maybe like this. Let's select the cherry, make it middle of there. Make this one maybe something like here and remove this one. And let's try this first part. Should be pretty okay. Oh, but this isn't good. Okay. Okay, this is way too hard, I guess. And we collide. Oh, okay. Okay, let me check how we did this there, because these do not have collision. Are they in background? Oh no, they're an over background, right? Okay. Okay. Okay, I moved these cherries. Wait, let me just put these all back where they were, okay. And then just not do this, but not do this as well, because we're on background and not on Terra. Yeah, remove that. Go over background, take those, rotate them and put them here. Okay, yeah, looks good. I don't actually know if the lighting is right, but probably isn't. No, the lighting isn't right. But doesn't matter, come on. I just want to try if this is possible. Okay, we need to wait. Bro, this is so hard. Okay, this may be a bit too hard. Okay, this is definitely a bit too hard. So we take those. Put them up. Like this, maybe. This should be fine. And then go here, over background. Remove this. And then put it here. Let's see if it now is better. Okay, yeah, now it's doable. Wait, can we make this jump? Okay, I think we can't. Ah, that's close. We maybe could. Okay, and I already have a idea for this one. For what we do back here. We could do, oh no. That's not good. Okay, just no, it has to be Terra, but okay, no, now it works. And then we could do something like this. Actually, I think this is fine. We don't need the longer ones. Yeah, this looks weird. This looks better, I think. But now we can maybe remove these. I'll just delete them. No, we just move them up a bit. Okay, move them up like this. Or maybe move them like this so you can jump over. Yeah, maybe like this. And take this here and put it like there. Something like this maybe. And then take this one. Make it Terra. Put this in the middle. And then maybe... but I should first take this SO3 and move it a bit in this direction. Probably like this, and then select this one and put it somewhere. I don't know, maybe like this. Oh no, I actually can't. Yeah, put it like this. Come on, doesn't matter. Okay. Then maybe right take these two. And then take the middle one, make this a bit longer, something like this. And then maybe just make this something like this. Looks okay. Make the second jump also. Maybe make the second jump even one further. How far are we? Okay. Still have a bit. And then maybe... maybe drop down again, actually. Okay, but the problem is, what if you fall here? Okay, and the solution is we just make it like it was here. I guess just wait, let's just remove these and then put them. Oh wait, this doesn't fit. Okay, put them here and here. And then we just have to take this, put it on top of this, and then take the other one, which is here, put it over this, and notice, wait. If I do like, okay, I just make it one shorter, I guess. Just make it like this, and then make the start here, and remove this one, and yeah, no, it's fine. And then put oh, I could actually, wait, I could actually take this and just Command D, Command D this, and not actually into here, but here, and take this here. Like this maybe, and then put waypoint 2 further there, like this. Maybe not as far, but put it like there maybe. And then take this object here, and put it here, and then take these, put them here, take these, put them here and here. Actually, no, actually we need this one here. Okay, now it should look pretty decent. And we put does this work? Okay, it looks kind of weird. Maybe we could do something like this. Put this here. Looks okay. I guess something like this, and then these middle parts are this, and then I don't know how we do the bottom, because this will probably look weird. I mean, honestly, just like this, I guess. Oops. Take this, make them like this. make them like this. Then this looks pretty decent. Then take the finish, move it up here. Something like this. Looks fine, I guess. But we probably need a few, because if you jump here, you probably see out of bounds. So we go to background, take this, take the box, and then just make it a bit higher. Just like this. Should probably be enough. Okay, and then just remove this terrain. Like this. And from here actually use those. And remove all of this. Oh, okay, there are still spikes that I didn't see because they're behind terrain. But I can, like, from this to this one, just take him there, just take this one, put it here, and then just take this one, take the middle one, make this box, put it here, like this, and then copy all those spikes and move them here, copy them again, and then just a few more. Just like this. Okay. Yeah, I guess it looks decent. But we could actually I probably don't like this. Oh, this is on background now. No, it's terrain, I guess. Okay, doesn't matter, honestly. Take this, just remove all of this, because it's probably better to just make this on a floating, yeah, something like this, one wider, on such a floating oops, I don't want this, on such a floating platform, and just take the bottom and extend it so you can't jump off, and then take the spikes. Oh my god, all of these spikes are here. So you can move them inside of here. And then take a bunch of spikes. Wait, is this? No, okay, this is not finished. Now it is. And then take a bunch of spikes and just copy paste them and put them here. Why are they always outside of the folder if I copy paste them? Doesn't make sense. Control D. Oh, actually too much. Actually one too much. Can delete this one. Move these here. And then I guess we have a decent level, except for I wanted. Yeah, let's do just two. Just copy these two and put them onto this platform like this. Something like this in the middle. Okay, we have a bunch of spikes. These should work. This should work. We can add some cherries, some collectible cherries. But other than that, should be fine. Maybe add one here. Something like this. Probably fine. Add one here. Add one somewhere here. And then it should be fine. Guess that's okay. Yeah, looks pretty good to me. I don't know if you can actually see this end. You probably can, but that shouldn't matter too much. And oh, okay, we could change the background music actually. That's maybe something. Let's listen to the. Ouch! This was way too loud. Okay, let me just play it. Oh. And what's for? Okay, no, they all do not sound that great, but let's just take one. Background one. And Plan Wake, yeah, set 0.1. Okay, let's play. Let's play this level. Wait, can you jump? Okay, you can jump over these. Even if they're on top. Okay. Just these things are a bit too low. These could be higher. Because you can, even if they're completely on top, you can jump over them. I guess something like this would be fine. And then also, okay, not for this one, but for the others, so also make it like this high. Tile palette over background. Remove these. Tilt this one, make it there and there. And then it's fine. But we should move the cherry so it's not on top of. Which one is it? This one. Maybe like this. Should be fine. Okay. And one more thing, just to make it look better. No, just no. Okay. Let's do this. Just take this and put it like here or something, and make this one, and then just add some more spikes. Because now you can actually see past the end, and this way you shouldn't. Okay. Looks pretty good to me. Should be fun.
Okay, let's take a look at the level I've built. So I'm gonna run this, do a quick walkthrough. I try to make it a bit more dangerously, with a few more traps and a few more tricky situations, but again, this is up to you. And here our source, and as you can see, I'm a very sadistic person. And here's our goal. Okay. Again, make sure to hit Ctrl S to save the scene. It's a good...
Actually, let's make the background music a bit quieter.
Habit to get into anyway, because this doesn't auto-save your changes.
Or I'm just trying it again. Maybe it's fun. Okay, it's a bit loud, but... yeah, it's actually a bit too loud. Let's change it to 0.1. Should be better, but then we also have to change it in the other scene. To 0.1. Like this. Perfect. Okay.
When you add something to this level, and then we click on File and on Build Settings. And in this window we have to add our levels so we can switch between them from within our C# code. So here we click on Add Open Scenes, which should add your level 2 now.
Yeah.
Again, I will cover the rest of this stuff in a separate tutorial. This is how you can actually export your project to these different platforms. We don't need this now, we just need to add it here and pay attention to this index here. So level 1 has the index 0, level 2 has the index 1, and any additional level we add in the future, or any additional scene rather, has an index of this +1 basically.
For example, yeah.
So we close this. And then we want to continue setting up our finish script, because right now when we get to the finish line, we just play a sound and that's it. We also want to go to the next level, right? So we go to Assets, Scripts, and open our finish script. And now after we have added the second level to the build window, we can load it from our code. So first of all, we need the scene management namespace again, as we already added in player live when we reloaded the current level. So up here below, using Unity Engine, we write using Unity Engine dot scene management,
yeah.
Semicolon. And then we can load the next level by its index with one line of code. Scene manager dot load scene, but this time we don't want to reload the current scene, instead we want to load the next scene. So we write scene manager dot get active scene, which again is the current scene.
Get active scene.
Dot build index, which is this little number in the build window on the right side. So 0 for level 1 and 1 for level 2. So this is the build index of the current level, and we want to add 1 to it to load the next level.
+1, yeah.
And that's it. Of course, eventually you will run out of build indexes, right? We don't always have a next level. This is why we have to add a game over screen or a game end screen, where we then don't load another level. We will do this in the next part, but for now we just keep it like this.
Okay.
And now when we touch the finish line, we should load the next level. So let's save this, go back into Unity. And then we open level 1 again, because only there we can switch to the next level,
Fair.
which is level 2. So after this has finished loading, we open assets, scenes, again, we save level 2 first with Ctrl S, and then we double click level 1. And now I'm gonna play this, and I go all the way to the finish line. And I'll actually just ignore these cherries here. And by the way, we have forgotten to add the animation for the moving platform here. We will do this in a moment.
Oh, true.
Okay, so
Ouch.
now we get here and we go to the next level.
Oops.
As you saw,
I don't actually know if this is too hard. Because maybe you can't jump in between the chainsaws. So maybe I need to remove this cherry. If you're perfectly in the middle, you can actually. Okay, this is bait. Can you still jump over them? No. Okay, I can't.
Switch to the next level was very abrupt, which
That's
I don't
true.
like, because we want to hear the sound effect, and then after a short moment, like maybe 2 seconds, I want to switch to the next level. We can actually do this quite easily. For this we go back into our finish script. And instead of calling complete level here directly, we want to call it with a delay. And we can do this by using the invoke method instead, which takes the method name we want to call as the first argument. So this is complete level as a string, comma, and then a number for the duration in seconds we want to wait before we call this.
Oh, okay.
It's a float, so I'm gonna pass 2f, semicolon, and now this will be called not immediately, but after 2 seconds after we have collided with the finish line. Now when we wanted to delay the restart level method earlier, we used an animation event, but this time we don't have an animation because we are not executing any particular animation when we hit the finish line. This is why we use invoke instead. Then of course we have to delete this call down here, otherwise we will still call it immediately.
Makes sense.
Save the script.
Probably actually calling it twice then, and just skipping a
Go
level.
back into Unity and try it out. So I'm gonna
Oops.
go all the way to the finish line. The fun is real. Try not to die here. And when we hit the finish line, we hear our sound, and after 2 seconds we load.
I'm not collecting all the cherries now. I'm just speedrunning this. Oops. Okay, that works.
The next level, which in my opinion looks much cooler than switching to the next level immediately. But there's actually still a bug in our code. Let me show you this by running the game again, and then I'm gonna go all the way to the finish line. Now when I touch the finish line, we hear our sound and then we wait 2 seconds, right? But this also means that we can walk away out of the collider and into the collider again, and then hear the finish
true.
sound again, which isn't great. It's a
Okay,
bug. So let's
and you
try it
can
out.
also die probably.
Sound. But we can fix this very easily. So let's go once again into our finish script. We can add a simple boolean.
I would probably not let the player be able to walk again, because can't you then just walk back and die?
Variable here to check if we already touched the finish line. So up here we create a private bool, not as a serialized field because we only need it in here and it's not managed in the editor. We call it level completed and set this to false initially, because of course when we start a level it's not completed yet.
Yeah, obviously.
Then
And
here
then here.
in the collision detection We also check with 2 ampersand signs if the level is not completed. And the not operator in most programming languages, including C# is an exclamation mark. So we write exclamation mark level completed, which means that we check that this is false. The level is not completed. Only then we want to execute this part here. And we also want to set level completed to true.
Because true.
Then the next time when we collide with the finish line, this will evaluate to false and we won't execute this part again. But of course we will still load the next level because we already touched the finish line earlier. Now our bug should be gone. So let's save this, go back into Unity and try it out once again.
But I want to know what happens if I play this, finish the level and then die. Because I guess this is a bug still. Or you can still die if you completed the level, which shouldn't be. Okay. Next level just starts, which is fun. Which is okay.
And now sound and no sound again. Perfect. So this bug is fixed. Now every level in our game works independently from the other levels. So when we, for example, collect 4 cherries here and then get to the next level, we start at cherry 0 again. Which makes sense, I mean we start collecting from scratch again. But it's also possible to keep game objects alive across levels, but again I won't cover this in this tutorial. I will cover this separately in a different tutorial, in a different video. And of course you can also use different background music in your level too. This is very easy, just change the track in BG music. And before we finish this part, I want to do a few small corrections. First of all, as I already said, we forgot to loop the animation of the moving platform. Fixing this is very easy. We can just go into our animations folder, search for the moving platform animation, not the controller, but the animation with this rectangle, and click loop time.
Yeah, true.
And that's it for that part. Then I want to go to the dev animation of the player again. So I open that.
But I also need to do this in the other scene, I guess. Wait, level was this? Okay, this was actually saved. Scenes level 2. Then here on animation. Okay, this is for the whole project.
The animation window. Select the player in the hierarchy. Select player.
Wait, what?
Dev. Controller, but the animation with this rectangle, and click loop time. And that's it for that part. Then I want to go to the dev animation of the player again. So I open the animation window, select the player in the hierarchy, select player dev. And what I just want to do is I want to put this event a little bit further behind to 116.
Okay.
Otherwise the dev sound is cut off before we load the next level, which sounds a bit ugly. So I just put this here and that's it. So now after we have died, the delay before we restart the level is a bit longer, so the dev sound can finish playing.
Okay.
Then I also forgot to set up the boundaries of the box collider of the finish line. I mean, this would also work, but I think we can make it a bit smaller. And this is also a good opportunity to see prefabs in action. So instead of changing it here on the finish object of the scene directly, we click on this right arrow to get to the prefab. And now all the changes we make here will be applied to all our finish objects in both scenes. So here I added the box collider, make it a bit smaller. Doesn't have to be perfect, I mean it's just a finish line. So maybe like this. And that's it. Now when we save the scene and open the other scene again, the changes should be applied to the finish line there as well. So Ctrl S, Assets, scenes, and I open level 2 again. Go to the finish line, and as you can see, the box collider is changed here as well. And that's really the purpose of prefabs. And then I also want to add an animation to this finish line, because right now it doesn't have one, and it looks really weird. Again, we do this in the prefab. Then I'm gonna go to the animations folder, and we have already done this 1,000 times, so I'm gonna fast forward this. The only thing that's important is that you add the animation to the prefab.
Oh, okay. We didn't animate the finish. Finish. Actually, true. I didn't even realize that we didn't finish. Animate the finish. Checkpoint. Then this one. Put it. Hello. Put it right. Oh, not here. Wait, I forgot to put this here. Okay. And now I have finish. Okay, and now I can animate it here. Yeah, okay. What is the setting for samples? $30, okay.
So this is how our animation looks, and of course the pink part here in the background doesn't belong to it. It only looks like this because we have the prefab selected. This is how the animation looks, and of course we have to set it to looping. So loop time, save the scene, and then I'm gonna reload scene 1 again to see if the changes are applied. So when we run this and select the scene viewer, we should be able to see it, and there it is. Looks much better, right? I don't want to add more levels in this tutorial besides these 2, because I don't want to be too repetitive. We already know all this stuff, but of course you are free to add as many levels as you want. And do me a favor, if you have designed a really cool level, maybe post it on Instagram or Twitter and tag me there. Tell me, hey, Florian, I'm following your tutorial and I've built this nice level and I'm really interested in this kind of stuff. It makes me very proud to see this. And my handle on both Instagram and Twitter is codinginflow and all lowercase. So I'm looking forward to this. And in the next part, we will set up a start screen for our game and an end screen. And then our game is basically complete. So I'm looking forward to this. I hope you
we'll
watch this as well.
Write a tweet after and tag him. I really enjoy the tutorial. He's quite funny in the intros and outros, and also I like the game. Before this live stream, I looked at a few different games that had tutorials of them that I could build for my first game, and honestly, this looked pretty cool. So I chose this one, and I'm not regretting it. It still looks pretty cool. The tutorial is really nice. So yeah, I'm also proud of you, Florian.
I find some major bugs that we have to fix. This will be the last part of this video series. It was a lot of fun for me recording this. I hope you enjoyed it as well.
This guy doesn't look like he has fun, but I think he has. I think he's quite a nice guy.
And now the only piece that's missing to make our game feel like a complete game is a start screen and an end screen when the game is over. So let's do this now. And the game over and start screen are basically just normal scenes. Just like they don't have a player and traps and everything, instead they just have a UI with text and buttons and so on that we can click on. So we simply go into our scenes folder here, right click and create a new scene.
Okay.
I'm gonna call the first one start screen. make sure that our current scene is saved, and then we open the start screen by double-clicking it.
Start screen. No,
then we right-click on our hierarchy
start screen. Right.
And create a UI panel. Panel is basically a background that we can give a color and put some text and other stuff on. So
is
let's
it
click this.
No, it's not.
And as usual, it creates a canvas and an event system as well.
Bro,
so just for organization, I'm going to put the event system up here as we did earlier. And then let's set up our panel. So I click on the panel, hover with the mouse over the scene view and press F to get a nice view on it. And here we can make changes to the panel itself, like changing the color of it. So I click on color. I keep it white, but again, you can set it up any way you want. But I remove the transparency to get this full opaque white color. And I also want to remove this background image here. So we click on source image on this little plus icon. And I want to set this to none, which is all the way at the top here. And now we have a full white background.
Okay.
And then on this panel, we want to put a text for the title of the game. So right click on panel, UI text. You can change the name, but I just keep it as text because we only have this one text in here.
Fair.
And then over here, we can set a text to the title of the game. I'm gonna call it the best game ever for a lack of creativity.
Okay, I have a funny one. I call it this game is Possible. Okay, the name is too long. Oof.
Creativity. Let's remove this ugly Arial font and set this to our nice press start font again.
Well, the boundaries
Gonna change the font size to 83, but it disappears because the text view itself is too small for the text now. So we use the resize tool up here, for which the shortcut is T. And then I'm gonna resize this. And we can hold Alt down to resize it like this around the middle, or without Alt it resizes like this. Doesn't really matter. But we make it big enough so the whole text fits into one line. And then I want to put this in the middle or somewhere here. And I also want to align the text in the middle here with this alignment property.
Maybe like that.
Which makes it easier to
align to the middle.
Place it correctly. And then just for the looks, I also want to add an image here. So I right click on the panel again. UI, image. Of course, it's white right now because we haven't set an image to it yet. What I want to do is I want to go to the main characters folder, where also the animations of our virtual guy character are in. And then I want to use this jump image here, and I drag it into the source image. And then I put it above the text, which looks really cool in my opinion, but I want to move both of them down a little bit.
Sure.
Like this. And then we need a button that we can actually click to start our game. And that's the last element we need here. So again, right click on panel, UI button. Move it.
Give me a sec. Something like this probably. Yeah, something like this. Maybe a bit higher. Looks good.
Down a bit. When we expand the button here in the hierarchy, we can see that it has a text element, which of course is the text inside it. Gonna change the text of this to start. Change the font to press start. And I make it a tiny bit.
Text in it to start. Oh, okay. Here. Start. Or a nice font.
Bit smaller by setting the font size to 12. And now, of course, we need to give functionality to this button. So we click the button, and then
That's
down
correct.
here we have this
Oops.
onClick field, with which we can call a method. Of course, we have to write this method first. And where do we put it? We put it into a C# script. And it makes sense to just put the C# script as a component directly on this button. So we click on Add Component, type in Start Menu, in Pascal case, and create a new script with this name.
Create and add.
As usual, we drag it over into the scripts folder.
It's still loading.
And then open it. This will be a very small script. We remove these two default methods here. We need to import the scene management namespace. So using Unity Engine, not this one, Unity Engine scene management.
Scene management right there.
And then we create a method here, which this time needs to be public, otherwise the button cannot access it.
Public.
So public instead of private, void start game. And this is just one line again. We do the same as we already did in the finish script. We just want to load the next scene, which will be level 1 then. So scene manager, load scene, scene manager get active scene, dot build index +1. We've already done this before. We save the script, go back into Unity, select the button again and go to the onClick part here, where we now click plus. Then in here we need to drag the component that contains the method we want to call. So we drag and drop the start menu in here, and then here we select our function under start menu, which is the name of the script, and then start game, which is the name of the public method we just created.
Yeah.
And now when we click this button, this method will be called, which then loads the next scene, which is level 1. So let's actually try this out.
Shouldn't work.
And of course you can add background music here if you want. Start. And it doesn't load yet, but I already know why.
Yeah.
Because we haven't added this new scene to the build window yet. So File, Build Settings, Add Open Scenes, and we put it up here because this is the very first scene before the first level. Like this. Run it again. Hit Start, and we are on level 1.
Okay. But let's just add background music. Actually. Background music. And then add component. Yes, it was audio source. No, what was it? What was? Wait, let me just switch scenes and give the background music a prefab. And then I can just drag and drop it to the other scene. Save. Delete this one. And prefabs, background music. Put it there. Maybe choose background 3. Sure, why not?
Exactly as we wanted. Now let's also create an end screen. So again in Assets, Scenes. Let's duplicate Start Screen after saving it, of course. So Control S, then we select it, Control D. And I rename the one that has the one we appended to it to end screen. And then we open this and make a few changes here. So we open the canvas panel, and I'm going to remove the image here and change this text to game completed. But we can keep the other attributes as they are. I move it up a little bit because now I want to add the second text below.
Oh, wait, give me a sec. This game completed. And then the image maybe. Do we have another image of the virtual guy maybe? Maybe idle or. Yeah, maybe just use the idle image for this one. And then on the button, probably say restart.
So right click on panel, UI text. Here I'm gonna write, thank you for playing.
Oh, okay.
Remove this ugly Arial font. Make this bigger.
Thank you for playing. What size did you use? 14, okay. And T was it? Put it there. And there. Maybe like this. And center it.
Align it in the middle, like this, and maybe increase the text size a little bit to 20, which means we have to make this even bigger.
Yeah, like 16, not 20.
Maybe like
yeah,
this.
16 looks fine. And then
of course our button shouldn't say start anymore. So we change the text of the button to a quit.
Oh, okay.
And we also want to change the method that we call when we click the button, because we don't want to restart the game. We want to quit the application. So let's remove the start menu component by right-clicking on it, and then we click remove component. And instead we create a new one, which we call end menu.
Like this.
Drag into the scripts folder. And open the end menu script in Visual Studio.
Yeah.
And this will be very small as well.
Remove
Here
everything.
We don't even need the scene management. We remove start and update. And instead we create a public, and again it has to be public, not private. So we can call it from our button. Void because it doesn't return anything.
Quit.
And we call it quit.
Oops.
And in here we simply call application with a capital A.
Application.
Dot quit, which does exactly what the name implies. It quits the application. But this only works after we have actually built the game, not in preview mode. So when we click the quit button, nothing will happen when we try it out. But of course we have to add the end menu to the build window as well. So build settings, add open scenes, and it should be here at the very end. And now we don't have the problem anymore that we run out of levels, because eventually we will get to the end screen, and from there we only quit the application.
Scenes? Oh, it's because end screen, but it should still be, wait. Maybe build settings. Oh, okay, no, it's working.
But again, the order of these scenes here is important. You have to put them in the same order as you want to load them successively.
Makes sense.
Start screen, level 1, level 2, level 3, and so on, and the end screen at the very end. So let's close this and run this whole game once again to see what we have created. So first I open the start screen, so we can run the game from there. And then let's play the whole game.
Can I create an exe from it? I would like to have an exe that I can actually play. Oh, wait, actually, oops, actually, let's pause and let's go back to end screen. I want to add music, but not the same. Let's make it this one, but let's actually keep it the same volume. Okay, let's start. Okay, let's play through this. No shot, I created this. That's cool. Whew. That was close. Da-da-dum. Oops. That was close. Let's go. Nice, this is actually cool. Created this completely on my own. That's crazy. Bro, come on. Clear game.
That's it for this video series. It was a lot of work, but hopefully also a lot of fun. If you enjoyed it, make sure to like this video and make sure to share this video series with someone you know. Remember that you can find the code for this game on GitHub if you want to download it from there, or if you want to just take another look at the scripts. As I already said, I want to cover more game dev topics in the future in separate videos, and I also want to make a tutorial on how to create a 3D game in Unity from scratch, similar to this one. So make sure to subscribe to the channel to not miss any of that. And then I hope I see you in the future. Take care.
Okay, the only thing is that I want to know is export game from Unity. So I could like maybe how to build export a game in Unity. Unity play game it and play it in your desktop. Maybe deploy build export. .exe build. Okay, that's I think what I'm looking for.
Hey guys, welcome back to another Unity tutorial. Today I'm going to be showing you guys how to export your game, how to build it. I'm going to be showing you the very basics and what you should at least include into your game to make sure you get a playable experience and so you can get started with playtesting right away. Now, before we begin, I got a question for you guys. That's to leave a comment down below and let me know what kind of video you would like next. So please do leave some feedback, I really appreciate it. And let's get into the tutorial. Okay, so for starters, open up your Unity project. Our project is opened up, and as you can see, we got ourselves a main menu, so the player can choose when they want to be put into action. But the most important things you want to have in your build, no matter what, is at least some kind of main menu. It can just be a UI button that loads into the scene. And you want to have a quit button. So first thing you want to do is go to the very top left and hover over File and go down to Build Settings. You want to make sure that in the scenes to build, you got your active scenes that you are using in the game. So in my case, the main menu and the level are all that I'm using as of right now. So I added those and I made sure that these numbers are correct since I am switching in between them. We can select development build, which will add a little bit of text at the bottom corner stating that this is a development build, and we can select our conversion mode. Unless you know
conversion mode default,
I would recommend just keep everything at default because that will just work fine. So we can click build or build and run. I'm going to click build because I want to make sure that I have a builds folder. And
okay. Builds.
if you are using the Unity Gitignore for your GitHub repository, builds with or without a capital letter will make sure it gets ignored. So if you want your builds to be pushed to your GitHub repository, you gotta make sure you remove those lines from the Gitignore file.
Okay, this seems to take a bit. So your first build might take a while. Oh, it's not actually taking that long, I guess. Hopefully.
Okay, so our game is finished building, so all we gotta do now is go to our assets folder, right click, show and explore, and we will get our builds folder. And we can go to builds and run our exe. So as you can see, we got our game in full screen right here. This is the actual build, and we can just save our settings, stuff like that, and we can completely play this with a more playable thing. And everything works fine. And you can export this just like that, post this on the internet, send this to your friends. Hey, sorry for the sudden interruption. Something went wrong with the creation of the video, so my apologies for that. I just want to apologize for one thing, and that is the poor editing and speaking. I'm still kind of new to recording things. And it really takes more out of me than I like to show for making these videos. But I really want to help people get into game development and make it more accessible, just like Brackeys did. And I love doing that through making YouTube videos and through streaming. And I love hanging out with you guys. So I hope I don't sound like a broken record, but please do consider looking.
Nah, bro, the video's fine. It's good enough, honestly. The only thing that matters is what you teach, and you did it good.
The Twitch link in the description below. Come join the stream at some point and maybe consider following. So again, my apologies for the weird ending to the video. I'll leave any feedback down in the comment section. Really appreciate it a lot. Have a fantastic day.
Bro. Okay. Okay, let's see. Opening my game. Game capture. Any full screen application? Okay, it doesn't work. Give me a second, I have to add a new. New seed. Okay, no, that's... Oh, that's the right one. Put it here? Yeah, perfect. Then remove this one. Okay, there we go. This is my game, let's go! Bro, this is actually... Wait, you can't see it. Why can't you see it? Okay, give me a second. Properties. Same executable. You still can't see this. Why though? Oh, okay, okay. Now it works. Okay, now it works. But let me just quit out of it for a second and open it again. Made with Unity, let's go. There it is. I will play it one more time. Just play the exe and be proud of my work. It's a bit loud, but it's okay. Ah, okay. There it comes. Maybe this isn't completely intuitive, that there is a platform which comes to you, but it's good. And if I press quit, nothing happens. Oh, right, okay, I know why. I actually know why. This is because here I didn't... Wait, where is it? Panel, button. Yeah, I didn't wait. This was the start screen, end screen here. Panel button. I have to quit there, and now it should work. And now we can build it again. Select folder and build it. But now it should work. I'm not playing it again. For everyone who was watching, probably no one watched this complete thing. I'm actually really sure that no one watched the complete thing. But to everyone who maybe watches this in the VOD or watched like parts of it, thank you for watching. I really appreciate this. You can for sure give me some feedback. I would also appreciate that, and maybe I will stream again soon. Let's see. But for today,